Cabana Battle and Twins of Power Forward. And name's Paul Robertson. And then he did a system animation.
I tried to learn something. So what I've been doing is getting initial score just to set that order.
This one is to snap the picture, and then this one shuts it off. And this goes in.
Yeah, thank you. I appreciate it.
I think it's. Oh yeah, that long one is what you press.
And I got to say,
opening the screen because it won't be up there long enough for him to read the whole thing. It's single space typing.
and then I spent another month to get through here. So you'll be managing this work. I'd like to try one more month. You would have the Wi-Fi password handy.
Is there any way to
Well, this presentation here.
You gotta, do you have a sec to look at the positioning? Do you have a sec to look at the positioning of the camera? Because I know I'm not in the same position I was the last time.
Nobody cares. As long as you've got the information, you're fine.
It's another 5 weeks of psychotherapy.
I do feel like there's a focus, but I think, well,
Well, I turned the auto focus back on.
yeah, okay, that's fine.
Only because I moved it into the other room. And switch the input.
So is his thing on actually? Andy, his, microphone? Okay, just making sure. I've started recording. And we're live streaming just to have it. So now you know. Discuss anything internal that makes you nervous. Your face was glorious last time. That look on your face of like.
Bring the voice down.
I love that. I love that because you're the joyful guy. I love it when someone's like a super joyful person, like, yeah. Oh yeah, we can't really. Anyway, so yeah, let's go. Made me a happy boy. I always love. That's the fascinating part of the world.
Yeah, makes it interesting.
That's what this thing needs to be more interesting.
More interesting.
All right, so that's recording.
Steve, can you turn on your microphone?
Let's see where.
Yeah, right
Oh, is it hanging down?
there. Yeah, you just switch on the top.
Oh.
You're
Wait,
fine,
I'm.
you're good.
Yeah, that's fine. That's where that goes, and it'll know what to do.
Oh, okay.
It's just it needs to be on, or it won't record anything.
Right.
Testing? Oh, okay.
We're all fine. Thank you.
Oh, okay. Let's see, is it time? What's your time?
1 minute.
1 more minute? Okay.
I'm just going to do a little housekeeping before we start. We just have a couple announcements. One is that somebody had a copy of Wasteland that was sitting out in the common area. It wasn't part of the giveaway. It was waiting to get signed by Rebecca, and somebody probably thought it was part of the giveaway, so away it went. But the person would really like it back, so copy of Wasteland.
I couldn't tell if you meant you saw it there or if he had it. If he has it, yeah.
Ah, okay.
Okay. And then-
I mean, a bunch of us saw it by
Right, by the chair.
By the chair. And if someone did eventually, I think, pick it up in terms of like, hey, don't dial the guy, but it wasn't part of, like, I don't think anybody was treating it like it was a
No,
giveaway.
no, I wasn't sure. Hopefully, yeah.
So John is the one who needs it back if anybody has it. And then how we're going to do it this morning is we're going to have some breaks, but we have some 30-minute back-to-back sessions. So those we're not going to take a break between. So we're going to do this session, then take a break, 2 30 minutes, short break, 2 more 30 minutes, and that allowed us to squeeze more in. So without further ado, this is Steve Buggie doing firmware on EPROMs, a key to Apple II forever. Thanks, Steve.
Okay, hey, thanks. This is my 4th time at KansasFest. I came in '96, and then I came in 2013, 14, and now this year. The reason for that long gap in there was that I teach at a college, and when I came here in '96, I was scolded by the dean when I got back for canceling my last class in the summer session. But I've quit teaching summer school for the last 3 years, so this gives me a chance to come here. Before I actually start my presentation, I want to put this thing up. I appreciate that Sean Fahey and James Littlejohn have been doing this giveaway table. We even had that 2 years ago. And it got me thinking. Now I'm in perfect health, I think, but I am 68 years old. And at this age, anything can happen without warning. And it got me thinking, what's going to happen to all of my Apple stuff? About half of it is Apple II. The other half is vintage Mac. Macs from before 2000 mostly. I've only got one computer with a USB port in it. But I was did make me think what's going to happen when I am gone. And I've decided what's going to happen is that my wife and sons are going to haul everything to the dump. And so this is an effort to prevent that from happening. I wrote this thing last week, and basically it's telling my family to contact Sean Fahey or Tony Diaz, and they'll make arrangements to come to Gallup, New Mexico, where I live, and pick up everything. That the paper asks them to box everything up, make the phone call, tell them how many boxes there are so they can estimate what type of vehicle to take, and then they'll come and haul everything from there, and it'll be up on the giveaway table the following year, including my EPROM burners, I'm sure. So, when I presented this to my wife, she was cooperative about it, and I've also copied this to the 2 sons so that this will definitely happen. But I would suggest that anybody here who is 60 or older should maybe consider doing something similar, because the thrift shops won't even touch it. There's 0 chance of selling anything at a yard sale or a flea market stand. And so if the stuff got hauled here and put up on that table, whenever that might be, at least it's giving the kitten away to a good home. Okay. Question?
Just a comment. I understand that KansasFest is now a corporation. Are you still working on that?
Oh, tax deductible?
It's a 5. They're in the process, but
Oh, I'll mention that to my wife.
the other thing to remember is you may want to put the corporation in as the people to notify. Because not that I wish Sean or Tony an early demise, things happen, but a corporation can move on.
Oh, okay.
And then the corporation can decide.
It's only a first draft, so I can make these corrections. Like I don't have, let's see, I don't have James Littlejohn's phone number on the handout. Okay, on to the presentation. Okay, the topic is EPROMs. I actually had a pretty long description of it in the program. A little surprised the whole thing got printed. But anyway, the topic of EPROMs. EPROMs, it's an acronym abbreviation for erasable programmable read-only memory. The technology was developed by an Intel engineer in 1971, and it really hit its peak in the 80s. And so when EPROMs hit their peak, it's also, we'd have to say, the golden age of the Apple II computer, the 80s. I mean, the 2GS developed halfway through the decade. And EPROMs are just about everywhere, not just in the computers. And other computers have EPROMs too. When I first started burning EPROMs, I didn't know anywhere where I could buy them new, so I gathered them out of junk computers. And the older PCs always had at least 2 EPROMs in it. Your printer will have an EPROM in it. If you got an image writer 2 printer, it's got an EPROM, maybe even a second one. But anyway, lots of things have EPROMs in them. What they are, they're fat little chips. They fit in a wide socket, and they've got between 24 pins and 40 pins. Here's a couple of, well, here's a 40-pin EPROM. Most of them are 24 and 28. I don't believe there's any of them in the Apple II world that use 40 pins. And it's, oh, let's see, hold on. Here's a better picture of it, the cover picture on the book. You can see that there is a glass window. The glass window is actually made of quartz glass, which allows ultraviolet light to penetrate through freely. And inside is a little micro lattice work of, looks like woven metal in there. Now, there's somebody up on YouTube has a film through a microscope looking into that window. And I can't remember the exact title of his video, but I think if you just go to YouTube and type in microscope EPROM chip, you'll get to see it. But it's just fascinating what he shows with that microscope. It's like looking in a 3D thing with all these little metal lines. I have no idea how they make that. I mean, it definitely couldn't be done by hand. But anyway, the reason they have the window in there is that unlike other chips, and many of them in computers do not have the window. Let's see, I think that the 2GS ROMs don't have the window. It's probably the same underneath that black material that covers it. But what's special about the EPROM is that with the glass window, it's possible to erase the chip and rewrite fresh code into it. And the way that it's erased is with ultraviolet light. Let's see, I guess I could just show that now. I brought 2 EPROM erasers. This is one I bought on eBay from Hong Kong. It's commercially made. It's got a clock timer here, an on and off switch, and you put the chips in there. It only holds about 7 or 8 in there. And then you turn on the clock timer, and the clock timer will shut them off after the amount of time. This one I made about 15 years ago when I first started doing EPROMs. It's homemade, but it works. And you can see all of the chips in there. Let's see, they are stuck to the walls in there. It holds about 35 to 40 of them. And then this is ultraviolet light I got in a pet store, pet shop. It's called a germicidal UV light. It's very, very intense UV light. I mean, in the book here, the author's repeatedly warning, don't look at the light because it's much more intense than sunlight, and it can cause blindness if you're staring at it. But anyway, I put it in here. It's got a couple of nails here to anchor it. Let's see, I've got a, it's written here, not a handle, because if you lift by that, it's just going to take the bulbs up. And I put a Christmas tree bulb here so that you'll know when it's on. Because if I didn't have that, you'd end up looking down into it, and it's very intense and dangerous. Let's see, turn on the light switch. Light switch. Dang. Let's see, wait. Oh, there it is. Okay. There's the Christmas light. It just sort of sits up there so you know that it's on. And let's see, I'll just give, turn this over real briefly. You see the blue? Okay. So you know that it's on. Let's see, it takes it about, with the bulb size that I've got in there, it takes it about 1.5 to 2 hours, according to the book. I usually let it stay in maybe 2 to 3 hours, make sure that everything is erased. The book says that an EPROM can go through about 100 read and erase cycles, and after that it becomes inefficient. It doesn't record all of the bits anymore. So let's see. Yeah, every computer has some kind of EPROM, or at least its equivalent. I think some of the newer computers might have something called an EEPROM, which means electrically erasable, read-only memory. Yeah, they're found in a broad spectrum of equipment. I bought some EPROM chips to erase and rewrite with Apple II code. I bought them on eBay, and this set of chips were brand new. They all had code for Zeiss electronic microscopes, and I don't know what a Zeiss electronic microscope is, but knowing that it's Zeiss, I know it's very, very expensive. And I erased those. They work perfectly. Chips that were used in PCs can also be used in Apples. There's nothing special about the chips. They come in different sizes. The sizes range from 16K up to 512. At least 512 is the most that my EPROM burners can handle. In the 2C has a 256 kilobit chip in it. That's 32K bytes. The 2E has 3 ROM chips that can be upgraded to the enhancement standing, but they're all very small capacity chips in the 2E. The EPROM in the 2C, even though it's only just one EPROM, actually has greater capacity than all 3 of them in the Apple IIe. There's even a 4th one, which is not part of the enhancement kit for the 2E. It's the keyboard ROM. They don't include that in the enhancement kit because the keyboard ROM simply includes the characters on the keyboard for a particular country. So if you the computer sold here would have the USA keyboard on it. I once had an Apple II that I think somebody must have brought from Germany because it had all of the German punctuation marks, those little double periods above letters. And also the German keyboard has the X and the Y reversed. And when I was typing an important word like psychology, that's what I teach, I would always make a mistake. You know, all of the finger habits of hitting the Y would end up hitting the X. So different countries will have different keyboard ROMs. I don't know what's done for a keyboard ROM in the 2C. I know it's got a switch on the top panel for Dvorak. Is that how you pronounce it? Yeah. Dvorak keyboard, sort of a faster keyboard if you don't already have QWERTY habits in your fingers. But I'm sure there must be some way that the 2C can handle the keyboard pattern for other countries because it's been sold worldwide. I guess you just replaced the whole 256K ROM chip with it only having the one ROM chip in there. Now, what are the EPROMs used for? Well, most of all to hold the firmware, and the firmware is kind of standard code which is used in the same way every time. Things like the boot up sequence in any computer. And it's also, it's accessed almost instantaneously. Like when you turn on your computer and you see Apple IIc at the top edge of the screen, it's reading that directly off of the EPROM chip. And I've made the enhanced EPROM chips for the 2E and the 2C, and I've altered that code. I've put the word was 2C on some of them, the word enhanced up on the top. I even made an Obama 2C, but nobody's ordered that yet. Let's see, and then I also put Gallup NM. Nobody ever ordered that one either. I put Bug 2C. Nobody ordered that one either. But whatever can fit into an eight character space can be put as the opening screen. I suppose you could even put your own name. It's hard to imagine anybody's going to steal a 2C when they break into your house. They're going to steal the silverware first. They'll recognize 2C as being kind of an older thing. So the ROM has this basic firmware that is used the same way every time, but also it allows, because of the erasable feature, it means it can be upgraded when necessary. And I think that accounts for the popularity of it. There's been the one round of upgrades for the 2C and then the Apple IIe upgrade kit with 3 ROMs and the 6.5 CO2 processor. Another important thing for ROMs, though, is to enable the long-term survival of Apple computers. But I'll come back to that later. It's kind of the subtitle of my talk, The Key to Apple II Forever. What can be done to make sure that the computer is going to still be working 40 or 50 years into the future when you give it to your great-great-grandchildren? Let's see. Okay, I've mentioned about the erasing. Many, many warnings against looking into it. Now, how is the new code put into the blank chip? Okay. Oh, let's see. This just shows the 2E enhancement kits. 3 EPROMs, 2 of them have 28 pins, 1 has 24 pins, and then the 6.5 CO2, which came in the 2C. I believe even the original 2C had a 6.5 CO2. That's a booklet that Apple published on it. I also had a 4-page handout, so it comes to 24 pages altogether. It's the same thing. Okay, yeah, there they are again. That's the 2C chips over here, a 2-page set of instructions. For putting EPROMs into the 2C, in addition to just swapping the chip, you also have to bridge a little, I don't know what you call these doodads. They look like butterfly wings, but you bridge one of them with a drop of solder, and you cut another one with an X-Acto knife. Whoa, hey, wait, what happened? Okay. Oh, there's a nice view on the interior of the EPROM eraser. All those chips are waiting for their dose of ultraviolet. Another view of it with the commercially made one up at the top. Yeah, there it is. You can see even that ultraviolet comes through even on film. Okay. I packed in a hurry, and I forgot to. My favorite EPROM burner is so valuable to me, I wasn't even planning to bring it. Just show a picture, but I did plan to bring my other one, which is interface card, and I forgot to bring that. I did bring this thing, which I bought about a year ago, but the trouble is I still don't know how to use it. It's called the Shooter. And it, let's see, here's the 0 insertion for socket. So you move the lever and the thing lifts right out. And this prevents bending of any of the pins. Trouble is that I didn't get a manual with this. And I noticed it's got a serial port back here. And I don't have the software disk either. And so I think if any of you buy an EPROM burner, it's very, very important to get the instructions and also to get any software disk. But what's that? Have you got one too that you can't use? Well, even with the interface card, if I didn't have the instructions, I'd have no way to use it. Okay, I mean, it's not something you can just figure out with trial and error. But anyway, with this thing, at least the company is still in business. I'm going to contact them and see if I've already looked for a PDF file up on the web, and I can't find anything. Trouble is they didn't even put a model number on it. But some company called Logical Systems Incorporated, but I'm hoping that I'll be able to figure out how to use this. I've seen another one of these advertised on eBay that looked even more attractive. It had 2 sockets side by side, and I figured that you put the original in one socket and the blank in the other socket and hit a button, and it'll probably copy straight into it. This one only has 1 ZIF socket, so you'd have to remove it and put the blank in later. This one is the Apparat Prom Blaster. It's an Apple II interface card. Let's see, there is the ZIF socket. And some of the cards are not labeled very well, but if you see the ZIF socket in there, it's most likely an EPROM burner. This ZIF socket, this socket with a little lever on it, I can't think of any other interface card that's going to have use for that type of a chip holder. This one, the instructions are kind of badly written. I think this is written in the era of, or this came out in the era of the 2+. And to use the thing, you have to move little jumpers on it. My favorite, the Super EPROM burner, I'm going to give you the disk for it. The Super EPROM burner's got dip switches, and the instructions on setting the dip switches is right there on the card itself. But anyway, this thing does work, and I do have the disk for it and the manual. So if for any reason I lost or broke the Super EPROM burner, I would then switch to this one. Let's see, just another picture of the same one. Okay, that's the thing I just held up. Okay, yeah, like I don't know how to set those switches. It's a standalone programmer, but it does have the serial port, so I'm sure the serial port's got to connect into a computer. And I've got to write to the company, ask them, do you have any Macintosh software for this? The other shooters that I saw on eBay that sound like they're only set up for PC use. Okay, yeah, there's a view from the top. Another view of the thing. Okay, now this is the screen that you see with my favorite EPROM burner, the one called Super EPROM burner. Showing, let's see, here's a list of programs on it. Let's see, and I've put the disk, I mean, I've got enough, I made 25 copies of the disk, and so you'd be able to look all the way through it. But this disk includes the enhanced ROM code for the 2C, the enhanced and unenhanced ROM code for the 2E. It also includes, for the Mac 512, enhanced and unenhanced for the Laser 128. Wouldn't that be a rare thing to have, to enhance a Laser 128? Let's see, the disk is set up for DOS 3.3. Let's see, it's got this one. This version of it has the ROM code for my one that says the WAS2C. Let's see, just more. Okay, now the procedure to use the card is, first of all, you erase the chip with some kind of eraser like this. Then you put the chip in. Then you load through the software about this far. Then where it says command, you pick E. And what it does is it just checks that the EPROM is completely blank. Because, for instance, there are some corner spaces on my EPROM burner where it probably doesn't get a very strong ultraviolet light signal on it. And so it might only be partially erased. So if it shows any evidence of old code staying in it, you got to erase the thing again. So it only takes it about maybe 20 seconds to scroll through the code to see if any of the old stuff is still there. The software asks a number of questions when you set this up. First of all, it asks what slot is the card in. Secondly, it asks what is the size of the chip in terms of capacity. So you indicate whether it's 16K, 32K, 64, 128, 256, or 512. You have to indicate that. You also have to set the dip switches on the card itself for the capacity of the program, or pardon me, the capacity of the chip. Okay, so all those things have to be set up in advance. There's a lot of little steps in this, and so I tended to make these things in batches. So maybe if I'm making enhanced chips for the 2C, I make 25 in a batch. Let's see. So then you type in some code. Let's see, like fast burn and verify is what I usually do. And for fast burn and verify, I think the first part is what is the beginning of the code to put into the chip, the beginning of the code in the program, 0000. What's the end in the program, or pardon me, the end on the disk, and then where do you start on the chip itself? Okay. Now the reason why you have to specify where on the chip itself to start is that the 256K ROM, which the 2C uses, is relatively big for this card. I mean, I think the card is dated around 89 because it did come with the enhanced 2E ROMs in it, and so it couldn't be from the early 80s. But the thing is, if burning a 256K chip, you have to go through the procedure twice on each chip. First, you load and burn the first half of the code, and then you run it through again and burn the second half. If you actually were burning a 512K chip, you'd have to run it through 4 times. I think the Mac 512 uses that 512K ROM. And so once you've set up, answered all of the questions that it asks, then you tell it to burn. And there's a fast burn and a slow burn. A brand new EPROM will always work with the fast burn command. A fast burn means it does this in maybe 3 or 4 minutes. The slow burn, though, is sometimes needed if it gets stuck and gives a message, can't burn. Maybe if the chip has been through many, many cycles, it's likely to have to use a slow burn. Slow burn is about 15 minutes. Okay. And then it gives a signal at the end. It even compares every byte on the disk with every byte in the EPROM, and it'll usually say all bytes match, and that means that the thing will work. Okay, I think that's just oh, well, this shows all of the different sizes of the EPROMs from 16K bits to 512K bits. So you indicate which one. Which one I picked on this picture, number 7, is the 256K ROM. Oh, now there's my favorite. The reason I get a little bit emotional, this thing I couldn't find for about 10 years. I made a huge batch of 2C enhanced ROMs around 98. Somebody that I corresponded with on, well, this is way before eBay, Professor Hank Levinson of Rutgers University. I corresponded with him, and he made a trip out west, I think in the summer of 97 it was. I guess I was corresponding around 96 or 97. He made a trip out west. He stopped at my place, stayed for 3 days, showed me a lot of soldering techniques, but also showed me how to do the burning of the EPROMs. In fact, I got the card from him. And I don't know whether he ever attended KansasFest, but he was very knowledgeable, very patient as well. But anyway, he provided this card for me. Notice that when I say they're not labeled very well, it just says EPROM programmer, but the full name of it is the Super EPROM burner. Here are the dip switches down here, 10 of them. And then up here, it shows you how to set them for each size of ROM chip. And if you're doing it in a batch, of course, you don't have to keep resetting it. This is the ZIF socket, zero insertion force. Here's a little lever. You pull lever down and the chip just lifts out. Okay, and then to put the next one, you just push it in, tighten the lever, and it's ready to go on the next one. How accurate is the burning of the chips? Mostly, I'd say it's very accurate. I'd say about 10% of the time I have to redo the chip. And if you redo the chip, you got to start from the beginning. You erase it completely and go through the full burning sequence. There's no way to just identify a few bytes somewhere and make corrections on that. The whole thing has to be redone. How long do the chips last? Well, I made this big batch of them right after Hank Levinson visited. I think I had about 100 or maybe 110, and only one of them went bad as far as I know. I was selling these on CompSys Apple II Marketplace and on eBay, and only one person reported that it was bad. But if one does go bad, I would tell the person, mail it back to me, and I'll send them a replacement, and I erase the thing because they are reusable, thank goodness. But so anyway, out of about 110 made 15 years ago, only one of them was reported bad to me. It could be that others might have gone bad, and the person lost my address or was too shy to return it. But they do last a long time, but they don't last forever. You know, even floppy disks will go bad if you allow enough years, wouldn't you agree? I mean, if you had floppy disks and put them in storage somewhere and then took them out 50 years from now, I bet a lot of them are going to have errors on them just because deterioration in the media. My book here says that an EPROM will lose about 25% of its charge in 10 years. So now I had almost 99% preserved from 97, 98. So that was pretty good. But the thing is, are they going to last forever? And they won't. Any sudden failure of a piece of hardware is probably the result of deterioration of the EPROM. I had a printer go bad on me. It wasn't an Image Writer 2, some other kind of printer, but the thing was working perfectly and then it suddenly didn't work at all. And I figured it must be because the EPROM went bad in it. So this other theme I had for my talk, which is preserving data on EPROMs, contributes to Apple II forever. If you want to have your equipment last for many more years, let's say 30 or 40, maybe 50 more years, the best thing is to have backups on the EPROM. Either if there's any way that you can burn more EPROM chips, do it, or or maybe you can buy a replacement EPROM chip and then just put it away. That might help. Also, the EPROM code could be preserved on various media. I kind of think if you put the code on multiple different types of media, then you got a good chance that at least one version of it is going to be preserved. What I mean by that are things like floppy disks themselves. I mean, I've got these disks for giveaway at the end of the talk, and you'll have the enhanced 2E code, the enhanced 2C code, the laser 128 code, and the Mac 512 code just on this disk. Well, if it can be written to a disk, it can also be written to a CD. And one project I'm setting for myself, let's say for the next 6 months, is to try to go through all of the things that I have which have EPROM chips in them. I've got, let's see, what is a SCSI Revision C card at home. It's got the EPROM. I've already copied it off of the EPROM, but I have to check and put that code onto blank EPROMs and put it back into the card, make sure that it works. But I think that CDs are probably going to be the longest lasting form of media. Even they won't last forever. A librarian showed me an article in a library journal comparing the expected lifetimes of different types of media, and I forget the figure stated for CD-ROMs or CD-ROM disks, but it's not forever. It's longer than floppy disks, but it too will deteriorate. And then maybe even store things, if you have a thumb drive that you just use for storage, copy the code into there too, so that if needed in the future, you'd have some way to get to the code. But what you'd also have to have would be an EPROM burner. It's probably one of the rarer types of interface cards. How many here have an EPROM burner of any type? Oh, wow, actually more than I would have expected, about a third of you. Okay. Has anybody got this one here that I can't figure out how to work? I mean, I paid, I think, $80 for this, and I've not had any use of it at all. But
That company's still in business.
oh, well, thanks for telling me. The company closed business. Maybe that's why I got it for only $80.
They're still there. They're still there. They're still in business.
Wait, but they're not making these anymore?
Not that, I just looked it up, not that model, but they have a download section, you can say you're a customer, I bet they'll help you out.
Yeah.
Oh, okay, they might send me the manual and the disc,
Maybe
maybe.
the cable too. Maybe
Yeah. Well, it looks like a serial cable. I mean, I've got things that'll plug into that, but I mean, I just, I don't have any PCs. I mean, I hope they would have some kind of Mac version.
Probably it's just, it does automatically. It's a standalone.
The what now?
It's a standalone. So you press a button, it reads the chip. You press the second button, it writes the chip.
Oh, okay, we'll have to try.
So a manual probably would be just enough.
Okay. So anyway, the code should be preserved one way or another. I wouldn't be surprised that there might be websites up there that would have the ROM code for various things. You know, Apple's got a huge website, and they sort of support older stuff, maybe. Maybe they've got ROM code for things like the image writer printer.
A good tip probably to people is to put a sticker in front of the window. So
Cover the
that's
window
chip.
after you burn the chip.
Oh yeah, a big detail I totally forgot to say. You might say when you look at these things, you don't see the glass window. Why not? Well, this thing is sensitive to ultraviolet light, and so it's unlikely that you use your computer with the lid off outdoors. But the idea is you put on a little sticker over it. Even the book mentions a perfect thing would be these little write protect tabs that were used on 5 1/4-inch discs. Those are usually black, and then I put a typed label on top of that. But yeah, you have to protect it. Now, you might wonder how much sunlight would it take to damage the code on there. Well, it takes an awful lot of sunlight to erase it. What the book mentioned was that with a 4-watt bulb, that's the size in here, it can erase the chip in 1.5 to 2 hours. But it says if left out in sunlight, it would take 41 days of sunlight. And if we were exposed to fluorescent light, it would take about 41 days. So it's not extremely sensitive to sunlight, but you just don't want to lose even 1% of the code because that's going to crash everything.
1 bit is enough.
Oh yeah, crash 1 bit, sure, yeah. I mean, actually, when I'm inserting these chips into their sockets, if 1 pin gets bent, it's gibberish on the screen. Yeah, I mean, there's no tolerance for error on that. So anyway, I think that for keeping Apple IIs going into, let's say, 2050 and beyond, people should try to preserve the code on these chips and also try to get an EPROM burner if you ever see one. Now, this computer wheel that I talked about at the very beginning, this card is going to be part of the boxes and boxes of things that are shipped over. And I figure in who knows how many years, maybe 10 years, maybe, maybe 20 years, that card is going to end up on the giveaway table. And but the problem is that if you happen to see this card and always look for the ZIF socket to identify it, the problem is I doubt that the software disk is going to be rubber banded to the card. I mean, when my wife throws everything in the box, my disks are one place and the card is somewhere else. So what I'm hoping is when I pass out these cards of the software, put it somewhere where you know you'll be able to get it in indefinite years forward, so that if you happen to be the lucky one to dig through the pile and find the EPROM burner there, you can say, aha, I've already got the software for it. And there are some instructions right on the disk itself. They're not very well written instructions. I mean, I still had to do some trial and error flipping of, or, doing different things, but at least it was enough to get the thing working. So it's just one page of instructions, which is in a text file right on the disk. Okay.
Can you do a copy of and put it on Azimuth?
Can I what?
Can you do this copy and put it on Azimuth, an image file as amount?
Oh, put the image file. Well, let's see. I'm not sure how to create an image file, but I mean, I've got anybody can do it from this disk, and then maybe put it up at some website. But so that this thing is still on, blinding me. Now, let's see. The final topic is what about the 2GS ROM? Could you make duplicates of 2GS ROM? First of all, I don't think you can turn ROM 1 into a ROM 3 just by putting in a different ROM chip.
That is correct, but you can turn a ROM 0 into a ROM 1.
Oh, really? Just with the
Yes.
ROM chip?
Yes.
Okay.
Early ROM 0s also need a video generator upgrade, but I mean, it'll work fine without it. You just
Okay.
flickering on black
Well,
and white screen.
at last year's giveaway table, I actually salvaged a junk 2GS. I think it had been left out in the rain. Everything's rusted in there. But I salvaged the chip and I swapped the ROM chip into one of my other 2GSs, and the ROM chip still worked. So,
Do you still have that one? I need a ROM 1 chip.
well, I'm keeping it as a spare. I mean, I'm not sure that I'm not sure that I can burn that type. And now I looked up in the technical reference guide for the 2GS, and it says that it's a 128K ROM. Now that must be 128 bytes, not bits.
It is.
Yeah, because these things are all measuring bits, and then bytes are 8 times bigger. Because certainly the 2GS has got to have a bigger ROM than 2C.
Oh, yeah, I know for a fact. I was researching.
It is bytes.
128
Yeah.
bytes.
So the 128 is just beyond the capacity of this one. This one goes up to 512 only. 512 divided by 8, what's that, 64 bytes? Okay, so it wouldn't be possible to burn the 2GS ROM with this, and I don't know how much the ROM 3 would take, but one more thing, I was going to say that I don't think you could turn a ROM 1 into a ROM 3 just by changing, because there's hardware differences between the ROM 1 and the ROM 3. There's a megabyte of RAM on the board on the ROM 3 and less on the ROM 1. So where the hardware is actually wired differently, I think that you'd have to replace it with the ROM 3.
The
Yeah.
chip is a 27-1000.
A what?
The chip is a 27-1000.
27-1000, yeah. Oh, so if this one went just one step further, maybe.
Yeah.
Well, I was really impressed though that this came with the enhanced ROM for the 2E built into the card. And so that suggests to me that it's probably, this card is probably from around 86 or 87 maybe. Okay, let's see. Question? Oh, 2 minutes. Okay, is there any questions? Okay, yeah.
There's a number of straight proms in 2E. Can you replace those with a EPROM?
The straight proms, you mean with that doesn't have the window? Yeah, I think you can. Yeah, a lot of the factory provided chips don't have the window. I mean, the great thing about the window is you can redo the code. But I think that underneath that opaque top, it's probably the same kind of circuitry inside. It's just that it can't be modified. But yeah, I'm pretty sure that, well, I mean, for instance, the 2C original ROM chip doesn't have any window, but yet these burned EPROMs work perfectly in it. Okay, let's see. So I'm finished. I do have copies of my Apple computer will. None of you are named in it. Let's see. And I'm not passing this over to any lawyer or anything. I don't want to have a lawyer badgering my wife. Have you shipped that Apple II junk yet? No, I mean, this is just an informal thing. I'm counting on their good graces to carry it out. Also, I have these discs here, and I hope that you might pick up the copy of the disk. It's got the code for the 2E and the 2C, plus those other things like when you might find a laser 128 at a yard sale or something, and you can upgrade its ROM. Okay, so these things are for giveaway, and thanks very much for your attention. I've got souvenir EPROMs up here that don't work on any Apple II. They're either too many legs on them or just incompatible numbers on them. You could make jewelry out of it, maybe drill a hole in it and carry it around your neck.
Okay, the next session is at 10 o'clock, so stretch break. We'll be having Quinn Dunki doing a session on mouse programming, followed by the last session of the morning at 10:45 is Pascal by Jay Graham.
Oh, I didn't run overtime.
You're perfect.
Okay, did you remember to do the pictures?
I did do
Oh,
some
good.
pictures, and I also took some on my phone.
Oh, good.
From some other angles.
Well, let's see, I don't know how to transfer. Oh, I don't know how to transfer. I could email phone. Oh, okay. I'm sure there's some way I can.
Yeah.
Yeah.
Something I want to tell you, I don't know if you've ever seen it. There is a new they're saying it should be guaranteed for 1,000 years.
Oh, where did I last hear that?
Well, I
Hitler
know,
had the
yeah,
1,000-year right?
No, it's a different physical.
Oh, really?
Yeah, no, I hear what you're saying. I know exactly.
Under normal conditions, standing up in the box.
How long is this company going to be around?
I don't know, but if your product works, they've got this business.
What kind of materials?
Well, the articles that were in the popular magazines. They'll tell you, say, right, this is the stove.
Yeah, sounds like this car.
Well, yeah, it's a BB.
Oh, well, let's see. What's the name of it?
M-DIS, M-DIS.
Let me put a note on that.
If you Google 1,000 year blank DVD, you'll find it.
Wait, let me write that on my notes. Yeah, who made this board? I'm not even sure. I've got I've misplaced the paper manual. What I depended on was the manual that's on the software disk. Oh, it might say on the software disk. Did you get a copy? Yeah, I bet there's probably a heading that might tell you both of those cards were absolutely. Wait, let's see.
Verbals and archives for people wanting to archive information. If it was last 50 years, somebody has to I remember there was
There's something on the Viking space ship, like a recording, gold ladder or something. Yeah, it's supposed to. It's out in interstellar space. Oh yeah, I do. I've got diagnostic, master diagnostic. And I've also got the standard Apple. Yeah, I actually, I think we need to, well, it's written on yes. So you can just copy yes to the CD.
I'd love to get access to I don't need
Oh, yeah, yeah, I don't think there's any way to use code like the one in the image writer guy. There's, I don't know if there's any way where you can get like like with the 2C, there's you type something in the monitor or something, and whatever it comes out with, it's only, I don't know if that's possible. But the image writer does have self.
Oh, no problem.
There might be some. Yeah, I wonder what this 1,000-year distance.
They all work. Even.
I think they guarantee it's 25. Yeah, 25 is, yeah, I mean,
I will help
when I say give your Apple to your great-great-grandchildren. So far,
It's like lighter.
It's all our fault.
Even though it's the same manufacturer, some of them are the same. This yeah, and that's what we're into a little bit of alcohol.
Really, the best for my sleep.
yeah, I'll leave them up there.
I have all my stuff, so I'm here on Saturday night. Yes. And this is on the.
Oh.
Yeah. That'll
look like there was
Oh, yeah, not on the floor. Yeah, I dropped the list on the floor and stepped on it all of
yeah, that one just hooks on and then they have to.
Was this one yours? Oh, wait, I think oh, good. Okay, thanks for, yeah.
All right.
You want to use? Sure, yeah. So, I assume I can hook this guy up with the projector as well? Yes. Yes. You can do like a, it doesn't have to be simultaneous necessarily. I guess it can't be because we only have one projector.
This is work, yeah.
The one that I'm talking about, oh, virtual floppy drive. See, I'm afraid I'll get them mixed up with Yeah, what, I'm in room 236, just spring by there.
When will you be there? Presentations you going to be at?
Yeah, it'd be great.
That's the last one.
Yeah.
Yeah, I think I'll go up to the room as well.
Okay.
And figure about 2 hours, but I'll just get them going before lunch, and 2 hours later they'll be ready.
Yeah, that'd be
So you got a burner that can do the bigger size?
Well, Dagen's bringing his, it's a modern burner, we're not 100% sure.
Oh, yeah, I think that's creative the direction.
Yeah.
It's good to go.
So there's a, like, well, probably that was a giant size. No, the only one I brought was that, and I don't know how to work it.
Connection's bad.
It's in there, it's that thing that's kind of sort of. Yeah,
I'm not sure it knows there's a second display. Give it another shot here. It's not acting like a display.
Oh, yeah.
This one right here? Sure can.
Can you just, oh, never mind.
Got another one.
Really get a memory card to work.
Oh, really? Oh, good.
The resolution is so low, I can't even get to the control to turn off mirroring.
If you click on 10, can you click on 10?
Oh, yeah. There we go. That's better.
You know, when you live in
Jake can help switch the source.
Machine, by the time he gets it over, I have, you know, 3 or 4 sets of chips that are my life. 2 weeks, they play that one. Still got a couple of 3 miles an hour contract. And I've got some original. Oh, yeah.
Well, no, but some.
Oh, the Epson switch back.
Yeah, I don't have.
Yeah, it's fine for a minute.
Okay.
Yeah.
And we have a mic if you're willing to.
Yes, I would like one. Yelling into a room.
It's off for the moment. This always going on too.
We're setting up. May I give a plug for Hackfest?
Absolutely.
Check.
But I know they're all.
Who's entering Hackfest? Hackfest? Hackfest is the annual programming competition at KansasFest. Your goal is to write some original software for the Apple II entirely at KansasFest in the 3 or 4 days or so. Hackfest is underway right now. Our judges are Quinn, Michael Mann, and James Littlejohn. So if you're entering, make sure you let one of those people know. Otherwise, they won't be able to come by and judge the awesomeness of your work. The judging criteria is based on whatever the judges, whatever impresses the judges. So it might be it's clever, it's cool, a technical achievement. It might be that you learn something that a $50 bill might work too. Usually they're looking for some aspect of your entry that simply impresses them. So it doesn't have to be complete. It doesn't have to be working. It just needs to impress them. So
$50 impresses me.
okay, there you go.
Throwing that out.
Take a look at kansasfest.org/hackfest for rules, ideas, past entries. Any questions? Okay, look forward to seeing your entries.
Question way in the back.
Oh, yes, sir.
I have a really interesting, fun idea, but none of the skill necessary to execute it. So if somebody is looking for something to do or a challenge, talk to me, and I've got some fun stuff that maybe you can work on, and I can totally take credit for.
Team projects are allowed. Yes, sir.
Was that 50 Canadian dollars or US dollars?
Either's fine, honestly.
You should probably have
Euros.
50 Canadian and 50 euros and 50 US just to be safe.
Yeah, it's probably wise.
I'll take 80 Australian.
Yeah.
When's the last moment to decide you're going to do it?
Whenever you want. Judging ends on Saturday around noon. So you could decide at 11:50 that you want to do it, but probably the sooner the better.
When did it start?
It started 7 a.m. yesterday. Any more questions? Thank you.
I'd like to welcome you all to our next session. This is mouse programming with Quinn Dunki. Thanks, Quinn.
How's my mic? Everyone hear me okay? Yeah, in the back? All right. All right. Yeah, welcome to programming this guy right here. This is 2-bit programming of 8-bit mice, mastering your rodent. That is the first of many terrible, terrible mouse puns that will be in this presentation, so fair warning. So those of you who are bored already, all of the code that I'm going to be talking about is on GitHub, so feel free to grab that and start browsing through it while I talk. I'll give you a minute to do that. So the 8-bit Apple II mouse is kind of a funny thing. It's kind of the tail end of an old technology and the beginning of a new technology, and that makes it a very strange beast to program. The architecture was never intended for a mouse, obviously, and it was never planned for one, so they really kind of shoehorned it in wherever they could. I'm going to change this slide. Does anyone else need to grab it? Going once? All right. I'll just do a little jig. So I'm also, fair warning, I'm terribly unprepared for this talk, but it's only 30 minutes long. I'm pretty sure I can fake my way through 30 minutes of anything, except possibly skydiving or scuba diving or really any kind of diving. But well, 30 minutes, you know, you got to wash your hands, you got to do the prep. I can probably do 30 minutes of that. All right. Once, twice. All right. I guess the aspect on that is a little crazy. You'll also note that all of my slides are in both 40-column text and 80-column text, so take that, French touch. All right, here we go. That QR code will be again at the end if you want to grab it. So we're searching for modernity here. Steve Jobs perhaps apocryphally said when the 2C was launched that we are not shipping a computer in 1984 without a mouse. And that no doubt made the engineers break out in cold sweats because the architecture, as I said, was not intended for it at all. So they made room for all of this fancy new firmware and structures required to support the mouse wherever they could, and wherever they could changed a lot. So we need firmware for this mouse, so where do you put it? Screen holes are always nice. We've always got those, right? And some of those screen holes are read-only, but that's all right. We've got the slot firmware areas, so we can use those. The 2C calls them ports, as you know, but yeah, there's those little blocks of memory in the hardware page reserved for each of the expansion slots. So we can overlay some of that. And well, actually, we're going to need to use all of the slot firmware areas. So this is where it gets pretty interesting. So now the other problem here is that, again, since we're bridging old technology and new, the old way to do stuff like this is just ROM entry points, right? You got some ROM setups, some registers, whatever you JSR into it, magic happens. The new way to do something like that is with an API. And this mouse firmware kind of tries to have a foot in both worlds, especially since there isn't really enough room for any one place in the ROM for this firmware to live. So they moved it around a lot, and as soon as you're moving code, you're talking about indirection. Yeah, old school ROM entry points are not going to work. Who knows which ROM entry point that is? Going once, going twice. It's C out. Thank you very much. Dagen, of course, knew that one. So yeah, we need to do some kind of modern style API calls because the code moves around. And so, of course, whenever you're talking about moving code, you need to do indirection in the name of abstraction, which is a great name for a band. And just to make things even more interesting, this technology also spans generations of machines. The mouse was introduced with the 2E enhanced, or at least it was retconned to the 2E enhanced with the Apple mouse card. And the 2E and the 2C, the 2E enhanced and the 2C are a lot more different than you might realize. And nowhere is that more true than the mouse. So writing one mouse driver to support 2E enhanced and the 2C and the 2C plus and all the ROM versions of the 2C turns out to be fairly difficult. So yeah, the solution involves a lot of self-modifying code, actually, which, of course, as we all know, self-modifying code is the source of and solution to all problems. And we're not done yet because so as you may know, the 2C had several ROM versions, and the mouse firmware moved in every single version of the 2C ROM. So there's about 6 different cases. And there's many other pain points here that we'll get to. So there's lots of self-modifying code ahead. Luckily, I've solved most of those problems for you, so you won't have to. The goal here is at the end of this, so at that QR code I showed at the beginning, there is a blob of assembly that will support the mouse on every 8-bit that can support it with one known bug that I'll get to. So you should be able to at least use that for your own stuff. And that code's also incorporated into the GUI talk that I'm giving tomorrow. So more on that later. So yeah, lots of self-modifying code. All right, so step 1 when talking to the mouse is we have to find it. So normally when you go looking for a mouse, you're going to search for pellets in your house. Luckily, we don't have to do that. It only gets worse, people. It really does. So the way you do this is on the Apple IIe is you have to scan for the mouse, for the Apple mouse card. And of course, it can be in any slot. And the official way to do this is to search all of the slot firmware areas for that byte pattern. That magic string of 5 bytes is how you identify an Apple mouse card. And yes, that is seriously the way you're supposed to do it. That's in the documentation. And then on the Apple IIc, where everything's different, amazingly, that actually still works. There are several versions, as I said, of the 2C ROM, and the Apple mouse firmware lived in several different places in each of those ROM versions, but this search will actually still work. And what you end up with is a virtual slot number, or what the 2C calls a port number, where you can pretend that that firmware exists if it was a card in a slot, which of course it's not really. All right, so now now that we found this mouse, how do we talk to it? Well, by squeaking. I know. See, I warned you. It's only going to get worse. So here's where we get into the weirdness of trying to indirect to find this code. There's mouse routines to initialize the mouse and read the mouse and check the status of it, various other things. each of these mouse routines has an index. So you find this code by going to your hardware page, some section of that hardware page, and then adding an offset to that to get your for your routine index, and that is then an indirect jump point. And the x in that equation is that's actually an error in my slide. The x, oh no, it's not actually. The x in that math is the slot or port number that we found earlier. And so then before you actually make the indirect jump to that, you have to load the X register with the routine number and the Y register with the slot number. So even though we just calculated where to jump to, you have to then also tell the firmware where it is. For some reason, it doesn't know. So you have to calculate the routine number and the slot number, and then load the registers with those again, and then indirectly jump off of that. So the firmware actually gives you, this firmware math gives you a pointer to where the code actually is. I know. And amazingly, despite all this, the mouse is all interrupt driven. And despite that, it's not interrupt safe. So yeah, I know. So you have to disable interrupts and re-enable them between any mouse call. And you can't do anything interrupt related inside mouse calls. So yeah, it's all very exciting. You spend a lot of time rebooting when you're getting this code to work. A lot of time rebooting. All right, so we know how to find the mouse. We know how to talk to the mouse. We need to catch mouse events, which we do with a mouse trap. The mouse has multiple modes that you can use it in. There's what they call a passive mode, which is where you just pull the mouse and check its status frequently. And you can find, using the mouse firmware, what happens when you make mouse firmware calls is it grabs the state of the mouse and dumps it into random screen holes that happen to be available. And some of those screen holes are read-write and some of them are read-only, and none of them are interrupt safe. The awesome thing is that some of them are shared by the disk controller. So if your code is not exactly right, your disk drive stops working, and it might ruin whatever disk is in the drive. It's super, super fun. Ask me how I know. So yeah, one way to use the mouse is with passive mode. Passive mode is fairly risky because you have to dance around the disk controller and be careful not to do anything at the same time. And it's also a pain in the butt because you have to scan the mouse really quickly to figure out what it's doing and have a nice, fluid motion. So I don't actually recommend that way. The mouse also has a number of interrupt modes, which I think are better because the mouse is fundamentally an asynchronous thing. It's supposed to be operating all the time independent of whatever the application is doing, which is a really alien concept for an 8-bit Apple II, which is part of what makes this difficult. So interrupts are your friend. And on the 2C, there are actually interrupts anyway. Even in passive mode, the mouse is being driven off a vertical blank interrupt, which the 2E doesn't have. But so it's using interrupts anyway. The other advantage to using interrupts is that then your mouse is independent of your clock speed, which of course on the 2C Plus is pretty important. So the code that I've included here in this talk is using what's called combined interrupt mode, which generates interrupts anytime the mouse moves and anytime the mouse button goes down. It does not generate an interrupt when the mouse button goes up, which I will get to. That turns out to be a hard problem to solve. All right, so I alluded earlier to those firmware routines that are going to tell us all this great stuff. The primary one is serve mouse, and once you've initialized the mouse, then basically you just set up your interrupt handler on that combined interrupt I mentioned, and inside that interrupt handler you just call serve mouse, and that gives you X and Y position values for the mouse between 0 and 1023. Those are not particularly useful values because you're going to be using the mouse either in probably 80-column text mode or in high-res graphics mode. So yeah, neither of those are convenient. Luckily, the mouse does have the ability to clamp. So you might think you should clamp to whatever screen resolution you're going to be using for your pointer. What's actually better is to clamp to a value that is easily scaled to the resolution you want, because you want to maximize the precision of your mouse. So if you, let's say you're using the 40 column text screen, if you clamp your mouse to 40, then the range of mouse motion that moves your pointer extreme to extreme is going to be about this much. So you kind of want, in physical space, you want kind of 6-8 inches of physical mouse movement to map to your range on the screen. So that's where you kind of have to balance the clamping with the with scaling. So what I found works the best is you set your clamping to be a convenient power of 2 from what your ultimate resolution is going to be, which all the assembly programmers know why that's a good idea, but just in case, I'm going to show you anyway. So for example, for an 80 column text display, if you want 80 X range, for example, you can clamp to 640 and then shift that value down 3 times. So that's a 16-bit downshift. The numbers shown there are hard-coded screen holes. You would never actually do it that way, but that's just to illustrate. So I mentioned that serve mouse routine. I just called it serve mouse. In the documentation, there's index values for all of these mouse routines. And in the code that I provided you, there's shortcuts. So all of that weird abstraction I talked about before, calculating the firmware number and finding the slot and all that, I set up a collection of macros and routines to do all that for you. So there's a macro called call mouse, and you just have to call mouse, and it'll do all of that craziness for you. But it's good to know how it works, because there's probably bugs in it because I wrote it. So when it doesn't work, you'll know how to debug it. All right, so that's kind of the broad strokes. The devil is, of course, in the details, as is often the case. So let's compare apples to apples. Thank you. I'll be here all week. No, seriously, I leave on Sunday. So the simpler case of the two is the Apple II Enhanced with an Apple mouse card. There were other mouse cards that were made. I presume that they're all compatible with the Apple mouse card. Otherwise, why would they make them? Yeah. Yes. Assumptions are wonderful. So the II Enhanced Apple mouse card has its own 6502 on the card, and it interrupts the main CPU only when mouse state data changes. So if the mouse moves or if the button goes down, and it samples the mouse at 60 hertz, which is pretty great. Honestly, the II Enhanced with the Apple mouse card is really, really nice. On the 2C, they decided to, on the 2C and the 2C Plus, they decided to do everything on the main CPU, because of course there's no room for an extra 6502 in there. So the main CPU does everything. The 2C has vertical blank interrupts for exactly this reason, not because they want you to write demos or cooler games. They did it only to support the mouse, and because they didn't want to bog down the main CPU with servicing the mouse all the time, it only samples at 30 hertz. Which means all of your math that I talked about, scaling and clamping and all that, is all different on the 2C. So you have to do both cases. And the worst part is back here on the 2E, that last bullet point, button interrupts on the 2E only occur when the mouse goes down, which is great. That's what you want. You only care, you want to catch that falling edge of the mouse state, or that rising edge, really, of the mouse state. The 2C, however, interrupts at 30 hertz as long as the mouse button is down, which is incredibly annoying, but that's what it does. So this creates a big known issue with writing a mouse driver. So the goal, of course, is to have a mouse driver that works across the board, right? You don't want to have a completely different driver for the 2C. That may, in fact, be necessary, as we'll see. So this creates a known issue with the driver that I've supplied, which is that, so right now the way it's written is you cannot, if you click twice without moving the mouse between clicks, that second click actually won't be detected, which is slightly less annoying than it sounds when you're using a mouse application. You tend to be moving the mouse all the time, but it is slightly annoying. It does mean, for example, you can't support double clicking, which, sort of annoying, but it makes the mouse driver about half the size it would otherwise have to be for that tiny little conceit. And of course, the reason for that is that there is no button up interrupt, which is what we need to know. So, the way it works is that on the 2E Enhanced, as I say, it's easy because as soon as that button goes down, you just assume the button went up again immediately after and forget about it. On the 2C, you can't do that because otherwise if you try to pretend the button went up again, if the user's holding the button down, you get constant interrupts until they let go. And so it's going to look like they're mashing the mouse button. And so what you need to know is when are interrupts about to stop, right? Which you can't know. So the code that I've supplied has a flag that tracks whether the code thinks the button is down or not. Problem is, of course, there's no way to clear that flag because the flag would have to be cleared by the absence of an interrupt. And so I do that by clearing the flag when the mouse moves, because that's also an interrupt I get. The nicer way to do that is probably to use a vertical blank interrupt as a separate source of interrupts, and that can watch for the mouse button going up and clear all your flags and things. That's not yet implemented in the code that I provided because that's a lot more work. I tried to make it work last night and obviously failed. So you know, this code's all on GitHub. Maybe some of you can fix that problem. There is the way the documentation. So the other fun thing about programming the mouse on this machine is that the documentation is basically all wrong. I found several sources of mouse documentation, including the 2C technical reference manual, the 2C the second edition 2C technical reference manual, the 2E technical reference manual. There's 3 Apple tech notes on the interrupt environment, how that is affected by the mouse, and differences between the 2E and 2C mice, and general programming of mice, those 3 Apple tech notes. All of those sources disagree on a number of key points. The general consensus about how you're supposed to handle this mouse button up problem on the 2C is that there's 2 flags in the status register that you get with the interrupt. There's a bit set if the button is currently down, and there's a second bit set if the button is currently down and was already down last frame. So that should allow you, in theory, to catch that rising edge of the mouse button, which is what you want. As far as I can tell, that flag just doesn't work. So I actually spoke to Becky yesterday about this, and apparently she said that this was typically solved back in the day with a vertical blank kind of watchdog, as I was just describing. So as much of a hassle as that is, that may be the only solution. Maybe it's a bug in the firmware, I don't know, but that flag just doesn't appear to work. So yeah, so either we have to play nice with the user on the 2E only, have a nice, support double clicking and all that, or be consistent in the code and make the code, much tidier, or have a much, bigger, messier driver that handles both. So those are kind of our Sophie's choices. And as far as I know, all of this is not 2GS compatible. I did give it a try in Sweet 16 and it doesn't work, but it is harmless as far as I can tell. Mostly harmless. I mean, you never know with interrupt code. Maybe it stepped on, I don't know, Apple Talk or something. I don't know. But yeah, the code that I provided on Sweet 16 will start up and run the interrupts, and you can quit, and it disables interrupts. Nothing crashes, but it doesn't seem to work. The documentation claims if you do all of this properly, as I've demonstrated with all the firmware calls and the indirection and all that, that 2GS will work. It does appear to be wrong about that as well, so who knows. The firmware, in fact, supports 2 mouse buttons, two mouse buttons. Because the 2GS supports 2 mouse buttons. So the idea is you're supposed to be able to write 1 mouse driver that works on the 8 and the 16 bits. Because of course there's no 2 mouse button support on the 8-bit mouse. There isn't even a pin for it on the port. But they support it in the firmware so that your code would work on the 2GS, and it does not. So this is clearly all an afterthought, as I said. So I have a very brief, very lame little demo. Can we switch the projector? Okay. Yes, the beep is weird. There it is. So this disk image is also in that distribution that I supplied. So got nothing on it except this little mouse demo. And this is just, so the code that I provided has mouse.s and mousedemo.s. Mouse.s is the driver, and then mousedemo.s just shows you how to use it, and it builds into this. It just shows you the current XY position of the mouse, and then so I've scaled it to an 80 column display. So the upper left is going to be 0, 0, and bottom right is going to be 4F17, which is 79, 23. And then mouse down events are detected with a little bang. So you'll notice I'm sneakily moving the mouse while I do this, because if I remain motionless, subsequent clicks are not detected. So that's, yeah, you know, you get a little shaky and the problem fixes itself. So, so if you get any support calls for your software about this bug, just tell your users to wait a few years and they won't notice it anymore. So yeah, so hopefully those of you who might be inclined to actually try this have looked at the code, and so you might have questions, possibly. Yes, Ivan.
If the 2E can only detect the mouse button down, does that mean it's not possible to implement drag and drop?
Yes, that is a very astute question. If you're in Hackfest, you already win because of that question. So, and that is likely why that they did that in the 2C. So yeah, it is not possible to detect, not easily possible at least, to detect dragging on the 2E because yeah, that it does not recognize that the mouse button is down. It's even worse than that. The mouse can only generate one interrupt source at a time. So if you're holding down the button, movement is actually ignored. So yeah, which I think I can actually demonstrate that. It may actually, because this is the 2C, it may, yeah, see that? Just hold down the button and you stop getting interrupts for movement. So yeah, so again, that's probably why on the 2C, if you were able to write a mouse driver dedicated to the 2C, it would be much, much better because you've got those continuous 60 hertz interrupts from the vertical blank, and you could just, you know, handle all the mouse state yourself, and it would be so much better. But it would be a completely separate driver than one that works on the 2E. And so, but yeah, the short answer is that's probably why the 2C generates those continuous interrupts while the button is down, because then you can do dragging and other such things. But yeah, it makes the driver much more difficult to write.
Is there a potential clever way to get around that on the 2?
I think there probably is. One way to do it would be to use passive mode, where you just pull the mouse yourself, depending, so that, you know, wherever you are, if it's, let's say you're writing a desktop application, you're going to have an event loop, let's say, and just make sure you're in some tight main loop, just pulling the mouse a lot, and then it's kind of like an interrupt. So then again, you can just update the mouse, track the state yourself. That would be one way to do it. So the 2E mouse card is generating state changes all the time, and it's filling in the screen holes for you. So you can just read the screen holes directly on the 2E and just kind of pretend that you're getting interrupts. So that might be a way to do it. Aside from that, yeah, I don't really know of a nice way to do it. It's entirely interrupt driven on the 2E though. Other questions?
So how did people who wanted to support the mouse do that? I mean, did they have to essentially go through the same pain that you did to support all these buttons?
Yeah, I suspect that, like, so there are applications like GEOS, for example, that have great mouse support. I suspect they have completely different drivers for at least the 2E and the 2C, possibly different versions of the 2C as well. Yeah, I think that would be the absolute best way to do it. I tried to do it as simply as possible and as little code as possible. So, I mean, the driver that I supplied it's like 60 lines of assembly or something and does 98% of the solution. That other 2% is going to, you know, quadruple the size of the code to fix those couple of little things. So that's the balance that I struck, or the compromise. But yeah, I suspect that's how they're doing it. It's just a lot more code. Because and the other good example is, you know, Bill Budge's mouse paint also, as far as I can tell, has no idiosyncrasies in the mouse. Just works great. So I suspect he also probably did something like that. And it would, you know, and it probably took him weeks to do this instead of days, because I had Virtual 2, which reboots quickly, and, you know, all of that. So trying to build this on real hardware would have been a pain in the ass. If only because you would have to back up all your disks constantly, because every time you mess up the screen holes, you trash whatever disk was in the drive. So it's awesome. Other questions? Yeah.
What's the size of the actual final binary?
Let's see, on the mouse driver.
You said like 3 blocks on your demo.
Yeah, it's small. The GUI library that I'm showing tomorrow includes this driver, and that whole thing is only 6K. So the mouse driver is probably, I don't know, 500-600 bytes.
It would probably fit at 300, maybe. It's also, I mean, I haven't made any effort to make that code smaller either, so I bet it's possible to do a mouse driver that sits at 300, and then you wouldn't even know it was there. Let's see. The other thing I wanted to mention is the mouse driver that I'm supplying also plays nice with ProDOS, as you can see here. Oh, look at that, we're back in ProDOS. Oh, look at that, still works. That's also fairly non-trivial. So to do all of this stuff sort of right, you have to register and unregister yourself with ProDOS's interrupt system, and you have to block out the memory where the driver lives so that ProDOS doesn't use it for disk buffers and things. So the driver demo that I supplied to you does the interrupt stuff properly. It does not do the memory stuff, because the idea is you'll just include that driver with your own code. The library that I'm going to supply tomorrow does do all of the memory footprint stuff as well. So that's also a lot of work to do all that properly. But again, if you didn't care about that, if you were doing just a disk boot one-off thing, you could just jam this driver at 300 and not care. Yes.
How have you found the support in the emulators for emulated mouse?
Yeah, good question. So Virtual 2, shockingly, not shockingly, is excellent. Yeah, their mouse support is so good that, yeah, it detects when the pointer is inside the Virtual 2 window, and it does all the right things. And then when the pointer leaves, you stop getting the interrupts. Like it does everything perfectly, which was really valuable for debugging, because I could move the pointer in and out of the Virtual 2 window and control when I was getting interrupts and stuff. It was brilliant. The only downside is that, as far as I can tell, there's no way to emulate the 2C. So when it came to add 2C support, I was literally, moving the code back and forth constantly for every iteration, which was incredibly tiresome, especially, with this button up bug that I was talking about, which occurs on the 2C only. It's part of the reason why I couldn't fix it last night, because the iteration time is brutal. So yeah, if anyone knows of a way to emulate the 2C, I would love to hear it.
Oh, you mentioned that GEOS handles mouse control differently. I have GEOS, and what I remember was that they supplied a mouse with it. And is that mouse wired differently, or is it only the software that's different?
Well, so maybe that was an option. I also have GEOS, and it was just a box with disks in it. I used my Laser 128 mouse with it. But no, the answer is no. There's nothing different about that mouse. An interesting thing about the 2C, which we were just talking about in the corner there, is that the 2C can detect the difference between a mouse connected and a joystick connected. It has some funny little voltage dividers in it. I don't know what use that is, but there is also an AppleSoft kind of pseudo interface to the mouse that uses the paddle commands, PDL 0 and 1. It doesn't work very well, but if you want to play with the mouse a little bit in AppleSoft, it is possible as well.
You mentioned just in your presentation, I get that the internal handling on the 2 and the 2C are different, but are the mice themselves different?
No.
Okay.
Yeah, the mice are the same. Yeah, that's the good news.
Actually, I tried to use the mouse on the 2C. It worked elsewhere and it wasn't working.
All right, yeah, actually.
I had to get an Apple 2C mouse.
So yeah, Mr. Mangin in the corner there is going to do a whole talk about the actual hardware aspects of these stuff. So yeah, maybe I might be totally wrong about that. But for the next 20 minutes, I'm right. So until proven otherwise. Any other questions?
So what you said, there's no difference in the mice? Like if we just get a regular old MO100 and plug it into a 2C?
Well, okay, so that is not true. So Wikipedia actually has a great page about Apple II and early Apple mice. There's some that work on early Macs and the 2C. There's some that work on early Macs only. I've got, this is the 4035 mouse, which is, I think, one of the more general ones that works on early Macs and the 2C. So yeah, it's a complicated topic, actually, which ones work. I think the M0100 mouse does work on the 2C and the Mac. I'm sure, again, Charles will talk about this. But yeah, so the bottom line is, if you're going to buy one on eBay, yeah, do be careful what you're buying. And if they don't specify exactly which mouse it is, I wouldn't buy it. Or if they don't have photographs at the bottom of it, so you can see the model number.
They changed the MO100 without telling anybody.
Yeah, that could be, again, yeah.
Even though they left the number the same.
Spoilers.
Yeah, that's a whole separate talk, so we'll leave that for now. Any other questions about the programming aspects of these guys? No? All right. Thank you very much.
Okay, we have a stretch break till 10:45, and then Jay will give us a talk on Pascal.
We're kind of gonna take the issue with the mouse. I have a mouse card with my 256, which is fine.
Yeah.
The thing that came with the Enhance 2E was, I think, was the ROM.
You lost me there.
Well, it's just font characters.
But what matters is they're going in, they're functioning.
What's that? I'm going to talk a little bit about it, yeah. Okay, no problem.
The person who tells me things, the person who I do not like here, is the one that
Okay, I always do. That's right.
That's the way. In all my interviews. Anyway, we're on there, we got this thing, streaming. Do you use any physical stuff on there?
Yeah, I'm going to use the Apple II. I have to set that way so I can see the screen.
One of my hands is on the screen. Exactly. This will be a collective class. He's doing the things he loves. All right, but the thing is,
I'd like to welcome you all to the last session before lunch. Lunch is in the Massman cafeteria like normal. This afternoon we have Javier doing an LCD conversion panel, or LCD conversion session. And then Jason Scott's going to do a talk on Apple in contemporary culture. And then after that, Dagen's going to do a SuperMegaSplodaGanza. Should be fun.
not again.
And that'll continue after that with Mark Pilgrim will be doing the story of the greatest copy protection ever invented. Don't miss that. And then the final afternoon session will be Charles bringing us back to the mouse again, doing a deep dive on the Apple mouse. But right now we have Jay Graham doing a session on Pascal as my second language. Thanks, Jay.
Okay, thank you. All right. Let me get my timer started here so I make sure I don't go over. Because then you'll be late for lunch. So, what I wanted to do was talk a little bit about Pascal on the Apple. It's kind of the least known language on the Apple, but it has a lot of history in the development of Apple behind it. And so what I wanted to do today essentially was go over a brief history of the Pascal. Oops, let me get the presentation here on the screen. That would help. There we go. So what I wanted to do today was go over a brief history of the Pascal language itself, the history of Pascal at Apple, Pascal on the Apple II. There were a lot of compilers that were made for the Apple II, some of them good, some of them not so good. Programming 101, and I emphasize the 101 because I am not a programmer and I don't even play one on TV. My degree is in computer science, but it's probably been about 20 years since I've actually coded. I will talk a little bit about it and from the days when I was at the University of Pittsburgh learning Pascal. And then some additional resources and references. And one of the things I wanted to stress before I begin here is there are a lot of good resources and references out there. And in my research, some of the research that I did, I mentioned them at the end. I know Steve's history of the Apple II. He has a very good section on programming languages for the Apple II in there. And there's some other people that have written some interesting historical research on that. And then if there's time at the end, I will do a demo and some questions. Okay, so where did Pascal come from? Well, it was actually named in honor of the 17th century philosopher and mathematician Blaise Pascal. And it was developed by a guy by the name of Nicholas Wirth. And basically, it was in the late 60s. It was largely and exclusively developed and intended to teach students programming. It was first developed for the CDC 6000, which was a mainframe back at the in the day. Had a very large significance on the Apple Lisa and the Macintosh, and now we've there's actually available today even versions of it that are object-based, such as Delphi, which was a Borland product, and Free Pascal. So the whole and that's so upon me not being a programmer, the whole object-oriented thing over my head. So I'll talk a little bit about it, but there's no way I could even write, I think, one line of code of that with anything that's object-oriented. Okay. So here's the timeline. The timeline in 1969, there was an attempt to develop Pascal actually with a Fortran compiler, and that failed miserably. So they went back and they rewrote or developed Nicholas Wirth. Went back and actually started the development of Pascal and completed the development in the early 1970s. In 1976, there were over 80 computer systems that had Pascal on it. 1978 is when Apple decided they were going to get into Pascal, and I'll talk a little bit about that in a minute. 1980, the University of California at San Diego developed their Pascal a gentleman there by the name of Ken Bowles. Did the development on that. And in 1987, almost 10 years later from when Apple started playing with Pascal, they introduced their object Pascal, or as it was called on the Lisa, Clascal. And then 1990, there were some extended Pascal standards published. And through the 80s and the 90s, which is when I was at the University of Pittsburgh, that was the language that was being taught. I think I had 4 courses, in Pascal. So in 1978, when Apple was looking at it, Richard Gleaves and Mark Allen basically were developing the 6502 interpreted language from the University of California at San Diego's. And another interesting note is that the game for the Apple II, Wizardry, was actually developed in Pascal, the first version of it in 1981. Okay, so how did the Pascal system work? Well, they had a unique approach to it. It would be like a standard compiler system, except so you would get into an editor, you develop your program, you would compile it, but it would, instead of compiling it in native machine language, it would compile it into this thing called P code, which P doesn't stand for Pascal, it stood for portable code at the time. Algol and some of the older procedural languages use this. So then the P code would be run then through and executed through an interpreter, and that interpreter, would be the thing that would talk to the hardware. Now, why was this good? Well, remember I said Pascal was over on 80 platforms in the late 70s, early 80s. Well, the reason for that is the only part of it you really had to write was the P code interpreter. That was the thing that took the P code from the compiler and ran it against the hardware. Okay, so the compiler was, you had to write that once, but if it compiled into P code, the P code was a pretty good standard, and then The only thing you really had to write was the P code interpreter for new hardware. Okay. And then extended Pascal. This is where we're at today. In some of this, they extended the language. They made many enhancements to it. Modules, separate unit compilations. You didn't have to compile the entire program again. You could compile separate units and bring it together. Variable length strings and arrays. The early versions of Pascal did not have that. You had to declare a string, which the length of a string. Direct access files and constant expressions, which was actually an expression as a constant. Okay. So now Pascal on the Apple II, and I have some books up here. I don't have them all. I was hoping to get that one yesterday in the garage giveaway, but somebody else got it. I have the one for the language reference. I don't have the operating system reference, although that's available online in PDF form. So there was obviously Apple Pascal. Talk a little bit about that. There was Instant Pascal. I'll try to show a demo of that today. There was TML Pascal, or called Complete Pascal later on. That was for the 2GS. There was an interesting adaptation of it called Cayenne Pascal, and I'll demo that today, where actually the gentleman that wrote that and developed that software developed Kix, which was a kind of a Unix-like shell that booted on the Apple II under ProDOS, booted up under the Apple II, and you actually used Kix to do the programming. The Pascal compiler was built under there. Then, of course, there was Turbo Pascal, and of course that required a $200 or more CPM card that would run CPM. There were a couple of other flavors of CPM Pascal, and then there were some lesser known ones which I'm not going to show today, like Laser Pascal, Pegasus Pascal, and Saturn Pascal. Okay, so let's talk a little bit about Apple Pascal, the Apple version of it. So the interesting story here, the key players in this were Bill Atkinson and Jeff Raskin for Pascal. And what they essentially did, Bill Atkinson sold Apple management on the idea that basic programming and assembly language programming was great, and because Apple had the built-in BASIC, but assembly language program, the learning curve on it was real steep. And the BASIC, you just really couldn't get a lot of the performance out of there because it was an interpreted language. So they got the go-ahead and they licensed the Pascal from the University of California in San Diego. And they essentially developed the Apple II Pascal with a compiler, an editor, an assembler, a filer, and a utilities. Now, the interesting thing about Apple Pascal is that not only is it a compiler, it's an operating system. Also, so I'll do a demo of that as the very first thing. When I show that, you'll see that it'll actually boot into its own operating system. It doesn't boot into ProDOS, doesn't boot into DOS 3.2 or 3.3. And the reason I say 3.2 is when Apple Pascal was distributed back in 1978, DOS 3.2 was the latest and greatest at that point. And it did compile the P code like I talked about earlier. Now, it had some limitations. The limitations were identifiers or variables were limited to 8 characters, okay? That for people that were programming in BASIC, that's fine. That was great. Memory was restricted to 64K. The documentation for it actually is pretty good. I was surprised. And when I don't want to say this on the air, but I had bought Turbo Pascal, but I had to bootleg the Apple Pascal back in the day, version 1.0 and 1.1 when they came out. With that, and again, I was in my 20s. What did I know? So the documentation was pretty good. I had to Xerox that too, which, by the way, it sold for about $495 back in 1979, and I'll explain what it came with or what came in the box at that point. So essentially, there were a lot of interesting things with it. Back then, when it was developed, the disk format changed. Instead of 256-byte sectors, the Pascal operating system used 512 byte blocks, okay, instead of the 256 byte sectors. So of course, that wasn't file compatible across, that and DOS 3.2. The file names were limited to 15 characters. I remember DOS, I think, was 30 characters or something like that at the time. So it was about half. Now, why did they do that? Well, it's interesting. It's not because they just said, well, let's use 15 because it's half of 30. But the reason they did that is because at that time, 80 column cards were real rare and real scarce. So the people that had to program in the 40 column mode in Apple Pascal, if you had a 30 character file name, it would pretty much take up most of the screen, 3/4 of the screen. And they had a funky thing in the editor where you could hit Control A and it would pan you over to the next 40 characters in the screen. You'd hit Control A again and it would pan you back. So without an 80 column card, it was a nightmare. And I didn't have an 80 column card for the first one until I got my Apple IIe. Okay. The other interesting thing about it is in DOS, as you know, when you write a file to it, it'll use all available sectors on the disk. Okay, so if there's something written on one, it'll skip and take the next one. And DOS is real good about reading those back because of the disk signature or the signatures on the sectors and so forth. Well, to enhance the speed of the file system for Pascal, the files had to be contiguous on there. So that was great when you got you made your first working disk. But then when you deleted and added a few files or programs from there, it started to leave holes on the disk. And those holes on the disk were looked as they were used space on there. So you couldn't use it. Once you used the space on the disk, that was it. Even if you deleted the file was deleted. It wasn't in your directory anymore, but the space on the disk was still flagged as used because it wasn't contiguous. So in the Apple Pascal, they had a utility called Crunch. And when you crunched the Apple disk volume, what it would do is it would go through there and wipe through the entire disk, and it would line everything up in contiguous file again on there. And it was KRUNCH instead of CRUNCH because, and then again, it would go through and clean everything up for that. The other thing is the timestamp was added to it, which was interesting because I can't remember back to DOS 3.2. I don't think that had a timestamp on it. So it was good to have that on there. And the other thing is the disks could also be named. They could have a 7-character volume label on it, instead of volume 254 or whatever it was. So you could actually name the disks. Okay. And again, it sold for $495, which was a lot of money back in 1979 and 1980. So let's take a look and see what came in the box. So you got hardware and software in the box, which was interesting. So with it, you got the Apple language card. There was one of these available on eBay here not too long ago. It was like $70 for the box. They didn't have the language card in it, but it was like I was bidding on it, and then it got up to $70, and I lost track of it and lost that. But so you had the language card with 16K of RAM. You had 6 diskettes, and I think later on in the later versions that they trimmed that back to like 4 or 5 maybe. You got an IC puller in there. You got 3 Pascal manuals. You got the language system installation and operating manual, the basic programming manual, and the AppleSoft tutorial manual. You got the Apple II basic programmer's reference manual, and you got 2 16-sector PROMs for your disk controller. So you had to do some surgery actually on your Apple II to get Pascal, working on it. You had to pull in the P5A and the P6A 13-sector PROMs on the disk controller and stick the 16-sector one on there. Okay. All right. So then Apple III Pascal came along once the Apple III was introduced, and Apple III Pascal was actually developed in Apple II Pascal, which was interesting. And most of the software actually for the Apple III, it was interesting, was developed in Pascal. The system utility program for the Apple III and Backup 3 were all written in Pascal. The documentation actually got better. I forget who was writing the documentation for this at the time at Apple, but boy, they did a pretty good job on it. It was real thorough. It's a little small by today's standards. There's a little booklet like that. I'll show it here in a minute. And that cycled through 4 versions of it, from 1.0 to 2.0. And it had a sophisticated floating point package that was with it. Was called SANE. It was Standard Apple Numeric Environment, or SANE. So I'm sure there's a lot of jokes for that. It's insane. And also there's a gentleman by the name of David T. Craig, and I'll announce him. He captured a good history of the Apple II Pascal, and it's out on the Asimov site as well. So the support ended in 1985, and so did the P code at that point. And I'll explain what I mean by the P code in a minute here. So along came the Lisa with the Lisa, and along with the Lisa came Pascal. And again, just like the Apple III, a lot of the code for the Lisa was developed on Pascal. And actually, I'll talk a little bit about it here. Lisa is actually where the Clascal came out, or the class Pascal, classes plus Pascal. So again, a lot of the software was developed on here. The operating system was developed in Pascal, and it was around 90,000 lines of code. The workshop development environment for the Lisa was developed in Pascal, and that was around 100,000 lines of code. The application programs, I think there were about 7 of them, like Lisa Write, Lisa Calc, were developed in Pascal, and they all averaged around 70 or 80,000 lines of Pascal code. Now, the interesting thing here, just like the Apple III Pascal, I said, was developed with the Apple II Pascal, the Lisa, they started from scratch again. It was a 68,000 processor. They went back and licensed Motorola's 68,000 compiler, and took that and did the development effort from that. Now, remember I said P code disappeared. It didn't really disappear. It was still in a lot of the compilers, but on the Lisa, it disappeared. This was when they developed the Pascal for this, it was a native code compiler. No more P code. With this, it was actually, compiled to 68,000 machine language. And there were roughly 3 versions of this. I'm sure that there were a few interim releases, and there were many code extensions to it to adapt to the hardware for the Lisa. Okay. It also included SANE, so that was in there. The Macintosh development actually used the Lisa Pascal. Mac Write, Mac Draw, and Mac Terminal all developed on the Lisa Pascal for the Macintosh. And there were 2 key players at the time for this, and that was Ira Rubin and Al Hoffman, and they both worked at Apple. This was also used to develop the class. I have classical there, but it's Clascal, thanks to autocorrect. So it was Pascal plus the classes. So that was the first object-oriented version of it. Let me do one little story here that I found, and I forget where I saw this for the research for this. I think it was on folklore.org or whatever. But remember, I said you needed the 16K RAM card back then to run Pascal because it required 64K to run. If you didn't have 64K, it didn't run. When Bill Atkinson was doing a lot of the development for the Lisa at the time, they were with the Pascal. For the Lisa Pascal, they were actually doing a lot of that development work and code work on the Apple II. And then they would port it over later on once the Lisa hardware became available. So back then, with 64K, it was tight fit in 64K. 128K, it runs okay. But 64K, it was a tight fit. So Bill Atkinson goes down and was complaining one day to Burl Smith. And I'm sure if you don't know who Burl Smith was, he was a 23-year-old self-taught engineer at Apple. And he actually worked on the Macintosh team with Jeff Raskin, and he was world renowned in Apple for being a real good hardware ninja and guru, and developing things. So Bill Atkinson was complaining to him one day and said, "Man, this 16K language card," he goes, it just doesn't work. He goes, I'm trying to write this Lisa Pascal when we're getting up to 70, 80,000 lines of code, and I'm having all kinds of problems with it." Well, Burl Smith looks at him and he goes, "Well, why don't you just put more memory on the language card?" And he goes, "Well, it's 16K and we're already bank switching." He goes, we can't put any more on there." And he goes, "Yeah, you can." So he goes back into his office, and a day or two later comes out with an 80K language card. And they put the language, and Bill Atkinson puts it in there, and the 80K language card worked perfectly. He said, "You're already bank switching." He goes, "Why don't you just extend that and bank switch some more?" So they loved it. The development team for the Lisa loved it because it made things so much easier. So Apple manufactured a whole bunch of these 80K language cards and gave them all to the developers. So that was an interesting story that I thought, and it was all because of the Pascal development on there. Now I've never seen one, but I'm sure somebody here probably has one. So as we move on to Macintosh Pascal, we've gone past the Lisa, and now we're onto the Macintosh Pascal. So in the Macintosh Pascal, they came out with an MPW, which was the Macintosh Programmers Workshop, and that replaced the Lisa Pascal. This was more of a professional development environment. It looked very professional, and I never used it, but I saw it being used, and it was interesting at that point. And they added things for support for the new Motorola processors like the 030 and the 040. It was optimized object code. Object-oriented version of it was released. It cycled through 3 major versions of this, and they actually a lot of the Pascal, the Lisa Pascal, object-oriented Pascal, was used to do a lot of the development for the Macintosh. And of course, the key player for that was Larry Tesler from Xerox PARC, because it was based on Simula and Smalltalk. So Larry was the guy who was in charge of that. Now, one of the interesting notes on the Macintosh, it was real interesting to note that Mac Paint was a rather small program. It was developed in Pascal, and it was a rather small program by today's standards. But of course, it probably had to be to run on the Mac 128 that came out back then, which was what, an eighth of a gigabyte of, or an eighth of a megabyte of memory. When you talk about it. And this is what Rebecca was talking about yesterday. It's like you had 128K of RAM to get the operating system in there and Mac Paint. So when they finished the Mac Paint, it consisted of 5,804 lines of code. Okay. And it was augmented by another 2,700 lines of about 2,700 lines of assembly language. And it compiled in less than 0.05 megabytes of executable code. Okay, 0.05 megabytes. Now, not gigabytes, megabytes, the M, which was interesting. So let me talk a little bit about the Think Pascal, or Instant Pascal, I'm sorry, Instant Pascal that came out. Let's see that. So Instant Pascal came out. It was written by Think Technologies, and it had a couple of interesting things about it. It used double high-res graphics, and by use double high-res graphics, I mean the actual IDE, or Integrated Development Environment Interface, was a graphical one. And it was pretty cool. It was slow, a bit, as you see there, but it was pretty cool. The other interesting thing about it is it had an LSE, which was a language-sensitive editor. Now, when I first started programming in Pascal, you didn't have a language-sensitive editor. You were lucky you had a text editor. More than luckily, though, you had a line editor with it in programming in Pascal. I remember a line editor on the VAX 11, and that was a nightmare. When I saw this, it basically senses the language. And when you type the word program, it bolds it and says, that's a reserved word. and then it'll ask you for the program name, and you start typing it. A lot of the things that we're really used to today, in Notepad Plus and all of that type of thing, this had it back in the day. It was a language-sensitive editor. It had also some really cool tools for debugging, single stepping, and watch points and things like that. It was slow. It worked under ProDOS. And there's a button right there. There were a lot of interesting paraphernalia that came out for it because they were trying to market it. And then eventually Apple bought it and bought the rights for it and used it to sell it to educators for teaching, because it was a really good environment for that. No, it wasn't an operating system. The interesting thing is on all of these, Apple Pascal was an operating system and had it bundled into there. This booted right out of ProDOS. Yeah, you booted it right out of ProDOS. Okay. Now, and then there's TML Pascal and Complete Pascal. And by the time the 2GS came along and the graphical user interface, I wasn't programming at all anymore. So, the whole toolbox thing and that, I never tried any of that. But again, this was a native code Pascal compiler. It was released in '87 for the 2GS. And it would do 2GS toolbox, but you could also use this for plain Pascal programming. So it also had the educational twist to it when the 2GSs were in schools. It was a multi-window mouse-based editor, no drag and drop. For this, you needed at least your minimum requirements were an Apple IIGS, 768K RAM, 3.5-inch disk drive, GSOS 504 or higher, and a hard drive was strongly recommended for it. Okay. There were a lot of versions for this. Version 1 came out as TML Pascal, and then there was TML Pascal 2, which was 1.0 and 1.1, and that was released in the late 80s, early 90s. Then they changed the name and bought it and to Complete Pascal. I believe they were bought out at that time in 90 and 91. And then in late 91, there was a fire actually in the developers studio. I think they were based in Denver, Colorado, if I'm not mistaken. Then it burned down, and that was it. So did TML Pascal, and Complete Pascal burned down at that point. And then later, I think it was in 2009, the author granted free distribution status for it. Not going to show that one today. Now, here was the interesting one I talked about. This was the Cayenne Pascal. It was a native code Pascal compiler. It was released in 1985 and 1986. They formed in 1984 to develop, professional quality, low-cost programming software and programming languages. And I think their first product was a P-code compiler for like the Commodore 64 or something like that. They developed a lot of interesting stuff back then. I didn't hear of them back then. My research turned this up, and it was like, man, I wish I would have known about that back then, because before Turbo Pascal came out, this was a pretty cool environment. They gave you an editor, they gave you a compiler, you got an assembler. Now again, this booted out of ProDOS, but it booted up into a Unix-like shell, and it didn't have all the Unix commands in there, but it had a lot of the ones you would need to do programming. Their second product was a native machine code Pascal compiler, and it would run on anything that had a 6502 in it, which was an interesting concept with this. It ran programs about 30 times faster than BASIC. I put an asterisk there because that was their claim. They actually developed newsletters and sent newsletters out to all of their users with tips and tricks and all of that for Cayenne Pascal. It needed at least 64K of RAM, would use more. Again, this was widely used in schools for teaching because it was a very good, easy teaching environment for that, and you could get up and running in it real quick. And it actually had some units for advanced things like graphics and mouse movements and things like that. And I have the web page in my presentation here. Then along came Turbo Pascal, and this I actually bought this, unlike Apple Pascal. It was released in 1983, and I remember I think I got mine in around 85, because my parents got me an Apple IIe for Christmas that year. And they actually bought me the CPM card. And I asked my dad, why did you buy me the CPM card? And he said, well, you can run more programs on it. And I said, oh, cool. And then when I saw this and it required a CPM card, I'm there, hey, I got everything to make this thing run. All I need is $50. So, you know, I saved up my pennies and actually, you know, ordered it and, you know, got it. Came on one floppy. Actually, I think 2 floppies came with it. There was the compiler disk itself, and then it had the sample program, which was microcalc or something. It was a Pascal, you know, source code, and you could compile it into a spreadsheet, which I think I did that once just to see how the compiler worked, and that was it. This was based on Poly Pascal. Borland released it. You needed the Z80, ran a little bit faster because the Z80 ran a little bit faster. And you could fit everything on one floppy, which was really good. Okay. Now let me talk a little bit about the. See, I'm doing on time here. Good. Let me talk a little bit about the program structure of this. This is the part where I will reiterate. I'm not a developer or a programmer. I used this in 4 classes back in 1980. I think I programmed in it maybe 4 times since then. Actually did a little bit more, and it all comes back to you because it was like, oh yeah, I remember that. So the program structure, you had a program name, you had a uses command, and what a uses command did was there were things in Pascal that were called units, and there were units written for like a mouse unit. So you would say uses mouse, and that would actually include that code in a compile time to your code and give you the libraries and the declarations in there. Type declarations, and we'll go over this because Pascal is what they call a strongly typed language. Constant declarations, variable declarations, functions and procedures, the main program blocks and comments. So this is what a typical Pascal program would look like. You have the name of the program, you have the uses, which are common delimited names of the libraries that you wanted to use. You had constant, and there was a global constant, and there was a variable declaration block, a function declaration block, a procedure, and then a begin and end. So all of your functions and procedures were in there. What's the difference between a function and a procedure? Function returns a value, procedure does something. Okay, a function actually must return a value in Pascal. If it doesn't, you have problems. Some of the things I wanted to talk about today, as I said, the semicolon types, some of the control structures. I'm not going to be able to teach you Pascal. There's a lot of good Pascal compilers out there now, free Pascal for the Apple and the Windows. You can download it. You can actually start playing with it pretty easily. And I remember this was drilled into my head by my instructor back then with the semicolon. A semicolon is the thing that will get you in Pascal all the time. And he would always yell in class, the semicolon is a statement separator and not a statement terminator, okay? It separates the statements, it doesn't terminate it. And he would yell that every class, and it's ingrained into me now. And, you know,
Sounds like you got a little trauma there.
yeah, he did. A little bit of trauma in there because you'd be, a misplaced semicolon in Pascal can cause you all kinds of problems.
Post-traumatic semicolon.
Post-traumatic semicolon disorder, that's right. And then when I got to see, it was like, oh my God, there's another semicolon. But, so in Pascal, I want to talk about the types in Pascal because this is the coolest thing in Pascal, and with the ability to declare your own types. So you had your typical types, which were integer, real, Boolean, char, which was a character, and then string, which is just a bunch of chars in line. Now, every compiler had its different range values for these, and it was interesting because they all treated it differently. And actually, when I have a demo program that I'll show here, and when I was playing around with that, it's interesting how they all handled like integer overflows. Some of them would give you a negative number, some of them would blow up, and you get a stack overflow, and then some of them would actually convert it from an int to a long int, and said, I know you declared this as an integer, but you know you've gone past it, and we're gonna switch it over to a long int for you. So then it had complex data types: byte, signed byte, which was -128 to +128. You had a subrange, so you could declare a variable called age, and the variable was 18 to 65. That was the type. Okay, age was 18 to 65. If you tried to say age equals 66, it died on you. You had enumerated types, set types and records, which I'll talk a little bit about, file type, pointer types, and procedure and function types. So let's talk a little bit about the enumerated types. This was a very hard concept for me to grasp. So with an enumerated type, you can declare something to be of type beverage, and the expected values for beverage are coffee, tea, milk, water, Coke, lime juice. Then you would declare a variable called beverage or drink with the type of beverage, and then it would say which, and then you could assign drink to equal lime juice at that point. Would equal that variable, that variable right there. And then when you wrote that out, it said you can drink lime juice. Okay, so again, that was an enumerated type. This was a real interesting concept because if you're in computer science, they bore set theory into your head. It actually had a set type in there where you could declare something like junk to be a set of characters. You could declare, again, this is an enumerated type here, which is days equals Monday through Sunday. And then you could declare work days to be a set of days, okay? And that was the way you declared something, set of, and then another, primitive type, or enumerated type. So, and the way you did an assignment on that is in your program, as you said, with work days is equal to, and then in square brackets, Mon, Tu, Wen, Thur, and Fry. And that was your work days. Now, the interesting thing is when you had sets, you had operators with the sets. So you could do things like union, difference, intersection, use the word contains, and use the word in. So I could have two sets, and I could say, please give me the union of that. And I think the asterisk was the thing that you used to give the union of the two sets. It would take all of the things in set one, all of the things in set two, assign that to a new variable, deduping it, and that would be the union of the set. The intersection of it would be the things that are common in both of them. So like in the one you have down there, or S1 and S2 down there, I think C would be the intersection. So if you asked for the intersection of that, it would give you C. Contains and in is something in the set or contained within the set. I think I used that maybe in 2 programs, but I thought it was really cool. So a record, that's another type. And you could build a record within Pascal. str25, you see that declared to be of a string type of 25. Then you have a type in here called tbookRec, which is a record. That's a reserved word. Then it has all of these variables and an end and a semicolon in the record. And then when you go ahead and you declared it, you had a thing in there. Essentially, you declared the variable here called myBookRec, which was of this type up here. And the way you addressed the individual fields within that record was with a dot. So myBookRec.title, which referred to this up here, equals this. So you could actually, there were some primitive types in there. And when you put a pointer in here, you could put a pointer from next and previous, which was an address pointer, and you could build a linked list of these things and all kinds of cool stuff. So this is an example of where it shows the different scalar types, structure types, and of course the pointer type in there. So that gives you kind of a little view of that. Then control structures are similar to what they are in a lot of the other procedural languages. There's a while do, an if then else, a for statement, a repeat until, and a case statement. And these are kind of what they look like. While A is less than, or A is not equal to B, do, and you could do statements in there. If A is greater than B, then else. There was a condition, an else condition on there. There was a for loop. There was a repeat until, and that's where the test for the condition was done at the bottom of the loop. And then there was a case statement, which was really cool. And this was good for like doing keyboard input. You would grab keyboard input, grab the key, and you would say case key of, and then you would have the different values there. So if it was 1, it would write this, 2, 3, or whatever. You would do things with different key presses. Some versions of Pascal had an other colon there. So if it wasn't, in this case, 0, 1, 2, or 3 through 10, there could be an other there. So if it was something other than that, you could do that. Now, not all implementations had that, but some of them did on the case statement.
Did you have to define all your variables before you used them?
Do you have to, the question was, do you have to define all of your variables before you use them? Yes, you have scoping like you do in the other languages there, but you define the variables up at the top, right after the program name, where your global variables, that would be global.
The compiler only does one pass through the code.
Again, the question was, does the compiler only do one pass through the code? Different compilers did it different ways. Turbo Pascal, one pass.
I remember I had PL1, taking a course in that, and I had Pascal. And in PL1, you can do the definitions and the use of them in any order because it was a much more complex language.
Yeah, and it did a multiple pass.
In some ways, they were similar.
Yeah.
So I had the experience felt the same. So I had to remind myself that this wasn't PL1, but I'm thinking of it as not PL1.
Not PL1.
Was there any relation between the development of Pascal and PL1?
They were all related back then. Algol 60, PL1, and a lot of the strongly typed procedural languages all had their roots in the beginning of a few people. So yeah, there were Modula 2 was another one. With that, there was actually Modula 2. Actually, Borland actually released a Modula 2 compiler. It was out for a little while with that. So they were all different, and they were all used to build upon one another.
They're all this, what do you call it,
structured programming languages. That's right. So procedures and functions in Pascal. So you have procedures and functions. They had arguments. They had local declarations of variables. This was really confusing when I first learned this. You could have an n at the declare n as an integer up at the the main program block, and then you could have n as being a char in the procedure. Boy, if you did that, it was like you would have all kinds of issues in there. So local declarations, procedural body, and procedures do not return a value directory. Functions had to, and you'll see in the declaration of them here. I'll show as we do the demo. This is a list of reserved words. This changed from compiler to compiler, but this is the the least common denominator of them. So there aren't that many reserved words in there. Now the interesting thing is when they were trying to do the Pascal syntax, they were trying to, and this was all kinds of languages. They tried to do definitions of syntax, and it was kind of not precise at first. So there was a gentleman by the name of John Backus, and he actually invented Fortran. And then Peter Nahr was a Danish astronomer turned computer scientist, and they came up with this grammar. And there are many iterations of this today, but it was called BNF, or Backus-Nahr form. And it was a formal mathematical way to specify grammars. You're probably sitting there wondering, why the hell is he talking about this? I'll tell you in a minute at the end when we talk about the Jeff Raskin Pascal poster. But it was also easy when they added something new to the Pascal language. If they gave you the BNF rules and you understood BNF, it was like, oh, I know how that works. And again, that Algol 60 was specified in this. So let me give you a little example of how this works. And this is a small grammar. This is not the Pascal grammar, obviously. So the way this worked is you would have a sentence, or you would have something declared or defined as a sentence. And a sentence was defined as a subject and followed by a predicate. Well, what's a subject? Well, a subject is an article followed by a noun. Okay, well, what's an article and a noun? Well, let's see. The predicate is a verb and a direct object. So the predicate, a verb and direct object. What's a direct object? Direct object is an article and a noun. And an article is either the or a noun is either man or dog, and a verb is either bites or pets. So here are three sentences that are defined in that language. The man bites a dog pets a dog, man bites a dog. Okay, two of them are legal, one is not. Anybody have an idea which one? See, yeah, man bites dog, okay? So Pascal was defined in this using this DNF. So all the different structures in there, you could, once you understood the grammar, and it took a little while to do this, you would understand Pascal. And you would understand by looking at the old Jeff Raskin poster. These were some of the propaganda that came out back then. There was a iron-on t-shirt transfer in magazines where you could peel this off and iron it onto your white t-shirt and you know, run Pascal. This is what actually the 1.2 version of Apple Pascal looked like. And that was a poster, and there's an interesting story behind the poster. So Brian Howard, I think, was one of the gentlemen that was working with Jeff Raskin on doing the documentation for the Apple Pascal. Remembered his name, Brian Howard. So they developed the documentation, and then Jeff Raskin said, "Well, look at the syntax for the Pascal from UCSD. It's wrong." So he found some issues with it. And he decided to develop a poster. So he got out his crayons and pencils and developed this large colored poster for Pascal. The colors meant something. The different colors that he used coded things differently. Like he might have done type declarations in blue. He might have done procedures and functions in yellow. So the color had a meaning to it. And the chart had a meaning, and it was a handwritten chart, and they made copies of it and gave it to all of the Pascal programmers. Well, Steve Jobs walks in one day in his standard Steve Jobs way, sees this poster and goes, "Boy, that'd be a good marketing tool." And he said, "Can we do that?" And Jeff goes, "Oh yes, it would be a good marketing tool." Well, Steve rips it off the wall, walks out with it, and Jeff Raskin never hears from Steve again until the poster's done. He gave it to an artist, said, "Can you make this thing look really good?" The artist took it, put different colors on different things, totally blew the meaning of the poster at that point because the colors were all just all over the place and made it look neat. Jeff Raskin never heard about it again until Steve Jobs walks in with a copy, and he goes, and Jeff Raskin goes, "You ruined this." And he goes, "No," he goes, "it looks really great." And the artist actually got credit on the poster, so Jeff Raskin didn't. And the poster was useless. It looks nice, but it was useless because the color had meaning at that point. Okay, all right. So what I want to do now is I want to kind of do a little demo here. And I use this program for demo mainly because it shows a couple of things in Pascal, not everything, because I would be here till midnight if I wanted to show you everything. But one of the interesting things that it shows you is with the function. And this is the way a function is declared. You have the function, you have the name of the function, you have an argument that you're passing into it, and then you have the value that the function, or the type that the function returns, type of the value that the function returns. And this actually is a really cool function because it'll use something called recursion. It actually calls itself. Remember Becky was talking yesterday about a stack. Nobody knows what a stack is anymore. Well, this is where I learned what a stack was. And it took a while, but once I got it, it was like, oh yeah, I understand that. And essentially what this does is it just cycles through 0 through 10 and writes out the factorial of this. Now, the interesting thing with procedures and functions, there were two ways to call parameters in Pascal. There are arguments in Pascal. It was either by name or by value. And by value, you pass the value of the argument in, and it would evaluate the value of it and work, but wouldn't change anything in the calling program. And when you called it by name or by reference, it actually would change the value in the program. So there was a way that you could pass it in by reference or by name, and it actually changed the global value in the program. So you had to be real careful with the way you did that. And I forget how you did it. I think you put a var in here in front of the n. But it was funny, Nicholas Worth, the guy who designed and the specification for Pascal, everybody always had problems pronouncing his name. So he would say, "How do you pronounce your name?" And he always had this joke, tongue-in-cheek joke. He goes, "Well, you can call me by name, Wirt, Nicholas Wirt, or you can call me by value, Nicholsworth." So it was like, okay, that was interesting. But it always, and he's the one that came up with the value and the name thing there. So let me show you a demo of this. I'm going to do some of this on an emulator, and then I'm going to do some of it. How are we good for time? We got a few minutes left here. Let's see here. I'm going to do the, see where I have this here. Do I have, wanted to grab the Instant Pascal. There it is. Okay, Instant Pascal side 1, Instant Pascal side 2. Okay, let's boot. Okay, we'll do 80 column text. All right, now. Windows 8 and the Apple doesn't like that I can't get that cursor out of there. Oh, come on. Oh, come on here. See if I can flip around to here. There we go. Flip the drive around. Come back in here. Okay. All right, let me see if I can make this full screen now. There we go. All right.
Almost.
Almost, yep, almost there.
Ink different.
Okay, let's close that. Let's open. Let's see, next disk. Yeah, let me see where I have to. Hinky different, yep. Let me see here. Come on. There we go. Now let's see here. Do an open on here. I want to do the next disk. Let me see. I guess I must have grabbed the wrong disk here. So we'll save this one for last. So we'll do the Apple Pascal here first. Actually do that on a live Apple IIe. All right. Let's see. I think I have that set to boot off of number 5. And I'm using a CFFA 3000 in here, and I have Apple 1 colon in drive 1 and Apple 2 colon in drive 2.
So this is not UCSD.
No, this is the Apple compiler. So, okay, let's go ahead and do file with this, which was F, L to list the directory, and then you give the Apple volume number of this, or the name rather, and there's my factorial program. Okay, it's hard to see in 80 column here, but bear with me here. Okay, so I am going to edit factorial, show you what that looks like. It's actually loading it into the editor now, and there's the same thing that you saw, the same function that you saw up there. The editor in here was a nightmare, but it worked. So let's go ahead and do the quit, and I will exit without saving. It will bring me back to there, and you'll see across the top there, C is compile. So I'm going to do compile, and I will type in factorial, which was the function that was on the disk, and it'll read it back off, and it'll say to what code file. Work file was the default, so I'm going to do factorial. Okay. Then the next thing it'll ask me for here is a listing file, and I'll just leave that none right now. You'll see it'll actually start the compiler, and it's compiling the program. Okay. That's a small program, so you can imagine what it would do on a. Then I'm just going to hit R for run. And there it is. The factorial of 0 is 1, 1 is 1. And now an interesting thing happens between 7 and 8. The number goes from 5,040 to negative 25,216. Anybody have an idea what's happening there? Yeah, integer overflow at that point. Okay, 8 factorial is more than 32,768. So it basically says, all right, you get a negative number there, and that's the way it does it. So you have to be careful and watch for that. Okay, let's.
Nothing above 8 is reliable.
Yeah. Okay.
Nothing above 8 is reliable.
What's that? Nothing above 8 there is reliable. Yeah, unless you, yeah. Yeah. Okay, let's see. The next thing I want to do, let's see, what other one do I want to show here? We have a little time left. Yeah, very little time. So let me, I don't want to make everybody late for lunch. So let me show you the Cayenne Pascal. That would be the, that's the other interesting one here. Smart port assignments. Let me go over here to move that.
Which one do you recommend for a new Pascal programmer to pick up?
The question is, which one would I recommend for a new Pascal programmer to pick up? This one, if you don't have a CP/M card, Instant Pascal is really good. Yeah, that was the one, the graphical one that I tried showing there. It's really good, but run it in an emulator. If you run it in an emulator at high speed, it really works. If you run it on an Apple IIe with 128K of memory, you'll hit a key, and a couple seconds later, the letter will come up because it used the double high-res graphics. Borland's Turbo Pascal is really good. If you remember WordStar, you got half the battle done because it used the WordStar editing sequences, and it compiled really fast, even on native hardware. Yeah, even on native hardware. All right, so let me go ahead and boot from slot 7 here, and I'll show you Cayenne Pascal. So it boots up, and it's now moving KICS files to the RAM disk here. Give it a second. And there you go. It has its editor, the Pascal compiler, the ProDOS filer utility, which is actually the ProDOS filer utility, the KICS command menu, an introduction, and you can obviously quit. Now, let me get into the editor here first. So I will edit factorial. I think I called it .pass here. Yeah, there it is again. There's the factorial program, lowercase here. Let me go ahead and quit. And for here, it was PC for Pascal compiler. Factorial.pass. And then I'm going to give it an object name also for factorial. Otherwise, it'll be a.out. Okay. And there we go. We're on its way compiling here. It doesn't really tell you it's doing anything, but it is. Comes back to a prompt. Okay, Unix ls. Let's see, where is, let me do ls fact star. All right, so you see the factorial pass, which is a text file, and then the factorial bin file. To run it, you just simply type factorial. Boom, same thing, integer overflow. Instant Pascal, the double high-res graphics, I had everything declared as integer in there, and it declared them as double ints and or converted them on the fly. So it came out with the exact right answers, and it didn't do an integer overflow on there. So again, if you want to learn Turbo Pascal, if you have a CP/M card, that's great, or Instant Pascal on an emulator like Apple Win or Virtual 2 is really, really good. Yeah, let's see. What's that?
Are those available?
Yeah, all of them are available. I have them all in a collection here, and if Andy's okay with it, I'll make that available so that you can just download them. I have all the manuals and everything in one place. Let me do one other thing here. I'll show you this. 1 second here. We'll put the turbo disk on there. We'll put that on number 1. Come back here. Let's get that off of there so we don't boot from there.
It's run under ProDOS on Apple IIGS.
I'm sorry, what's that? I don't know. I haven't tried it on the 2GS. I think I shot myself in the foot here.
No.
There we go. Okay, let's boot slot 7 here again. And now I'll boot up under Turbo Pascal and show you how this works under Turbo Pascal. PR number 5. Boom, 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 boom. Yeah, and this is Turbo Pascal. It's running. I forget what CPM card in here. I think I have the Micro Pro, the Micro Pro card, Star card. Okay, Turbo, and that's how you ran Turbo Pascal and CPM. And I have it include the error messages because that was the nice part of it. Let's edit factorial.pass. Okay, there it is. Control KD. I'm going to do the compile. See that compiled even on an Apple II really fast. Run it, but it still has the integer overflow problem on it. Okay, any questions? I'm sorry, we're running a little late here, but any questions I can try to answer? No? Okay. All righty. Thank you.
We're going to try to have all the files from sessions that people give us posted on the KFest website, so
Okay.
I'll be able to get this stuff.
That's awesome. So we don't have to rush up there and plug it.
No. Yeah, I'll actually give you a link to Box. I have them all up in Box. They're all organized up there, and I'll just make the link available to Planet Earth. So, Planet Earth. Only Planet Earth. Welcome to Earth. Oh, good. I'm glad you liked it. Hopefully that was good. Go learn Pascal. Oh, this is my wife, Robin. This is Andy Malloy. I asked her to come in to see my presentation. So what do you think?
You need to get rid of the almonds, though.
Oh, the almonds.
Are you a programmer?
Nurse.
Oh, okay.
We have to balance each other out.
Definitely.
You need help with cleanup?
Yeah, I'm just gonna. Can you get my laptop bag that's in the middle there, dude? So I think it's by that seat.
Is this computer for the presentation?
This? No, that's
That's him? Oh, okay.
Yeah.
Because I got for my presentation, I got little graphics.
It's not going to project anything.
No, are you sure?
No, I'm sure.
Try it.
Do you need something?
Any laptop, yeah.
Okay. A PC or
A Mac would be better.
okay.
But
You can use mine.
Okay, there you go.
yeah, if you don't mind, I'll do the thanks, man.
Solved.
So at 1 o'clock, I'll.
I'd like to have it on Apple II or some other kind of big program.
Hello, hello. How you doing? Thank you very much. So as you may know, I'm Javier Rivera. I'm the crazy guy that is showing all the time the LCD modifications. So I'm just going to tell you a bit what motivated me to do this, and how do I did all the the conversions and how it begin to fill with things. So basically what happened is that, I had my normal Apple IIc with the normal Apple IIc green monitor, and I was very happy with it. But, all this because I did all my retro write, of course. But I'm done with it, and I'm playing games, and a lot of the games, Karateka and all those, are nice, but they don't look as nice as in color. So every time I wanted to do something, play something in color, I have to bring my Apple IIc to the TV that I have and, connect it and play over there and, bother everybody that want to use the TV and all of that. So exactly, why? And I also bought a big, color monitor and connected, and I have it over there, but it's bulky and it's big and it's heavy. And the little thing that I have my IIc, it was a little bit too much for it. So basically begin to think, I wish I could put something over there and say, well, if the color Macintosh, the small one, has a color monitor over there and it's the same size, it's 9 inches, I begin to measure it and say, I could, buy a Mac and then just take out the monitor, the CRT, and put it inside and then just connect it and I got color. And yeah, Javier, of course, but you don't know anything about electronics. And then, of course, I begin to ask people, and they just, I'm sure they were laughing on the other side. I'm like, yeah, Javier, don't worry. So I discarded that. It meant to buy a computer, destroy it, to create my thing. And well, but still. So anyway, I begin to think about, what other options I have. And at the end, I found this 8-inch LCD from a place on eBay, from a place in China, Philips. And I bought it. I measure, I always take my measuring. I thought, so I say, okay, I'll do it. So, well, these are the first things. First, I had a 13-inch Toshiba LCD tossed in my house from an old Toshiba that stopped working. So I disassembled it, and I got a little driver for it, and I connected. So these are my first tests that I did with LCD. I put it on top of this, an iPad, so don't worry. I just put it so it didn't slide. It looks something else, but, so that's the monitor. So I begin to do some tests. Then I put it next to each other, the Toshiba and the normal Apple monitor, Apple color monitor, to see if it really makes a difference. And actually, it wasn't that bad. Of course, the monitor was a little bit better, but it was good enough. Same with text, any column. So I think, yeah, it can be doable. So this is the one that I bought from China. As you can see, this is an 8 screen. It's very similar, and I wouldn't be surprised if it's the same that you guys are getting from the Night Owl. I'm almost positive that it's the same brand and everything inside. So I bought it, I tested, I put it all together, and finally, I had it, and this is the result. Actually, this is not that. This is a new one, because the one that I have, the 8-inch, the problem is that there's a gap on the sides. So you got to put like a little frame, like a black frame, so you don't see the edges. So that was my first monitor, and it was very nice. But now I begin to do the version 2.0, and I found a 9.7-inch LCD screen that fits perfectly in there. One of the things, so somebody has an iPad around here? So, well, anyway, an iPad, if you take an iPad, it's a little bit wider, but it fits inside perfectly. But when you send the image over there, the image doesn't appear exactly in the center. It's weird, but something on the, I suppose, on the composite signal on the Apple or the little device that takes the image, puts it on a side, on a corner. So actually, what I had to do is I have to move the monitor a little bit down and to the side, inside. So it looks perfectly centered on there. So that's when I started to do all my conversions. I got right now I got 3 or 4 made, but I sold a couple of them. Apple IIc LCD conversions. As you can see, one of my main concerns is I love the IIc and the monitors, and I love the way they look. So the main concern of me is I wanted to keep it the same look and feel as the original. So I kept the 3 connectors on the back. I just, they don't connect to anything, so I just glue to the back. I put a new connector that looks exactly the same as the old one, the AC connector. And of course, I put a new composite entrance. This doesn't work anymore. I just glue it over there for looks. It moves, but it doesn't do anything. And on the other side, oh, here it is open. As you can see, I put a little piece of wood. It's not high tech, but as you can see, it's pretty good. The connector over there, it's strong. That's another thing that needs to be, because when you plug it in, you apply pressure, and if it's not really strong over there, you will drop it inside. The same with the power. And the power, as you can see, it just goes to a small power supply, a little, 12 volts power supply. And what I did is just a little thing that one goes to the power supply, the other one goes to the switch and goes back. So the switch works just like it should be. The nice thing about the LCDs is when you set it up, it has an AV, like 3 entrances. And I just set up the composite connection. And when I turn it off, next time you turn it on, it's in composite all the time until you change it. So it actually will remain composite until you change it. So every time you turn it off, turn it on, it comes back to composite. You don't have to be selecting or doing anything. It doesn't reset. The same thing with all the settings. When I put it the first time, it's a little bit fuzzy. So I change all the settings to be on the contrast, everything, so it looks as best as it can on LCD. And I set it up and test it, and it looks good, and just leave it like that. And every time you turn it off and turn it on, it just comes back with the same settings. So I love that. This is another photo of the interior. And as you can see, it's very simple. There's in the back, I'm going to show you another one. Those guys are glued over there on the sides. There's 2 versions of the Apple IIc monitor. Some of them have, I don't know, these are not glued. They have actually 2 screws over there. There's one version that has the screws on the sides, and there's another version that they screw to the body of the LCD, the monitor itself. So I gotta glue those over there. So that's another problem. And believe it or not, it looks funny, but I use pieces of wood because it's soft, but at the same time it allows me to push it in good enough so it stays there. And then I just put the double tape and tape the black over there so it stays there. As you can see, there's other entrances that I don't use. I just use the normal composite. And another thing is, I have to recreate retool, how they call it, redo the screw that goes underneath, because that screw's a very special screw that nobody has it. I went to Ace Hardware and every place, and they don't have that screw. So what you got to do is you got to make them do a new one. So that's just a side note. So those are the things, that's some of the tests.
Javier?
Yep. Sure.
When you do that to the screw, you can still screw it into the base, the metal base.
That's for the metal base. The thing is that you won't be able to screw it back to the original CRT. Because the original CRT is the one that has the.
Yeah, so you had to kind of like, what is it called, tap to? Yeah.
Yeah.
Had to retap it.
Retap it. That's the word. Yeah. So that's
good enough for us.
rethreaded. I think that's the name.
There
Yes.
you go.
Yeah. So yeah, but that's just for the base. If you want to use the base, if not, you don't need it. This is some tests that I'm running. As you can see, what I love is that this version goes all the way to the edges.
Yeah.
So you don't have something small. Exactly, and it shows. This is the good old Karateka on the other side.
Yeah.
It's really funny. The Australian version. You guys are so strange. So yeah. So as you can see, it goes all the way to the edges, and I love it. There's good old Karateka, normal, the American version, and then as you can see, the 80 column looks pretty good. I mean, it's not as sharp. I'm gonna go back. It's not as sharp as a Night Owl. I gotta give it to it. I think again, the electronics have something that make it very sharp. But I think this is really good. It's readable. If you're gonna be using it for I don't know, Apple Works or something like that, I wouldn't suggest it because, it's readable, but it's not as sharp as a Night Owl. But for normal things, reading things, and
With the Night Owl screen,
It's-
there would be much smaller.
yes, actually the Night Owl would be almost like this, the edges of the Night Owl. So it would be inside. So the screen maybe would be like this small.
You'd have to make a different border.
Yes, you gotta put a border inside for the Night Owl. So
So it's gonna sit even further back in.
yeah, or and it will look odd, with a black border or something like that. So that's why I'm not, as much as I love it, I still prefer this because it's full screen. There's another one, and that's another one that I just did for some of the guys on the group. He sent me one of these ones, and he told me, "Can you do it?" And yeah, I'll.
Is that the light blue?
The light blue?
Go back.
Back.
The colors are a little.
Oh no, this is black. I don't know. Well, it's because of the
The
reflect.
back of the
Go back.
monitor.
Oh, sorry.
Is that section light blue?
It's more grayish. It's
I
more.
have one that's light blue and I've never seen one before.
Oh.
Maybe that was another.
No, that's great.
That's your eyes.
Yeah, you gotta go to the optometrist.
White gold.
It could have been faded by the sun, I don't know. It was faded.
This has a little scratch over there. That's a shame. But other than that, that's a very nice one. And the same thing, I went online, and what I do normally is I go online and I do a lot of research, and I'll talk about that on that I'm gonna show. I do a lot of research because I want the monitor to be as close as possible. Yeah.
Does the tilt on the bezel work?
Hell yeah.
Hell yeah.
And I'm very proud of it. Yeah. No, that's what I want. I take a lot of time to measure it, then go online and look at the measurements because I'm not going to buy it. And then if it doesn't work, I cannot return it. So I check the measures on them and, make sure that everything's fine. And finally, I found this one I think is a 12-inch screen. And I had to do some cutting in the inside because there's some plastic things that you got to take out from, but it doesn't affect the rest of it,
Are these is that particular monitor dangerous to work on the inside, like some Commodore monitors, you have to have special trick screwdrivers, gouge it?
Oh, well, what I do, to be honest, I go to my CRT, I open it up, I put some gloves, I put myself on a mat, and then very carefully I take it off, put my CRT in a box, and that's it. So, I disassemble everything and the CRT is gone, and I work with the plastics, basically. Yes, very careful. And if you guys are going to do it, be double careful. If you know how to degauss and you know how to take out, how do you call this?
Screwdriver.
Yeah.
It's a magic way to.
Yes.
I've always seen it done.
You're short.
Commodore monitors.
Get it wrong, boy, you're gonna.
Well, if you get it wrong, that's the last time you get it wrong. So,
It's only gonna happen once.
I've met people who got zapped on it.
yes.
Oh, I'm sorry. I was.
Oh, I thought you were
No,
have a question.
I was enthusiastic.
Okay.
I think we're all enthusiastic.
Yeah, no, I mean, it's very cool that, you got to be very, very careful when you take out the CRT. But once it's out, you don't need anything from there. Just maybe the LCD and the connect, a couple of connectors.
Box go with the CRT.
No, I got it I normally either sell them. I'm not going to trash it.
Yeah.
I mean, I love those guys. And again, I've been chatting with people and people say, oh, you shouldn't do it. You should try to fix it, or you should. Yeah, but that thing is it's not gonna last that much, and I'm not gonna trash it because that thing is important to me also. And if somebody, it's a working monitor. So if somebody needs it, it's better to send it to them. It's
But somebody's got to degauss it though.
Yeah.
You have to discharge.
That's their problem now.
There are a lot of videos on YouTube about how
Yeah.
to discharge fly-by transformers.
To be honest, what I do is I normally wait like 2 weeks before I start working with them. I heard that. I mean, that's what I heard, that 2 weeks is a little bit better.
I don't believe there's a time frame. I would degauss any monitor I use.
I'm taking you to my house and do it. I don't want to touch it, man. I'm afraid of that thing.
As somebody who used to repair TVs, color TVs and black and white TVs, nobody's ever killed themselves with the shock. It's not the electricity shock that is a dangerous thing. It's the fact that you may drop the CRT or jam it with a screwdriver when you get shot. Because when you get implode the CRT, that's dangerous flying glass.
Oh,
It's not the
yeah.
shot, it's the broken CRT.
And also I saw that, I heard that the gas inside or something is not good.
No, it's just a vacuum.
Oh.
But the glass will fly right
Will
through
shatter.
the hole and be all over the place, yeah.
I've done that. That hammer, I didn't know what was gonna happen.
CRT is the first thing I.
You're still here.
Put on the side, exactly. And the same thing on, going back to this one, yeah, I was making sure that the tilt worked. And the tilt worked very nicely. Same thing, just keep everything, as original as possible, Same thing, connect the adapter.
These are beautiful.
Thank you, and I love them. I love that they look original, and look, the quality of the text is not bad at all. Not bad at all.
Do you have a weight differential? Like what weight?
Oh,
before,
yeah.
what weight after?
Oh, that's one of the keys that I like also. This one you can lift it with one finger. One finger, I'm telling you. No problem.
The color is gonna make the biggest difference, because the black and white tubes are much lighter weight. There's something fascinating I learned that I never saw before. Those things you see here that this exists. There's a color version of that.
There is?
Yeah,
Yes.
The Color Monitor 100.
Yeah, the RGB one, right?
The digital RGB for the 2.8.
Somebody here has it.
Yeah,
Really?
there was one in.
Who's the one doing the gaming tournament later?
It's Michael Stern.
Michael, he has one in his room.
He does, yeah.
And
I have a broken one of my
because
storage.
color CRTs are so much heavier, that mechanism wouldn't work, so they motorized it.
What?
I heard that there was a motor.
It actually moves itself. It is the coolest
Yeah,
thing
it's
I've
got a
ever
button
seen.
that moves the tilt.
It's a different model.
Wow.
Looks like the Monitor 2.
It's a different
It's thicker,
model.
it's got a motor.
You could put a motor to this one, actually. There's a lot of space in there.
It's a different
Once you take out everything,
You want to put the motor? You want to put the motor in? Oh, yeah.
you can put a diesel motor in there, guys. There's space to spare.
Here's an option for you, okay? I want the conversion, but I want the weight, the original weight. You can
No
put
problem.
some
I got some
rocks,
weightlifting.
We'll put the
Yep.
lid in the bottom.
That's it.
some rocks at the bottom or
Couple
the rings.
of stones, couple of rocks out of the gardens.
More shots about the text is not bad. It's very readable. Yep.
Does this save a lot of electricity?
I suppose. I actually haven't tested, but I'm sure it does.
LCDs won't draw as much as CRT.
It's 12 volt.
It's a Sear 17.
And the other thing too is that it's,
I'm gonna go from 60-something watts down to 5.
Yeah. Something like that.
you're not gonna heat up your room as much.
That's true.
LCD as well.
This is another one of my.
Bring in a heater next week.
Oh yeah, that's one of my favorites. So this guy is, I bought this one. It was I replaced it, and I got this monitor is a 15-inch TV actually. The LCD is a TV that I bought online. It's an LCD TV. I disassemble it, and I got this is kind of different because the LCD is inside a metal cage. The quality of the pixels here is almost the same as the Night Owl. Let me see if I have another one. Yeah, look at you can see everything very, very good. It's really, really good quality on the video. And this thing goes all the way. Oh, well, yeah, I mean, it can go almost to the edges in some games. So this is the inside of that one. And as you can see, there's same thing. I try to arrange the things over here. I put this one, I have some plans for the future. So I want to see if I can add support for the GS, the 2GS. So I added the cable on the back that goes to the BGA. So I can connect a BGA through the back. And also I got 3 connectors. So maybe in the future, those 3 prongs on the back, I put 3 video connectors. So maybe I can put also a selector, so I can have 4 computers and just move a selector and get the image. No.
It was from a TV.
Well, the TV came with speakers, and I could put the speakers, but I have to bring the audio from the Apple II. So
You got the input on the back. I figured
Yeah.
Put the speakers in the monitor case.
I could.
Yeah.
Well, I got space. You're right. I got space spare. And that thing is, what it is big. When I pick it up like this. I put it on top of the 2C metal thing, and it almost falls down because it is not. It's so light.
Yeah, I bet the weight difference of that monitor
It is.
probably the biggest.
Yeah.
That's a color too.
Yeah.
Well, it's a big one too.
And as you can see, it's a very big thing. I had to do some modifications. As you can see, I had to cut some of these guys to make it fit. But you know, it's no problem, and everything screws back again. The screws that really matter here that go all the way up, so it goes tight in there.
So that's that VGA connector is part of the original television driver board, I guess?
Yes, yes, it comes with VGA. This is the power VGA. I think this is HDMI, and
Oh, so you could even.
I can put HDMI. Yeah.
So you could actually hook that up to a Mac.
Oh yeah. Oh yeah.
Well, you could also hook it up to the Apple II pipe card.
Yes.
And be able to use the input switcher.
Oh, yeah.
To switch between the 2GS and the Apple II pipe card.
Or to the
Yeah.
CPU.
Yeah. Yeah, definitely.
The carte blanche too.
Yes.
Also HDMI out.
Yeah.
I heard about that.
Yeah, that would be cool to use.
That's actually.
All right, this is an a monochrome monitor, an Apple monochrome monitor. It looks exactly like the GS. On the back, you see there is a difference. But this is one of the other ones. This is the same 12-inch monitor that I use in the tilting one. But as you can see, it's also very nice, very good. And as you can see, it keeps the same look and feel, the original look and feel. If you don't really see that it's LCD, you know, you don't see the difference from afar. Same thing, you know, this doesn't work and this works, you know, turn on, turn
How
off.
long does it take to retrowrite that thing for that condition?
That took me like a couple of days. That's a platinum, so, and it was really yellow when I got it, but yeah. And these things are beautiful because the same thing, you just got those two screws, you take them out, and it opens perfectly. So you don't break anything. Nothing has to be, you know, forever, so you can open it. And that's the same. Somebody had, this is a very nasty photo, but you know, somebody asked me to show this one. And there it is, it's same thing, you know, connection to the, I use these guys, you know, it's not elegant, it's not beautiful, but it works, and it's, what I like it, because it's wood, it's a little bit soft on the LCD.
It's also non-conductive.
Yeah, that's it. You're right. I didn't thought about it. All right, so those are my demo ones. And as you can see, these are the, let me go to the front so you can see the.
And you have these with you here at the show?
No, unfortunately, I have to fly over here because from Florida, it's a little bit of a drive. I would love to bring them. And the one that I brought is the piece de resistance.
Piece of resistance.
That one.
Resistance is futile.
It is. So there you go. This is the original LCD, Apple IIc LCD. I'm gonna come over here so you can see that. And let's run Tom Biddles.
Prepare yourself.
And as you can see, this thing now is really workable.
Put on eBay, it's ultra rare.
Well, this is not mine actually. So
No, Steve Jobs no longer applies.
exactly. So there you go, and it's beautiful.
It doesn't matter whether it applies or not, all you get to do is on the ad.
I just want to say, I think this
Hell,
is
you can call it a
great work that you've done. It's also just great because this is obviously something that can be supported for a long time forward. You know?
I think so, yeah, yeah.
So I think it's really cool.
And what I like about this one is that it makes it workable, something that was not even workable at its time.
That's true.
You know? And one of the things that I did also with this one is, and let me show you, if I disconnect it right now, it's self-sustained. It uses the same things as the original one. What I did is I replaced, of course, the screen, but also I used the original cables over there. What I did is I soldered the cable from here and then soldered the other cable from here. And I passed it through this is a new connector, but it looks exactly as the original. So if you don't know that it's color and this is the first time you see it, you think it's original, everything. So,
That part is so hard to come by, like physical 3. You know if it's 3D printable, and then you can take your magic to add an LCD to it?
if you give me a 3D printed, I can add it, and very easily. The problem is that 3D printing something like this, even this size, I don't know, ask Charles, but it's expensive, I think. Still very expensive.
Yeah, but it's cheap. I mean, you do know before you did that monitor was
Okay, but let me tell you one thing.
$600 on eBay.
After $500-600, you still can't read it.
Exactly.
But this one 3D printed is like $600.
That much money?
Well, I asked Shapeways. I sent a quote.
Whoa.
So I don't think it would be feasible. You know, that's what I'm saying about 3D. I love it, but and also I was having that conversation before. I don't know if the plastic, like for this one, you see how it moves. If the 3D printed plastic will withstand this, you know, this force.
Did you get a quote for just regular the string PLA thing, or did you get for like powder?
I just did plastic. I'm not very good at that. Yeah.
Yeah.
Oh, this is well, it's not a long story, but this took me like 8 months to get everything. You know, I was just looking and going to a lot of websites, to Chinese, most of them, you know, of LCD providers, and you know, checking, taking, measuring, making sure, you know, go back and forth, back and forth. Finally, I found one of those. Funny that they say one of those visors that they sell, monitor visors that they use for truckers, and that's exactly what they got. That's the exact size. So it cost me like $150, but it's worth it. And you know, I just have to do a lot of modifications, and it for me it makes sense.
That's not an Apple enclosure. Is that what you're saying?
No, the enclosure is Apple.
Okay.
The only thing that is not original is the LCD.
Yeah, the LCD is from a truck, like a truck driver's visor screen.
Backup camera?
This is a video that I have on the internet. Those are that's mine, and that's this one. And I was just playing with Karateka. So as you can see, it's one of the things that I like about this one too. And unfortunately, I just found out. I just talked to my wife, and she told me that she found the little remote. There's a remote that comes with that LCD, and allows you to change resolutions, change the. So it's not only widescreen, but it can be 2 more smaller, and there's a 4:3, so you actually can see things the right size. So I love that thing. Oh, another thing that I had to do is I had to do a modification here on the back. So as you may know, the original one doesn't turn on and turn off. So this is, I don't remember what this was for. I think it was for, this was for changing between like black over white and white over black. You used to click over here and it will show the LCD, like inversion, yeah.
So you can go out in the sun.
And this one was for of course, for brightness. So what I did is I left this open because this is where I point my IR. The infrared connector is over there. So I point my IR over here. And this one, what I did is I put, this is a funny story because the connectors that it uses are not normal buttons. They are the, how do you call them? The touch sensitive buttons.
No.
So I touch it and it didn't work. I mean, I touched it with my hand and it worked. But then I used something to touch it and it didn't work. So I have to buy one of those little pens, stylus with a little bubble on the front, and I put it in there. Exactly, and then I put inside like a little rubber band so it holds it down. And then when I put it up, it will touch it once and it will leave. And it turns on. So, so I that spent a lot of time just to think about it, how to do it. Look, here it goes. You do it once. You hear a little beep, and it turns on. And again, you know, this is
better than the original.
It is. It is.
I remember those screens came out, and I was in the shop and setting up the display,
and you're looking for the angle, isn't it?
I was trying to tell if I turned it on.
I use it, and again, you're looking for the angle. You're looking for the angle, and you cannot see it. And I love it. You know, it's
all nice and squishy, hard to read. Guess what? We never solved one.
Yeah, no surprise there. On-ball aspect ratio and illegible contrast.
Yeah.
So what's the problem? Can you hold that up?
Sure. More?
Not too far up. Got a wire on it.
Yeah, you're running out of flight there.
Yeah. That's what I got this and that. What those new adapters? Those are pretty good. The ones that Steve sell. Those are the. I think it's. Oh, there you go.
Oh, wait. Don't drop it.
No.
Step that way a little bit.
This way.
Yes, boss.
There you go.
Selling these on,
I wish. I wish. No, this is actually Sean's. Where are you, Sean?
I suppose if someone spent $800 on an LCD display and then sent it to you, you'd happily cut it for them.
Oh yeah. Oh yeah. Definitely. And I love to do this now that I know. You know, that I've already tried.
Especially those.
The demo mode.
The what?
Any way to get one?
If you get me one and you give me the money for the.
Javier, I think you have a budding business here if you want it.
Yeah, well, I wish I had more of those, you know, but no, and again, you know, this is. I think I love it because I'm very happy because, you know, it solved the problem that I had with it, and you know, it is now usable finally. So I love that it works and, you know, it can be used by somebody. A lot of times at night I just connect it over there, turn it on, and play a little bit down Beatles or whatever. You know, it's.
Just a question. You said that the LCD screen was from a truck visor.
Yeah.
What type of enclosure does the visor use? I mean, couldn't you use the same enclosure and use that as a custom enclosure for the LCD instead of looking for the original Apple LCD?
The original LCD that it came with,
Yeah.
it has like a little mirror on the front that is like a mirror. So if I left that over there, you wouldn't be able to see it very well because it was reflected. So I actually that's another thing. I put a transparent plastic, a normal plastic in front of it. I honestly, if I could have the time, I'm thinking about looking for a plastic company that can make me the plastic cover. What?
Stupid eBay.
Oh, okay.
Totally unrelated.
Well, you were trying to get one of those?
Say yes anyway.
So yeah, that I'm trying to get a plastic like that is non-reflective. I think it will look a lot better yet. So, but that could be done. You know, I can open it, take out the original plastic, and put another plastic, and that's it. It will work. As you can see, there's a video of it working too. And I think I had another video that shows the different sizes.
I remember seeing the photographs of how the different aspect ratios. I don't remember if there was.
Another cool thing about this monitor is that the text, the 80-column text, looks very nice, looks wider. So there's, no, I thought I had it over here in my videos, but no. But anyway, any questions, guys? You know, any comments?
Comments? Have you considered, you know, the way modern laptops have a foldable case?
Yeah.
Have you considered fabricating something that would maybe just, you know, rest over the keyboard and have a way to like prop it up? In other words, like sandwich it shut.
I was thinking about it, but you know, Quinn is working on something like that, and I don't want to compete with Quinn, man. You got to be very careful there, man. So, I don't know. What do you think, Quinn? How's your project going?
Well, it broke, so, you know, great.
Why? I mean, can I ask why it broke, or you don't know, or? That's what I say about the 3D print. It was 3D printed? That's what I say about 3D print. But I'm afraid. I'm not an engineer or a structural engineer or something like that. But I think what I have seen in 3D printing, that it's a little bit too soft and too yeah. So you won't be able to
put stress on it.
Exactly. And it's beautiful because it's 3D printed, but I think it will have to be injected. Or
it can be strong. It's just 3D printing is not the magic push a button technology.
or like put some things in there to make it stronger, some beams or something like that. I don't know. Exactly. So that's what I've been thinking. Yeah, it would be nice to have one of those, but it will take a lot of work, not only in that looks good, but also structurally that you gotta be using it day night.
But think about that. An idea 2C in there, and
I would love
screen
that
folds
one
over.
with the 9-screen inch. I would love it. The thing is that I gotta find a thing that works over there.
You need an enclosure though.
Yeah.
So something that would fit over the entire thing.
Yeah.
And then come up and be the size of the whole thing.
Mhm.
Wouldn't that be cool?
Well, how about, like, instead of calling that route, like, finding an existing case, like a briefcase, you just have the 2C in there, and you have the monitor mounted on the back. of the briefcase.
It's
That can use-
it makes it very clunky.
Okay, Q. Is it gonna have guns in it?
Yeah, well, there's probably space for that too. Put like a little elephant gun there.
Yeah.
Question. What is the process of the retro writing of any individual piece? Do you code it? Oh, you
That's
have a
another session.
Oh, okay. All right.
That's another session,
There's two Apple IIe cases up there.
We'll do
sitting
that.
Right,
We'll do
right
that.
now, waiting for you.
But this is about color and
Watch out,
brush.
if you sit too long in one place, you'll get retrobrided.
Yeah, actually, yeah.
He's gonna retrobite my shoes.
I'm telling you, man. That's it. Anything that's right about it. But again, guys, I love the fact that the cool things about this. It gets lighter. That's what I love. That it's new technology, so it's at least it's gonna have nicer looks, and you can control more things. You can replace it. It's not that expensive to replace, and there's pieces for it if you ever break it. I just broke one that I was gonna bring, so that's another thing,
And it's color.
It's color, and it looks the same as the original one.
And
So
it's acceptable black and white.
it is, yes. It's never gonna be beautiful CRT. We love it. We love our little scan lines and everything. But you know what I think is the next best thing? And the way I have done it, at least I think it's acceptable.
Yeah.
Like, look at that. That's what I was telling you. It goes from top to bottom. Everything. The graphics are beautiful, big, and then you can, CRT normally it's a little bit hard for your eyes, and LCD is a lot lighter for your eyes. Yeah.
Do you have any advice, right, taking out the LCD, like certain manufacturers or countries? Or these things are kind of random.
It is so hard. There's a site for LCDs from China, but unfortunately, that's another thing. You're right. That's another balance that you have to be doing. You can do very good, top of the line, but it's going to cost you a lot of money, a lot. And you can find a Philips, and I'm sure I can find a Philips monitor for that LCD that gives me awesome quality of image, but it's going to be custom made. It's going to cost me at least $800, if not more. And I don't think it's cost benefit. These things are more a hobby. It's not, unless
Get you
you're.
90% of the way.
Yeah, exactly. And
or 20% of the money.
again, these guys could be a lot sharper. Could be like the Night Owl, but you know what? Are bigger, and they look very good on the color. This one is very sharp and it's very good and it's big, but it's a TV, so it also costs a little bit more. But that's a little bit of cost benefit. So it's still.
Can you put the tuner in that? Have it be selectable?
Oh yeah, yeah. It actually
Well, if it already has the original board, all you need is to have like a coax
Cool.
Yeah.
Cable going in the back.
I think it's also worthwhile to keep in mind, guys, that it's composite.
Yep.
And a VGA solution were to come out would address all those issues. So you no longer have fuzziness, you have more control as well. So trying to get a better screen to kind of deal with composite, kind of like trying to get better tires in the car to make it go faster. It's just kind of a way to do it.
No, yeah, actually, yeah. There's, yeah, go ahead.
I'm just gonna say that if you have a 2C or C plus, you don't have the option of playing it harder.
True, true. That's another thing that I've been investigating because also I got a GS and I want to use these guys with the 2GS. I was playing with a Gnobes or Gombes. I don't know what the name of it is. That one, the GBS 200. I bought one, I connected it, but it makes, at least in this monitor, it makes it too sharp. And what looks like blue in a normal GS monitor looks like lines over here, too sharp lines. Also, it has some, like the bottom has some distortion all the time. And I tried to modify things, change settings, and it was kind of difficult. Another thing that I found is FrameMeister. I read that it was top of the line, you will be able to see everything good. And other thing that also needs to be done in these ones is you need to be able to resize the image like a normal monitor and move it around. That's not possible normally on these ones. So what I have to do is, like I told you, little tricks to move actually the LCD so it looks centered. But those are the two things that I would love to have in a card, that you could move it around, you could change the size so you can use the most of your screen size. I'm sure in the Night Owl the same thing. I'm sure it doesn't go all to the edges. So that's one of the problems over here. So if you don't go to the edges, that's why I like these ones, because at least, you know, they don't go to the edges, but the edges go all the way in a little bit more. So
you have, yeah, you're basically, the physical screen size is oversized from the open and the bezel, so you can maximize the open.
Yeah, and it would be nice to be also affordable, because yes, I can solve it with a $400, $500 FrameMeister, but you know, exactly. So it needs to be affordable at the same time, you know, modifiable or something like that. So those are the difficult parts to do. So if you have money to spend, yes, you can get beautiful, sharp, and actually with scan lines and whatever you want. But yep.
Do you have a website where you kind of talk about some of your solutions, some of the parts that you found in that? It's called Facebook.com.
I got all my new ones are in Facebook, and I had a blog, but I haven't updated, to be honest. So I'll put it anyway, but you know. But you know, the new ones, everything new, I just put it in Facebook actually, yeah. Any other question? Well, but hopefully, you know, I covered as much as you guys wanted, and hopefully you don't have any more questions. And I wish I could bring those ones. Those are really nice, I'm telling you. And again, the best thing is that the lightness. It's so light. You can bring it with you everywhere, you know.
You're just going to have to do the Miami Fest.
There you go. Not bad. On the beach. Thank you very much, guys.
That would be the
So we have another 15-minute break, and then at 2:30, Jason Scott will be doing a session. And then we're not going to take a break at 3 after his is done, go right into Dagen Brock's session. So 2 back-to-backs, and then we'll get another break.
I gotta rest up for Dagen. Excited.
And what's the next
Absolutely. Light and power.
That's why it's so hard to find. Although why we pay $800.
Well, I knew that.
However, that goes like that.
It's they use for trucks.
Why is it reversing point?
Well, you know, I use.
It has
Really?
Yeah, a lot of the car.
Oh, that belongs to
so that you just run with a single
Oh,
cable.
you mean the color?
They just have a.
Maybe they're easy to produce and cheap.
Yeah, they just have a single cable that pops in the power.
It's quite the open price. Well, I
yeah, it's very good. I don't know why it doesn't use that.
But in reverse, you'll carry the camera.
So it doesn't say anything.
Well, a friend of mine says that he bought
That those little.
Maybe you can push the button and set it.
Okay, that's it, city did.
1,000? Yeah, I asked.
No,
there's
something that you have to check. Well, you guys have.
Yeah.
You can see it inside. Yeah, that's pretty cool. It's cool, isn't it?
Yeah. You know, the weird concept is so it's barely, it's completely like one of our contact. And so it's like it's you draw.
But you can.
Yeah. Oh, yeah, yeah. Yeah, it's like that, like computer apps, you know.
No, it would work good. I can open it.
I have sent an email to that guy after the site finished.
Oh, yeah?
So haven't heard back yet, but I have sent that. Yeah. What's up?
All these people take
Yeah.
I'm getting signal. I think there must be like a little. Yeah.
Great talk.
Thanks. Just enough to not leave me out.
Hey, Javier, smile.
It's not three-dimensional.
Hey.
Well, there were some options that same. In the picture, you only see one. Now, it says there's one.
Is that part of sample flat screen?
Yes. Yes, it is. Yeah, this is part of it.
Oh, okay. Oh, yeah, I've never had that.
No, they were useless and very expensive at the time. I can't remember how much. But it was
Oh, yeah.
like $500 or something.
Especially with
It wasn't that high. Well, I know that if you try to get one now on eBay, $798 the price.
Oh, for what?
No, not that. The original one. On eBay
Oh,
today.
with just black and white.
On eBay today.
LCD unreadable screen.
Right.
Oh, yeah.
Oh, I had to know it's. I'm gonna go to your thing and you can see it. It's giving me some.
Well,
photos,
it's
like,
probably.
it needs to get like different photos. I gotta open it. Maybe there's something else. What's the original one? You'll see. You'll see it. It's replaced inside with it.
Every single one.
Yeah. It's original. Everything's original. Oh yeah, no, it wouldn't be this size. It would be.
Oh, you're gonna go all the way down? That's what I think. Which means now you're gonna need support on the back.
What you do is you do something that goes over here.
Yeah. Is that what Quinn does?
Well, no, I don't know, but the seat here. That, so you can support the.
But with an LCD, the weight should be in the enclosure, not in the LCD. That makes me have to extend it further so we can put the battery in it.
Pretty well, I thought battery.
Or
take out
I'll do a YouTube video about
power replacing the battery.
I'll unbox the box that I got here.
Take out the 3.5 inch. Take out the 3.5 inch disk drive and put the battery over there.
Yeah, you can keep battery all functionality away from the machine.
You have to put the
But then you put the SD, yeah, you put the SD drive as part of it.
You know what SD
Instead of 3.5.
The latest
There you go.
it's inside, and it allows you to use a floppy or boot from the machine. So that,
All this is like, it's gonna be like a tank with rockets coming out of it.
Yeah, I don't know what's wrong with that.
Sure, man. Yeah, let's I'll go to your place later because I gotta fix this.
Okay. Yeah, you know where I am. Just stop by.
I'm moving away from it. He keeps yelling at me.
Maybe.
Sorry, man. You got watching it, you're getting upset.
I was thinking, why are you yelling at me? But now I see a camera there.
Camera on top.
Yeah, I didn't know that. What's
Sorry. It wasn't personal preference.
Thanks, man. Appreciate
that now occurs to me why.
So I gave you.
It's okay.
I gave you an assist.
You did. Thank you very much.
Now when you go to flip it, you're on there, you go straight through, you'll hit your chin on the table, and then you'll die.
No, I'm afraid not. But I think I'm gonna get back in the back instead of coming up to the
I
front.
lost and then I bought.
Okay, I won't have that.
No,
I could do that, and then I'll be in person.
Very angry.
Are you angry?
I've never seen such.
I'm just hoping whoever was sitting here during the presentation this time is not going to
There's no name.
I figure I had some reserves yesterday.
Doesn't work that way.
You know, I think it was fantastic. That actually resurrected it. Yeah, I love it.
I wouldn't be surprised. I look up
Oh, she's got the 9-hour one. I didn't notice that. How about that? There's the cable.
Yeah.
Who made the cable? Who made the cables? I forget. Who made the cable? The 9-hour cable.
So I have to watch that video.
Yeah. Who's running that session?
Yeah, actually, it's the aluminum part.
I have to read this.
It's basically better.
All right, let's find out.
Desoldered everything. Yeah.
Not that way over.
You can do it. All night long. You know, shipping that stuff.
Hello, Andy. So how all this web thing working? Let me. What do you got? You got as I expected. I have an adapter. I don't like showstoppers 10 seconds before air. So I'm going to stop the recording. Let's start up again.
So you can say, well, it might.
So,
Spontaneously shut itself off.
Well, it won't when it's plugged in, which is the thing. That's why it's just frustrating enough to bother me.
Do you need sound?
So give it a moment to get its thing together. I see we're rocking.
Well, I'll unbox the box and I'll do a little bit.
Me, it's probably 1024.
Once I realized it was a business expense, I won. What you and I were talking about? I've been on. I've been on balls. I've been on 5 before on 1. One of the EZ cartridges from the landfill. I got garbage. I got one.
Well, there.
You got one?
I did.
And?
And what?
Yeah.
How
much?
510.
Better than 618? But they've got things that are going on all through the night. This guy must have 150 of them.
Yeah. But I'll do a YouTube video about it and I'll make money off that.
Okay.
Cover myself in the bar, find out how.
Sounds like clickbait.
Hi, George. George. Hi. Hi. Glad you made it. I haven't seen you yet this week, have I? Yes, you have. Oh, I have? In fact, you waved and said hi, George, up there about a day ago. There are 73 people here. I can't keep track. This is the biggest K-Fest I've ever been to in 18 years.
The biggest or Ken?
I'm getting older, George. I can't remember everything.
No, we'll plug him in a
Oh,
minute.
you
All right, yeah. Now, let me turn that off and we'll do the next bit.
Sure.
And so, Mike, what makes sense is if you, when I stop it and start again, if you look at it, you really should. So when you see me do it, see how the L is jumping because the L is ambient. Like it will always, like if you notice it's not jumping at all, that means this cable went bad again.
Which one?
It's this one to the smooth one, not the bumpy one. Yeah, yeah. Just so you know,
So I get it.
you jiggle it until it'll go.
So I start to see input on that.
Yeah. Let's do it. Nobody's going to get a picture of how beautiful I am. That's sure. All right. And so it's the whole thing. Well, how far are we? What time is it? 3 minutes? Good.
Chris Barnes.
Testing. Test passed.
Yeah, the assembly line's publisher. And he said he could be carrying around.
Well, see, yes, he.
Happiness.
What do you need to?
Standing in front of my own thing with a pointer.
And multiple nights.
That's right. And if you want to, you can actually press this. Do this.
Thank you for that
Press
advice.
this,
He might have put something around.
do
I'll take it. I'll take it.
And yeah, so you're supposed to do it in such a way. Oh, that's right, you do that, and then when you, so, see what's on that? And you press that one, and then you go like that. Oh no, I can stop. Anyway. Yeah. That way you could be like, yeah, and be able to see what you, yeah, exactly. It's cute.
I made an announcement before, one more time. If you're interested in doing the kit building workshop tonight for Vince Briel and you didn't pre-order a kit, we have one GS 4 meg RAM card $45, pay James Littlejohn, and then you can get in on that tonight.
That was a nice ad, thank you.
Nice. He paid extra for that.
No.
Well, we almost lost Jason Scott to the Library of Congress. There was heavy competition this year, but luckily we won out. So to our benefit, here's Jason.
I see. So what he's referring, okay, so how many people here, this is your first KansasFest? Boom, keep your hands up. How many of you have never heard of me before? All right, so the Library of Congress was going to have a software preservation meeting that started basically tomorrow. And so they wanted me to go, and then they realized that they're idiots. So the entire event got canceled. A few people got screwed, but I didn't. I get to stay to KansasFest the whole way. But it was very, very hard. Very, very hard for me to not be here. So it really annoys me. Anyway, so I was like, really? And how do you explain it to the Library of Congress? I'm like, oh, there's this Apple II meeting I've got to be at because I know what matters. Anyway, so Library
part of software preservation.
Yeah, well, yeah, the upshot is the Library of Congress does not understand software preservation, and I don't really have any faith in them going forward. So anyway, hi everybody, this is Jason Scott again. I'll tell you who I am and what I'm up to, and you know, I talk a lot when I'm here off in the corners and everything about things I'm working on and stuff that kind of overlaps stuff of interest to KansasFest. So I thought, hey, just take 30 minutes and we'll just quickly go over 5 things where I've crashed into the popular culture with the Apple II in the last year. Some of this you might know of, some of you won't. If you follow my Twitter, I'm Text Files, and you'll see me constantly go off about that. I just punched Twitter in the face for about 10 minutes just before this speech, so more people are watching the stream than perhaps should be. But, you know, I also talk about, hopefully, nice things that are going on in the world. Anyway, so, like I said, I give things really quick. I don't make any sense half the time, but one of the things that's really important to me is just doing stuff everywhere. So when I get involved in projects, the Apples are one part of that, but I'm also got my hands on a lot of other things. But the Apple II community particularly matters to me, especially the KansasFest community, because it's one of the few real honest communities I deal with. Because I spend half my time in New York and half my time in San Francisco, where nothing can be done without at least some patina of irony and self-awareness. And what I would much prefer is a situation where people are doing things for each other because they want to help each other and not because it gets them secret points on their little geek cred card. So thank you so much for being real. Anyway, so I've been a whole bunch of different things over the world, but you know, one of the things that I'm mostly known for these times is being the angel of death. And angel of death means basically that when things are going down, software is disappearing, websites are disappearing, I show up, which means you know things are really bad. More than once, there's been cases where people are like, oh God, Jason's tweeting about this, we're screwed, get your stuff off. So that's what I do. And the place where I do it is here at the Internet Archive, which is located in San Francisco and the Internet. And it's the Internet's library, and that's what it's intended to be. It's a 501c nonprofit that is run by a crazy deranged millionaire who has this dream to create the Library of Alexandria once more online and put it in asbestos underwear. So the Internet Archive looks like this these days. One of the biggest things that happened in the last year, not related to me, is that the Internet Archive upgraded its interface. So the biggest issue that people had with it before was that it looked like a spreadsheet combined with a tax receipt. It looks like this now. It's not perfect. It's got issues. It's got boopity bops, but they upgraded they did a 15-year leap in what they did. And so as a result, there's now more robust APIs. There are better interfaces to software, and we even have a Python interface to the Internet Archive, which is how I do things and upload thousands of things a day using it. So place is even getting better. Inside, still wacky. Not many data centers look like this. The computers are actually there in the corner where they should be. And throughout the area, there are these little people. And if you work at the Internet Archive for 4 years, they give you a little statue. Because as my boss puts it, we don't have any 401. Well, no, we don't have any, well, we have a 401, but we don't, it's a 403B, but we don't have stock options or weird little cabanas that you can like get for the weekend if you're doing good sales. So instead, we'll just make a little plaster version of you. And you're like, Jason, you've been there a while. Yes, so there's a little me who lives there. He's clutching some software to his heart. And the woman who does it, Nuala Creed, interviews you and talks about what you like and what you're into. And she tries to get all sorts of pictures of you. And she created this little guy. And he's actually got little black angel wings now. I bought him little child's black angel wings. So he sits off in the corner and people are like, what's up with the guy with the wings? Who knows? So the thing over here is the petaboxes. Each one of those is right now about 1 petabyte of data. We get about 3 million visitors a day. And we've actually upgraded from 4 to 8 terabyte drives now. So actually those are going to become 2 petabytes apiece. And we've got 21 petabytes of unique data as of the last couple of months. Most of which is to the public, some of which is web crawls and everything else. I've been involved in being an Apple fanboy for a very long time. Here's me at 11. I insisted that my father put me next to the cube and take a picture. So anyway, I'm long into this thing, and now I'm just swimming in it, and it's a good world. So what I'm going to do right now is I'm going to do what I called 5 Apple crashes. Crash 1, 2, 3, 4, 5, and this is going to be basically just cases where, in doing the work that I do and all the various bits, apples happen to come up as one part or something of it. So crash 1, the JavaScript mess, which was the project that I was involved in to create a JavaScript-based emulator that could emulate dozens and maybe hundreds of machines. That was it's now about 3 years we're now into the project. The project is now up on the Internet Archive. You go to a site, you click into item, you say, I wish to play Jumpman, and you play the terrible Apple II version of Jumpman, and boom, you're there. It's like you're living it. Some parts aren't perfect, some parts are better than others, but right now, millions of plays have happened. Part of that, of course, is because the JavaScript mess will do everything from arcade machines through to consoles as well as home computers. The biggest news, I guess, is that it's no longer called the JavaScript mess, or I should say the JavaScript mess is now one brick in what's now called the emularity. And the emularity is basically a framework that we've created where you can plug in any of a number of emulators. And the reason I had to do that was because somebody made a really good DOS emulator, but it was in JavaScript and wasn't JS mess. So then I said, okay, we need to do that. So my hope is to take whichever emulators are open sourced and do the job better and use them and then click them in and out as the best emulator wins instead of being committed to one. So as a result, we now do DOS really well. Mess itself has gotten better with apples in the last year. In their opinion, they've gone from being the worst to the best Apple III emulator. And that was because one of their programmers spent 3 months kind of reverse engineering why do we suck so hard, and then figured out like where that was and made it work better. So the mess emulator actually does the Apple III really well, which means hopefully very soon I'll have the Apple IIIs booting on the archive with a whole bunch of Apple III software, which would be a very nice experience for the 4 of you who really care about that. You'll be all set. I have a screenshotter that goes through and plays Apple and every other game and makes screenshots and puts them up. It's called the Screenshot Gun. Here's one that it just barfed up one day. I thought this was amazing because it was like, welcome to Soft Disk, it's the place of Mogarth. You boot it up, that's what it does. But yeah, okay, thanks. I like having old artifacts. This is actually what remains of the Ripco VDS, which is one of the most popular hackers, and that's what remains of Dr. Ripco, who ran it. This is one of the few Apple IIs that ever made it back out of the FBI. So if you want to know what it's like when it goes through and comes back out of the FBI, they look a little bit like that. And some of the software looks like that too. The most popular thing is the Internet Arcade, where I put arcade machines up. This caused something on the order of 4 million people to visit in the first week It got on television. It was a quiz show question. It got way out there. And if it sounds like it's too good to be true, it was for 400 of them. But 600 of them are still up. So there's a whole bunch of games up there. If you go to the Internet Archive and you go up to the top, it says go to the Internet Arcade. You can play arcade games to your heart's content. Same thing with MS-DOS. I see Jesse Bell's online. You can go to MS-DOS and play endless amounts of MS-DOS. And my hope is to have, this is a very well-made emulator, and I hope to have other emulators that do particular jobs well going forward. Again, I never played most of these things. A machine played a machine to produce the best screenshots and then made all of these. And then it created topics based off of going through the text in all of these programs to figure out what are the most common things it talks about, and then ended up calling it like, oh, it must be something about mice. We also have the 4 AM collection, which is probably the biggest triumph of the year, which is that we have a cracker, 4 AM, who is anonymously cracking these programs and then putting them up on the archive where they are immediately playable, and then including a description of how it was cracked and what to do. It's an amazing educational resource. It's a case of turning something into a living environment. You're able to go to it, try out the program, understand what happened, and learn it. And there have been attempts by people to learn who 4 AM is, and I say, keep the magic, don't research it. So the JavaScript thing is actually getting crazier, because this is where we've actually gotten Windows 3.1.1 to run in JavaScript, which is impressive enough to be able to have this, which is a JavaScript version of Windows 3.1, but then we were able to hook it up to a network through an emulated PPP connection. So this is actually Netscape 1.0 connecting through to an actual website, mine, using Windows 3.1.1. So this is a 1995 browser running in a 1993 OS, running inside of a 2015 browser inside of a 2010 OS. And yeah, anyway, so the future is probably going to be something about this. If you haven't heard about it, you don't have to go into it right now. Basically, the creator of JavaScript was like, I guess I really shouldn't have made it in 10 days. And he quietly went around, talked to Google, Microsoft, Apple, and Mozilla, and said, let's kind of try again. So WebAssembly is meant to be a failover. In other words, if it's not there, JavaScript works, but a failover replacement for JavaScript or augmentation. When this hits, it's native speed in the browser all the way down. And when that happens, emulators run at full speed. The world is crazy. So anyway, just wanted to warn you about that tsunami coming. Similarly, with things like JS Mess, the number one thing of the JS Mess project was to take the individual drivers of Mess and Main, these emulators, and we wrote scripts to split them off. In other words, you would say, just give me enough code to run Pac-Man. And then you would emulate it, and then you would end up with just a Pac-Man program, which was smaller. Otherwise, it would be many megs. When they upgraded the build system of Mess in the last 2 months, and by the way, have now gone open source 100%, they're now tracking down 15 years of sketchy running people who did various programs for them over the years and saying, will you please switch to open source? And they're doing it. You are going to have this open source program that with the build system does per system builds, which meant that we influenced them to some extent, which I'm very happy about. So that meant that 80% of what JSMS does, it won't have to do anymore. Main will do it. So I'm very happy about that, because it's not good to have volunteers working to do a thing that somebody else can just make an option. Anyway, Crash 2. I'm still running around speaking like an idiot, going around a bunch of places. I'm still dressing up funny and still saying things. I'm still making public appearances. I've been in Sweden. I've been in England. I have been in Atlanta, and I've been in Boston, and I've been in California, all up and down. And the reason I do that is to give a voice to ideas and opinions and needs that other people may not be comfortable doing on stage. That is literally why I care about doing it, which is to go around to people and say, this is actually really important and this is meaningful to people. And if you've got stuff and you didn't know where to go with it, could you please at least talk to me? And so being that lightning rod has actually worked out really well. The highlight for me personally was hanging out with Ernie Klein, who's the creator of Ready Player One, because it turns out that JSMS is kind of the Oasis, in that you can like play old games instantly. And when I talked to him, he was like, oh, you really influenced me and everything else. So there's like a, you know, we were at South by Southwest, and while we were there, he was like, we'll have lunch next week. And then like the next day, the news came out that his book had been optioned to be done by Steven Spielberg. And then it became, he wasn't answering his calls all week. Anyway, oh well. This is the best news to ever come out of one of my speeches. This is a headline. Why are we trying to create Ready Player One's terrifying nostalgia-fueled dystopia? And it's all about how the Internet Archive should aim its sights higher than to create a terrible world where young children emulate games of the 1980s as something to lavishly worship. And I was like, this seems like a straw man.
Writers got it right.
Writers got it right. Yeah, I don't know what's going to happen there. But then there's positive ones. Like, for instance, one day I announced that I wanted to have every AOL CD. And this actually got a lot of attention. And so NPR did a story on it, and I have gotten hundreds of AOL CDs, which has been very, very interesting. And I'll show you the result of that in another crash. But anyway, so people have all these different ideas of why I'm doing it. And I know your question is, Jason, why do you sacrifice your time so much to do all these public appearances? And I'm just saying that in the ultimate approach, it's really, really seriously about being an advocate for the voiceless and an advocate for software, hardware, and experiences that otherwise wouldn't get the attention of people with money, resources, time, and interest. So anyway, that's where I'm going with that, and it's been a great year for that. Crash 3, here's me, sick as a friggin' dog, along with most of the corpus of Walnut Creek CD-ROM. Because of the AOL article, the Walnut Creek guy who had founded it said, do you want all of the CDs in my garage? And I was like, yes. I can't see, but sure. And it was a relatively advanced car, and I could hear the whenever I hit the side of the road. So I was able to go to the place and get all these. There are doubles, so I sent some to Stamford, some to the Strong Museum of Play. So out of nowhere, they got boxes of Walnut Creek CD-ROMs, a lot of them. I've already imaged all of them. They're all going to go on the Internet Archive. My plan is to have something like 5,000 or 10,000 CDs imaged on the archive by the, maybe not the end of the year, but I can get close. And I'm not even caring anymore. Like, I don't care if it's a printer driver from 1992 or if it's a file. And this is relevant to me for the Apple stuff because what it means is that as I do more and more of this, more and more people are coming to me saying, hey, I have software. Can you do anything with this? It's on black squares. And I'm like, yes, I can do something with it. These are Macintosh CDs. I haven't gone after them yet because I've just been finishing up the other set, but these are piles and piles and piles of old Apple collections of all types, cover CDs. This is from one person. And multiple people have gone like, I guess you should have this instead of trash. And I'm like, yes, I am your trash. In fact, it gets really kind of crazy. This is the Rhode Island Computer Museum who contacted me and said, yeah, so we got all sorts of crazy junk, all sorts of weird old apples and weird things and lots of old machinery and stuff. And then there's these boxes over there. And in those boxes are Apple 5¼ inch floppies.
Oh my God.
So each one is opened like that. And they're like, do you want to image them? And I was like, yes, I would like to image them. So I'm imaging them. Crash 4. This is a Apple II that is inside of an NPR studio. And the reason for this is because Meg Kramer of Marketplace Tech was like, I would love it if you could help me. I want the experience. I was born in 1989. I would like to know the experience of typing in a program from a magazine. And I was like, I don't think you do. And, you have to strike this kind of balance in the modern era because it wasn't a case of because you are a young woman. It's because you should not have another human being wish this upon you, even at your request. this is the kind of project that needs a safe word. And the thing is that she was still adamant about doing it, right? So what I did was I got her an Apple II with a single floppy, tested it as well as I could, and then gave it 3 compute magazines. One with 10-line kaleidoscope programs, one with a 1-page Apple II text game, and one with a 32-page hexadecimal all the way down mega. And I said, you are a winner no matter how far you run in the race. But you will not come out of that third one the same person that went in. And she recorded me to get all this experience of the crusty prospector going, no one comes back from Devil Mountain. So anyway, I don't know what's going to happen with that, and I was worried that she would just kind of put it aside. We put it on a mobile cart so they could wheel it in and out of the studio when she works on it. And she was stunned that she had to just, like, turning it off was just kind of the best way to deal with almost everything. Like, she was just like, where would you? And I'm like, no, just beep, beep, start over again. And I gave her a floppy that said Meg's floppy that makes her so friggin' happy. Anyway, she sent me this letter, and the letter was, I typed in the code, but I was having trouble against the high-res graphics, so I took some out, and here are the changes I made in the AppleSoft. So I think it's going to be a good ride. Anyway, Crash 5, I went to the Apple II reunion party that was held by John Romero and Brenda Romero just a few weeks ago. John just decided he wanted to do kind of a sequel. John is switching homes. They're going to find a better place for themselves. I'm not the person to say where they're moving, but, you know, they're moving, and so they wanted to have a nice, hey, let's have a bunch of people over. So they did. They actually had a bunch of people over, but their house is actually kind of cool. He really does like Doom. So this is all dice, by the way. This is just a big thing of dice, and this is a mural on the side of their area. Anyway, so it was a very nice affair. It was a very pleasant affair. Had a whole bunch of people for whom I don't even want to pretend to know all of their names off their faces, but you'll recognize some of them. You know, creators of things like Dino Eggs, and, you know, there was even one very grousey-looking Steve Moretti right there with his glasses. There he is, giving me the look. There's John Romero. He's looking trim these days. He's looking pretty good. And they had some of each other's software out for each other to sign, which I thought was very heartwarming. And somebody brought a very nice pair of Apple II glasses. Oh, sure, you want a picture? Go ahead, yeah. I put this up, and I had somebody on Twitter flip out in kind of a, you know, like, Apple gay rights thing. And I was like, this is older than your ridiculous ideas, and probably you. But it's this vintage, custom-made, really expensive Apple II eyeglass kit. And then could you autograph it? And yeah, people were autographing it all through the time. There's Margot. And I interviewed a few people, which is why I was there. So I had a nice little interview with Mr. Wagner, our hero of wizardry. And of course, I interviewed Margot, and I created a 30-minute clip of what we talked about. These were all really loose interviews, and you can hear the party in the background. So, like, I mentioned that a lot of when you interview somebody about vintage computing, like you say, you interview somebody from like 1982 about something then, I say, it's like going to someone, what was the favorite sweater of your third grade crush? As it's, you know, just like, and you're like, oh God, how do you remember these things? And she said, here was my third grade crush. So there's actually a 5-minute thing about her crush, who was her teacher, and why her teacher inspired her. So I've got that here. I'll play it for people later. I've got to, you know, I'll play it here first so that you guys get it first. Anyway, good time, good places, good people, and it reminded me just how social everything about the Apple is, and just how wonderful it is that this piece of technology brings so many people together. So that's the 5 Apple crashes that happened this year, and I just wanted to share that all with you because you deserve it. Again, thank you for your time. How fast was I? Was I fast? Was I there? Am I on time? Have I wrecked lives? couple Anybody have any questions that aren't in the form of a story about yourself? Yes, right there.
We upload stuff to Internet Archive and take a disk image.
Sure.
How do we get it to automatically run?
Upload, right now it reads .dsk and .po and .do files, okay? So what you do is you upload the file, like say .dsk. You have to do a setting, lowercase, emulator to Apple IIe or Apple, well, you just do Apple IIe, make your life easier. And then emulator _ext. And if you go look at all the others, you can see this too. Emulator _ext and what the extension is. So like .dsk or .do. This was the easiest we could make it in our framework. I help people with it. Once you do that, a thing will boot up, right? Emulate this. To create the screenshot, you actually kind of have to upload a graphic, or my screenshotter can discover you. So there's currently 3,300 functioning disk images up on archive.org. Some of them boot to the monitor, some of them boot broken, but they are all up there. Right now, we can't do multi-disk. It's 100% a UI problem. I'm in line to redesign the software UI so that you can press a button and just go flip which disk image is in the drive. Just doesn't have it right now. That's the way you do it for that. It's a different way for DOS, and it's different for the arcade games, and it's different for consoles. But it's pretty simple, and I want more people to do it. Like I said, 4am just does it. I wake up every day, and there's a few more. And then there's people who are uploading DOS programs. There's a guy named Jeremy Penner. All he does is find the best shareware DOS programs. And DOS really took off. The week that DOS was announced, we had 9 million new visitors. People really wanted to play DOS. My theory is that all the kids who played DOS when they were in their teens in the 90s now run all of the web newsletters and blogs. They're all like 30-something and all being like, this is really important. Stop whatever you're doing. Good theory. Yes, Steve.
So I know you've got the convention play in the browser.
Yes.
And it works with Apple II and Atari and what other
Okay, so let's set aside the consoles and the arcade games. To varying degrees now, we can do DOS, we can do Ataris, we can do Atari XLs, we can do Apples of various stripe. We can do the color computer. We can do the we got Farfall. Farfall is running on the archive. We have there's some terrible Z80 monstrosity that we do. So that's funny. The Commodore guy.
Blue Atari.
Yeah, Atari. Commodore guy and I are still talking about this, about a way to do it. Like I'm not rushing to do the Commodore yet. The mess is too slow, and the other emulator guy kind of wants some friendship in the return. Not bad friendship, but just wants to do it orderly. But once he does it, I'll put up 100,000 floppies, so I can wait for that misery. Yes? The backup project, which is the project to back up the Internet Archive, which is as stupid as it sounds, is running very well. We've fixed like 200 bugs in Git Annex in the process. What we need right now is for someone to be able to go onto it and quick start up. We don't have a quick start yet. So we're kind of floating at about 33 terabytes of backed up material, which is significant, because, okay, sorry, I didn't even explain. So the Internet Archive is located mostly in San Francisco with mirrors in a couple other countries. And I wanted to create a Samsadat distributed backup and said, how would we do that? And we threw a bunch of people at it. And so now there is a place you can go, iabak.archiveteam.org, that will show you, and it uses no Internet Archive hardware, because what's the point then? So it's all contributed volunteer hardware servers, and it shows you how much there is and how many backups. And the idea is 3 copies in Yeah, it's 3 additional copy. Sorry, Internet Archive has 2 copies. There are 3 more copies that have to be geographically away from it. We have 103 clients in something like 25 countries that are each holding pieces, and then there's a fixity check, and then there's recalibration and all the trouble you can imagine. And what it's going to eventually be is you at home will help. You'll be miserable, but okay, thank you. You'll be home, and then you'll shove drives into your dock. Drives you don't care about, 1 terabyte drives that you no longer use, and you drop them in, and it backs up part of the Internet Archive and then checks on you. And if this sounds weird and ham radio-y, it is. It's meant to be this kind of last-ditch case saving of material. Because, you know, the Internet Archive is in very good shape, but, you know, I think most people would agree some of that stuff is precious enough to guarantee that it's elsewhere. That's what that is. Anyway, it's coming along. Any other questions?
Yeah, how do you have space and time to set these 6 hours a day to do all this?
Volunteers and people who help me, who I try to acknowledge as much as I can. There are dozens and dozens and dozens of people underneath every project that I am all sitting all on top going, look at me, which is part of why I get yelled at. Because some people will say, well, look, he's just claiming that he looks like he does all the work. But there's many other people who contribute time, effort. Kevin Savitz and I have spent countless hours where I am going, where he is going, I am going to upload many gigabytes of items. And I go, you are going to upload many gigabytes of items. And then I check on him in a month and a half. And then both of us are at the ribbon cutting ceremony. So there's lots of people who are just working away. I try to facilitate to answer those unanswerable questions so that each person goes, how do you, emulator_ext. Oh, fine, thank you. And just try to be that little extra push to get it. Or, yes, I will drive to your garage and grab every copy of Walnut Creek, including the one where he went, this one got sued the most. I said I was going to reveal what that was when someone asked, but it's GIFs galore. For some reason, GIFs galore seems to keep getting sued, what with its Disney characters and its Marvel images. Oh, well. Anyway, if you have GIFs galore, it's worth money. All right. I guess we have to move on, and thank you. And thanks to everyone else who's speaking today.
We're going to roll right into Dagen's session. Dagen, you ready? Oh, surprise, surprise.
Hi, Dagen. Hi, Dagen. One day I was speaking about things.
While Dagen's setting up, if you're new here, maybe you don't know this, but you're welcome to wander the halls, swipe your card and go into the other wings that you're not sleeping in, and check out people's rooms, see their machines. Everybody's willing to show what they have, so please realize at night everybody's doing cool projects. You know, stay up as late as you want and visit everybody. That's right. The quiet halls after 10, plain low, but the active halls are going till. You know, I saw somebody at 3 a.m. wandering last night, so people are up.
You want to get to the walls, is that with me? I've been reading, stumbling to the bed.
Is this DVI? Can I borrow a VGA adapter for this? I thought there was one. I have my own. I've got a DVI one, but
All right. There's a little microphone there. Click on.
Oh, sorry, guys.
Got it. Okay, here's Dagen with the Apple II SuperMegaSplodaGanza.
Yes. Yes, that's the actual title of it. I didn't know what to call it because I don't really have anything specific to talk about. The description I gave them was eminent Apple IIGS enthusiast Dagen Brock. You like how I'm eminent? That's what happens when you get to write your own descriptions. Says I'll give 30 slides in 30 minutes. I didn't like that. I'm more into powers of 2, but it got weird. So there's something like 45 slides, 30 minutes. I'll try and speak slowly and clearly. So let's go ahead and start. Boom. Your mind exploded. So last year at KFest, we had some interesting conversations, and I said specifically that I was going to try and collaborate more this year because I've always kind of operated as an island. I just like to go in my little cave and hack away and then like, hey, look, here's my latest toy. And I don't think I directly achieved my goal of real collaboration in a team way, but I have worked with so many people, including a lot of people in this room this year. I got a lot of help from a lot of people. There were weeks when I had Apple II emails coming and going between my house in UK, Australia, France, Brazil, of course, all over the United States. You know, the internet's truly a wonderful thing. I remember when I was a kid, I would go to a library and look for computer books, and you know, I might be able to find a basic book. If I was really lucky, it might even be about AppleSoft Basic. So things have sped up so much because we can collaborate now in this meaningful way on the internet, even though, you know, things like Facebook are sometimes annoying, but we've got a lot of people on there, so it's really great. So one of the things that came out of KFest last year was I was griping about access to Apple IIGS learning materials. I've always been an evangelist for trying to get more people into the Apple IIGS because everybody knows the Apple IIe, the Apple IIc, they're iconic to people outside of our community. Everybody here knows about the Apple IIGS, but there's not a dearth of people still actively doing it. It seems like the 8-bit side has had a strong resurgence for years, and the IIGS has been a little bit left out. So the first thing I did after we did a little programmers roundtable, which by coincidence only happened because another session got canceled. So we talked about Apple IIGS stuff. I ran home, registered the domain apple2.gs, and I gave it a home. It's not a great website, but at least there's finally something specifically targeted towards the IIGS. So I was happy with that. And it's got a couple features. It's not, you know, the center of the Apple IIGS world, but we've got a reference library with about 25 books. And a lot of these you can see are actually, I don't know if you can. No, if I could scroll down, some of these are, oh yeah, these viewer PDF ones are actually from the Internet Archive. They're stored on our previous speaker's site, which is not his personal site, but it's worked out pretty well, if for no other reason that now when people search for Apple IIGS programming, there's an actual site that is specific to it that they might hit. We have a forum. Some of you guys have signed up. Some other notable people have signed up, like the Brutal Deluxe guys. It's not super active. It's a bit of a ghost town, but again, it's there. That's what was important to me, to give it a home. I added some goofy little features, like this is something where I've got a page that uses the Brutal Deluxe Cadius formatter for code formatting, because when people paste their code onto forums, they always do it with tabs and horrible spacing, and this would fix it. So just little toys, and I kind of whipped this whole site out in about 2 weeks, but that's not what I normally do. I normally, you know, enjoy programming the IIGS, and I thought, great, here's a place to find the information. The problem is teaching people, and I've tried to do the workshops here at KansasFest, and people have been really enthusiastic, and it's gotten me to put some material out. But I thought that's not the end game. And as some of us get older and this becomes a more niche hobby, like I said, you could check out books from the library when I was a kid. Outside of that and bulletin boards, the way I would typically learn pre-internet was if I happened to run into another programmer. So we don't really have the oral tradition of teaching people to program anymore. Certainly not in 6502, 65816 assembly. You're not going to go to a class for that. So I thought, okay, I'll just break it down. And I started to do a series of videos. And I kind of said I was going to do it, you know, to promote the Apple IIGS site. But that's not why. I really just wanted to start recording this. I wanted to get out everything I knew, everything I could learn, because I think people like archivists will say, some future generation will say this was important to some guy, some weird guy in Kansas City. So I started to make these videos. I showed the computer, the 65816 in this first one, and Western Design Center thought it was cool, so I thought that was cool. I tried to keep it really simple. People are always so daunted by the Apple IIGS, like, what is it? What is it? Is it just like Apple II with more bits? I don't understand. And yeah, I mean, it is. I haven't learned everything about it. It's a daunting system, especially when you get into the GSOS APIs that you use for desktop apps, which I'm not particularly interested in. So I came up with the simplest thing I could, and At the end of the first lesson, which was really about using the Apple II monitor and the mini assembler, which on the 2GS works very much like the Apple IIe and earlier models, I came up with the simplest demo I could do that would work on a 2GS and show off, a little programming, and I can actually explain it really quickly. This displays the Apple 2GS and boot stuff, this little subroutine. This loads approximately the scan line divided by 2. This strips off the high nibble, or low nibble. Yeah. And then it stores it out to the text location. Because on the Apple 2GS, you can change the foreground and background colors, and then it just branches over doing that repeatedly. It's a really short program with a kind of cool effect, right? And this, I think, really drew people in because it was so simple. And then I thought, all right, let's do another one. I did a follow-up to try and get more detail on how some of the inner workings of the video hardware functions. And for the next one, I moved on. I tried to explain super high res. And this is actually a shot from a PDF that I made for KansasFest 2 years ago that I'm kind of proud of. It's kind of my super high res graphics cheat sheet. And I told you, how you can write to the screen and things like that. And things were going along pretty well. And I'm kind of proud of this too, because now if you go to YouTube and you search for Apple 2GS assembly language, I wasn't trying to corner the market, but at least there's something, right? I want people to be able to search for Apple 2GS and find something for the Apple 2GS. You can see that before this probably would have been the top result, Apple IIe. Great stuff, I'm sure, not Apple 2GS. So that kept me busy for a while. And I'm actually going to switch gears now. I took a hiatus from the videos. People are still asking when's the next one, and I'm about ready to start it again. I'll explain later kind of why I didn't get further with it. So what happened next, I thought I've done these videos. I was very busy getting ready for a wedding. I didn't have time to do any larger video projects, but I always have time to, hack out a quick one-off. So on Facebook one day, people started talking about, wouldn't it be great? Let's port some games from other systems. How come the Commodore 64 and the Atari have these arcade ports that are so good? So just out of spite and to kind of be a smart aleck, I made this this fake out version of Bubble Bobble. And it was more of a proof of concept and to let people know, like, the 2GS can totally do a lot of games that never actually came out. And in this one, I used the Noise Tracker Tool 220 and a bunch of sprites taken from the actual Bubble Bobble arcade game. And I converted them using a program called Mr. Sprite by Brutal Deluxe. And I'll bring up Brutal Deluxe a bit throughout this talk because they've been very instrumental in providing modern tools so I can do my build pipeline on a modern system, right? So it's not the game, it's just a silly little demo. But anyway, this took about 3 days and it was just fun. I don't know why I do those sorts of things, but I mean, it's my hobby, right? And I got to practice some more techniques. So around Christmas, I released this old code that had been sitting around on my hard drive, and it was actually an unfinished idea for a much larger demo. And I just knew I wouldn't get back to it. So instead of letting it rot on my hard drive, I released it. The cool thing about this is this image is if you're familiar with the Apple IIGS, it's an uncompressed C1 image. So basically it's like somebody just dumped all the screen data to a file. And then I compressed it with LZ4, which is a pretty nice compression algorithm, and used the Brutal Deluxe LZ4 decompression code. So this kind of proved, oh yeah, I can get really great compression rates now, and it's very fast using their code. So that was also fun. And LZ4 is actually available in a lot of languages, and you can see the Brutal Deluxe guys are actually on the official list that's on GitHub / used to be Google Code, along with this other one by Peter Ferry, which was for the 6502 and 65C02. That's interesting because I had just used the 65816 version, and later in the future of that year, I decided I would use the other one, and that kind of came back and bit me, unfortunately. So switching gears again, I had gotten married, came back, still wasn't quite ready to do videos, really refreshed. I've been working on some more double low-res routines since the Flappy Bird days. I actually had more interesting stuff that I thought that mode could do, and I was going to do it. And so the first thing I did, I had this old routine that would do sort of a sine wave on any graphic you put in there. And I've been working on some other routines, and I thought, you know what, KansasFest got announced. I really want to do something. I know I can't go there, so I asked them if I could present remotely. And they were like, that's fine. So I started thinking about this idea for an 8-bit demo that I would show at KansasFest, which was kind of all well and good. And I thought, okay, the problem with Apple II 8-bit demos is that the sound is so lackluster because it's almost impossible to interlace sound with animation. And you can do that pretty well, but even then the sound itself is typically your square wave, right? You're just popping the speaker off and on at a different frequency. Unless you're a super genius like Michael Mahone, sorry if I'm mispronouncing it, who came up with the DAC 522 to be able to do 5-bit 11 kilohertz sound. And so I downloaded his source. I couldn't get it to work because it was actually missing a file, and I contacted him and he sent me back. So this is just another small example of collaboration, people helping me get my toys written. So everything was good. They accepted my proposal for the remote presentation, and I kind of started to work on this right before Christmas time. So we're going to switch gears. We're going to store this away for later, because around that same time, there were these two guys that I talked to at the last KansasFest. They're like, oh, we're working on the transwarp clone. Maybe someday we'll have it. I honestly had no idea how close they were, but I had talked to them a couple times. They're good guys. Yeah, they do all right. And they said, so we've dumped the firmware. We're working on new stuff, and we also have the firmware disassembled by this guy named Jeff Bodie in Australia. I was like, okay, tell me more. So they sent me his disassembly, but it wasn't really usable. It was kind of a collection of different disassemblies, very well commented though. So they sent me the binary. They dumped the ROM from the transwarp, the 1.9 version, and they sent it to me, which meant it was time to disassemble all the things. So I had to pop out a disassembler, and the best Apple IIGS specific one is called the Flaming Bird Disassembler. As you can see, it was written in 1994 by Ferox. And I believe it was part of the Phoenix Corporation. I think that's where they got the name. The only problem with this was the support wasn't so good as it was written in 1994, and I had no way to contact this guy, and the language, all the instructions were in French. Oh. So I had to translate 29 pages of the instruction manual, and then I posted that back. Everyone was grateful over in France. They're like, oh, now you know how we feel having to translate your stuff. Yeah, it's like it's not a contest, but anyway. But the best thing about this actually taught me how to use it. But there's a whole scripting subsystem in this disassembler, which obviously probably makes some of the heavy lifting better. I got to about page 27 out of 29, and I'm like, man, it's getting towards the end. It's going to fit all this scripting stuff in there. And on like page 27, it literally tells you, oh yeah, all the detailed scripting stuff is in this other document. I have not yet translated that, but it got me far enough along to where I could start the disassembly using Jeff's work and some other work. And at the same time, some guy heard that I was digging into 2GS native disassemblers, Ewan Wana. I don't know how to pronounce his name either. But he came out with Breakdown, which I was already too deep into my project. I couldn't look at it at the time. But I have since looked at it, and it's really quite adept. And if you look at this, this is just a binary I dumped in there, but see how it automatically picked out some of the standard firmware locations and stuck them in there and didn't just put in FDED. It like knows what C out is. It knows what home is. So I would definitely check that out if you're interested. The Flaming Bird is also good. But I still had some serious problems. I'm not sure what this next slide is. Oh, yes. So I worked for months on the disassembly using the Flaming Bird disassembler. This is a little visualizer of all my code commits for Gorse. You can see back in December, I was working on it off and on. I actually took a a trip in early like February, and I'm like sitting in a hotel room in Sweden making updates. And I got pretty far. And then one day I got to a certain instruction, and anytime I tried to put it in to disassemble, it would fail. I worked on that for about a week, and I just couldn't get it to work. So I put something out on the Facebook group, and I said, I'm stuck. I'm using the Flaming Bird disassembler. I'm stuck. I need this. I'm so far along. I spent months on this. I'm trying to disassemble this 32K binary for the Apple, or 32K binary. So Antoine Vigneault from Brutal Deluxe contacted me and said, is it the Super Nintendo ROM or is it the Transwarp firmware? Because only two things can be 32K. It's like, dude, how did you know? It's the Transwarp firmware. I didn't want to tell anybody, but we talk enough that I was like, he's not going to tell anybody what I'm working on. He's like, oh, I did that 2 years ago. So this is why you should collaborate. I mean, there's so many times I get bit in the butt because I don't reach out for help and I don't talk to people. So he sent me his. Granted, it still was a lot of work. It wasn't the exact version. So I had to first get his version to build. And then I had to make some extra tools around it. So I made my own tooling so that I could actually see differences in binary. And the only thing interesting about this is using a modern system, they don't typically show high ASCII. So these would just come through as gobbledygook because they're the high ASCII that we use on the Apple II. So that allowed me to see where differences were. And it took me about a week to basically get it to build and then get it back to an exact binary match of the Transwarp 1.9S firmware. And I got to tell you, that was a real thrill, having never disassembled anything longer than a small subroutine to actually have 32K of disassembled code, and it's extremely well documented now. I don't think anybody really cares about ownership, but I did this to help out the Ultimate Micro guys, and I asked them like, hey, do you care if I put this up? So at some point I will put this out, so if people want to go to GitHub and grab it and build their own custom firmware, they can. I still want to finish the version that I'm working on for them, which will include support for the 64K cache that I don't even know if they've designed it. I just said that I could make it work in software if they hook up the address lines. And they're like, well, yeah, we can do that. But the only problem at this point is I still had no Transwarp. So I sent that off to them. I had a Transwarp I bought on eBay a couple of years ago, and they helped me get it up and running. You can see it's back. And I've got one of their 32K cache cards and the scalable oscillator, which they really don't do a good job of telling you how awesome that is, because what it means is you put that in there and you just keep stepping up and go as fast as you can go versus buying 23 oscillators and plugging one in and seeing how that works. So really cool product. Either way, after dreaming of this for years and years and years, I'm finally a card carrying, literally, Transwarp member for the 2GS. And then the next step was I had an idea that my firmware, it was an exact binary match. So I knew it would work in a Transwarp, but how do you get it on there? So I had to get a ROM programmer and learn how to do the EPROM thing. I could have used Buggie's speech last year. Yeah, you wake up. I'm sorry, Steve. I'm sorry. But, again, this was a real thrill. Like, I dreamt about doing these sorts of things as a kid, and you would see those old EPROM programmers, and they were quite expensive back in the day. Now this is like a $50 Chinese model that comes with every adapter known to man. Works extremely well. And in this case, I actually just pulled one of the firmware chips out of the GS just to try and do a quick dump, and you can see all the basic keywords that are in there. How cool is that? So yeah, that's how you get your firmware onto your real computer. So I sent them a picture at the Ultimate Micro guys. I was like, hey, guess what? All built. And of course, if you went to their thing yesterday, you know that we are working on a updated version. I'm trying to leave as much credit and non-bastardized parts as possible for the history buffs, but we'll see. I mean, I may eventually branch out and just strip out a bunch of their animation and graphics stuff that is not relevant to the product. We may also eventually do a 64K firmware. Who knows? But anyway, that was a really great project that involved, the Ultimate Micro guys, Ewan Lanup, Antoine Vigneault, Jeff Bodie. I mean, this was like an international effort, even though I was ultimately successful. It was only because of them. So another note about this is that I typically keep all this stuff in my own GitHub. Now, I will put it out or this is GitLab. It's a source control repository sort of deal. And I do this so that I can do things. These projects over here are not ready for public consumption. Or in the case of something like Transwarp GS, you know, there's a little legal cloud over it. I'm going to release it anyway because come after me. I don't care. This is my actual humble GitLab server that runs in my basement. You can see there's some old water hookups over there. So pretty high-tech stuff. Anyway, it was going good. All of this stuff was going great. I was still working for this KansasFest demo in the background, but I was starting to get really drained. So I took some time out and just started playing around, doing things like writing one-liners. This is one of my favorite ones just because this is like a great one for kids, you know, plot sign. How hard is that? And look, it's one line. Name me a modern programming language where you can do that and have it animated and get all that feedback. But I started, you know, just do this stuff for fun. And you'll notice the kind of common theme here is these are all just toys. It's not really software that I'm trying to package up and sell to you. I'm doing this because this is a great way to learn about computers and to enjoy yourself. Here's a two-liner that draws a heart. And my minor optimization here is that everything down here is actually just one line, right? You don't have to split it up. 2 lines here, and then I drew a little line. What was interesting about this, I posted it on Reddit, and I was hoping somebody would rewrite it, and they did. So their optimization is that it's actually mirrored this way, so if you draw the stripes this way, you only have to define them once and then just draw them mirrored. So I'm not a great BASIC programmer, but this is why these, you know, I agree with Becky, you learn a lot about using these systems and whether you're using BASIC or assembly. They teach you different kind of problem solving skills, and you get to be close to the metal. You get to have simple, easy to use H-line, V-line. You don't have to worry about starting up your GPU or, you know, learning a ton of OpenGL APIs, which I'm sure everybody in here agrees with. That's why this is a great hobby. Another one I did was the WAS two-liner. So somebody was like, that's great. I think you just did that to show off the signature that WAS has on your Apple IIe Platinum case. And they were like, why don't you make that a one-liner? And so I was like, all right. So I took this old code from 2010 KansasFest. It's a little JavaScript. And what it does is when you click the mouse over here, it just draws out the coordinates in a basic data statement. And you just copy and paste that. I don't have to show the whole thing here, but I made a little, you know, a lot of what I do is really about the meta programming. It's not about me writing BASIC. It's about me writing the program that generates the data and then writing the program that generates the program. And, you know, fast forward a little, you can see the payoff at the end. I typed it all in. And I'm sorry if you already go on the Facebook group a lot. You've probably seen a lot of this, but just letting you know, it was a really busy year. I've got about 5 minutes, so I'll finish up quickly here. There's some interesting stuff. So this was a good break. I had to go back to finish up the Oz K-Fest demo, and time was really running short, but it was incredible. They were pretty high tech. Like, this is what it looked like there. They had me on 2 screens, which I didn't realize. I'm actually pretty uncomfortable with that. I don't like being in front of crowds. And the thing I did is I actually pre-recorded this and put it up on YouTube, because streaming to Australia, we've done those things, and it typically doesn't end well. So I was like, here, get this. You can download the video. So if any of you want to see my presentation, it's available. You know, I tried to explain double low-res graphics, and how the aux and main map work, and how I used the LZ4 code, came up with some Delta animation routines, interlaced it with Michael Mahone's sound routines to do beats in the off animation parts. I used Premiere to actually lay out that animation, and it was just a lot of fun. That's actually multiple colors and low res, so that you can kind of get the fading effect. And I don't know if you can actually hear the sound, but it's digital drums and then playing back in between. And it's not super precise. And I was so rushed for time, I cut it short. So hopefully, eventually, I can do a final version I could do a better job of some of the Venetian blind effect that you get. And this is all, by the way, before French Touch and the little Karatika demo. This has got some bugs in it that, of course, showed up when I did the final build right before I did my presentation. So I was like, so it's not perfect, but I think it did a good job of explaining double res and some of the things you could do with it using a modern system. So obviously I write a lot of tools, and for this I did some stuff that would basically take animated GIFs, and I would split those out into frames, and then I would make sure that they had colors that basically match the double low res colors, or at least the RGB values that most emulators use, and then it would suck all those in, compare frames to do deltas. So when this wing's flap, it doesn't redraw the whole thing, it just draws the part that's changed. Feel free to watch that presentation, it's pretty cool. Right as I finished that, these guys called Ninja Force came out of nowhere, actually 2 weeks before KansasFest, and released Kaboom, which did not help me get ready for KansasFest. And I'm pretty good at Kaboom now. But then a couple weeks later, they came out with their Ninja tracker. They were like, would anybody be interested in our music playing routines? I was like, yeah. So as soon as they released that, they released a source. It took me like 20 minutes. I got it to build in Merlin 16. And then I got it to build in Merlin 32. And then I posted the code on the Apple IIGS forums, let everybody know. And I don't know if it's a coincidence or not, but about 2 weeks after that, Antoine and Olivier from Brutal Deluxe released their Tool 221 player. And I was like, that's great. I'm determined to be the first person to put out a production using the Ninja Tracker code. So I did. Maybe you've seen this, maybe you haven't. I did it under a pseudonym because I took the graphics, and I also did the Brapple Blopple, the little bubble bobble thing, under a pseudonym, just because I don't like putting my name on things where I didn't create all the assets. I'm not really trying to be that sneaky about it. But ultimately, one of the things this was about is where our community is still a little bit behind is I don't have an artist. You know, there's lots of great people still doing art for Commodore and Amiga and ZX Spectrum and Atari. And if anybody knows a graphical artist or a musician that would like to work on some cool productions, it would help me a lot, because every moment that I spend doing graphics or sound is taken away from coding. So what is this all about? I didn't get to do everything I wanted. I got one of the last Nishida radio flash airs. I still haven't been able to try it. I have not been able to finish my transport firmware. There's a really cool thing I wanted to show you guys where Miss Dunki always espouses the sort of one button build philosophy, right? You shouldn't be typing make this and then convert it in here, right? Yeah, now they're fighting. So one of the coolest things I did is after last year's KansasFest, I took Ivan Drucker's A2 server, hooked it up to a 2GS, got it to NetBoot off of there. And then using Merlin 32, I can build code on my modern system. So what it was is I could have something on here, and anytime I would save my file, Merlin 32 would see that I saved and try and build it. And if it succeeded, then it would move it over to A2 server, where a listener would immediately run it. So that's a no button build that goes direct to hardware. So I don't know if it's almost hard to explain, but basically I would save something on my Mac and it would show up as the running program on a 2GS on the real hardware. So I do that all the time with emulators. That's how we commonly build software now. But that was actually really cool. And then one of the other things, and I'll just kind of make this the last thing, that I had written a program a long time ago and put it away because Apple is kind of an evil corporation these days, and playing in the Apple App Store is not a fun place for me. And they really, quite frankly, upset me. So through some poking and prodding, somebody finally got me to push to release this. This is my instruction reference, and some of you may have seen the initial version that I did for an iPhone. And this is for the iPad. You can search. So if I want to see what instruction is 00, I put in 00, and then I go, oh, that's break. And here's how many, it's 2 instructions long, it's 7 cycles, and here's all the data about it. I'm pretty proud of this. It's actually an incredibly useful programming reference. you can switch between the processor. So, 6502 up here does not have a lot of the same push, or doesn't have all the same pushes as, say, a 65816. It has many more. Of course, when there's multiple instructions, you click on it and it shows you all of them. You can look up the ones for immediate. And of course, the data down here shows you, well, immediate takes this many cycles. Absolute takes that many cycles. And I don't want to, I don't want to sell anything up here, but this is on the App Store now. If you want to do programming, I would say it's a great place. It has some other silly kind of features like the pinout reference.
It's beautiful.
No, I mean, it works. I mean, it was purpose built for people that are looking up instructions. You can even change the theme if you don't like the sort of retro theme. And again, being able to do things like just say, well, what's PHX, right? And just go right there and have the data. Also to have it as a second window on the outside of your computer is kind of useful. So for all the things I didn't do, I did a lot. And just to bring in some of the personal stuff, I'm really proud of all the work I did. But so after this, I will be trying to return to some videos, and other than that, probably taking a bit of a small break from this. A lot has happened in the last year. I got married. I got a new job. I lost a really good friend and my father right around Christmas, and then an uncle and a cousin about a month after that. And it's just, this stuff is constantly going on. So I really appreciate you taking time to listen to me today and support my hobby, because when things go crazy, sometimes, it gets hard, and it's kind of nice to just go, let's write some code. Let's just think about computer stuff and not people stuff. So, and I would love to talk to you guys more. I'm always on the Facebook. I actually probably share way too much on there. And I'm not a big fan of Facebook. I actually abhor it. But, we've got the critical mass of people there. So it's a good place for us to all be, unfortunately, because there's not a better alternative. But and outside of that, if anybody would like to collaborate on anything this year, feel free to reach out to me. And if you just want to talk about programming, I would love to talk about programming. That's my contact info. Thanks, you guys.
Sorry. 10-minute stretch break. At quarter of, we're going to have Mark Pilgrim talk about the story of the greatest copy protection ever.
Ever. Can I make one last announcement?
Yes.
Yeah. If anybody wants to play with the apps, they're on here. They're for sale for $4 right now. That is not always going to be the case. I'm just doing that to try and recoup a little of my cost.
What's it called?
It's called, oh, that's a good idea. I should tell you that. It's called Recreate 16.
Like recreate?
Yeah, I'll come around here. But in the meantime, if you want to just try it, I can let you check it out on one of these iPads. The app is called Recreate 16. It is for sale now, but I am going to make it free shortly. I just like messing with people.
Yeah. Good job. Sure, why not?
Oh yeah, I mean, this is not a platform I would go on.
Question. How easy is it to set up that A2 server thing that you were describing, where it goes to the hardware with 0 clicks?
Okay, how do you spell it again? We tried that. I'm not getting
I released it about 3 hours ago, and it's
I'm sure it takes maybe a couple of days.
Blue cast too, is that already?
Yes, except that I can't actually see it.
Oh, it's probably it's an extended desktop for me. I have to turn it on.
Yeah, hang on. Okay.
The server itself would run on your Mac.
I just run it.
This is what came up earlier.
Yeah, no, you guys.
I don't know.
Targeted.
Arrangement, mirror. Optimize. Okay, sure. I assume that's the thing.
And then I did have to make
No.
Otherwise, I could just go.
Hey. Yep.
Okay. Amplification system.
Facing up.
Oh, really?
That's true.
Is the iPhone version still available?
It is.
It's not as good as this, I think. Make it so hard. I don't know. Well, the only thing that's still out there is just recreation. What's funny is this one, the iPhone version is we'll have time to finish it. So it's just, it's Apple. So I really got this out before that basically wouldn't even let me release it. You don't make money if you're not buying
Right here, there's a screen here. It might be out. Right here, this side, right here.
And I rewrote all this.
So that could be the problem. So I don't feel any hope. It's like, yeah, okay, so you get there's nothing moving over here. The whole, it's the whole, but it's even over here. Where it's coming from, we can ship it.
Mike, I stopped and started again for March.
What did you do?
I stopped and started it again.
I'm trying not to get harm over there. Not working on thunder. Too bad we can't have a thing. Why? All we need is one of those photography stands. Put the camera on in front of it, or back the table. We'll get one of the little ones that sits on the table. No, that's the problem.
Just saying, I don't. So you're right. That would be the next step. Now that this is done.
You have the data set. The data set.
Let's see.
Yeah.
You'll transfer.
Doesn't realize
APIs, and even SSH. This is a
Chris Torrance. I'm Charles Lott. He's the one that sent the email or the message. But I'm trying to trap. I know, but I don't want to bother you. Yes, sir. Yeah. That's 2 night owls. How much? Penny? Yes, that's good. That's a bargain. That's a bargain.
Yeah.
Well, see, I can go to the other class.
Okay, we're gonna get started.
Is this a good pipe?
Yeah, thank you. I have a one of the other classes now.
I don't hear it. Check,
I can watch
check,
the playback.
check. Audio check.
Thumbs up.
Thumbs up. All right.
Okay, we have 2 more back-to-back sessions without a break in between. After Mark goes, we're going to have Charles Mangin do a deep dive on the Apple II mouse. After that, we're going to do dinner back in the cafeteria. Right after dinner, Martin Hayes is going to give us an update on Lawless Legends. Make sure to be here for that. Next, we're going to go into perspectives on Apple from the Atari side.
Yay, Atari!
There we go.
Do Atari!
Bring some Atari love.
What's Atari?
After that, we're going to do, there's going to be 3 hardware workshops where if you're interested, repairing your broken keyboard, making the Night Owl connector cable, which Chris will do, and then if you've got a Brio kit, that's all going to be down here. So bring your soldering irons. You're welcome to come down and watch other people do it. After that, we're going to have donuts and milk, and then we'll go into a game tournament, and then Firefly at 11 o'clock. So Mark, well, thank you for doing your presentation.
All right, so this is billed as the story of the greatest copy protection ever invented. I don't really know if that's true, but that's what you get when you make people write their own headlines. So I'm going to start off, Mike, in the front. Can you read some of these words for me?
Well, Mustangs, trombone, headline, feedback, handrail, roadside showdown, turnover, bookcase workshop.
All right.
Wow. Do you want me to continue? Oh.
But the point is, if all you have is a steady stream, an unending stream, then what you read out of it depends on where you start. Which gets us to timing bits. Brief history of copy protection on the Apple II in like 60 seconds. Okay, so you have to get data off of a disk. You can't put bytes on a disk like as they are in memory because of limitations of the disk II floppy drives. So there was this intermediate format called nibbles. DOS, we'll stick with DOS 3.3, although DOS 3.2 was similar and slightly less advanced and could store a little less data. But DOS 3.3 had, sectors on tracks, okay? 16 sectors per track, 35 tracks per disk, and so you get 140K worth of data. But the code to read that data off the disk is on the disk. So there's a bootstrapping routine that happens every single time you boot a disk. Well, that also means that you can play with how data is stored and how it's retrieved. And boy, did they play. In the early days, it was all around changing the delimiters, the standard delimiters between, this was called the address field prologue. This is actually Roland Gustafson, who was a famous programmer and copy protector back in the day. He wrote Print Shop. He also wrote a number of other things, and he did the copy protection later for Broderbund, a lot of different Broderbund games. And the reason that he had this on his license plate was because this was the address field prologue. And so you would look for this, and then you would say, okay, well, the next thing I'm going to read off the disk is the address field, and then there's an address field epilogue, and then you skip a lot of stuff, and then there's a data field prologue. Oh, look, here's the sector data, and then, okay, so that's how DOS 3.3 worked, that's how ProDOS worked later. And, you know, that's how all unprotected disks worked, and that's how most protected disks worked, except, you know, we'll use D4 instead of D5. Or we'll use, you know, AA-D596 instead of D5-AA96. Okay, so it's minor variations to the structure of the disk, and suddenly you can't copy it. Then we get into nibble copiers, we get into Locksmith, which came out first in 1980, maybe, like really early, and was a nibble copy. Suddenly you could copy all these protected disks. Wasn't that great? Because all they were doing was structural changes, and it copied them track by track. So it just copied all the nibbles on the track and wrote it out, and it didn't care that it was D4 instead of D5. Okay, so there was this back and forth in the cat and mouse game, right? And that was that went on for a long time, and people would come up with, oh, well, let's store it on half tracks, which are between the tracks, 0 and 1, or 1 and 2. Or let's store it on quarter tracks, which are halfway between half and a whole track. And anyway, so there are all these structural things. Oh, let's count how long, you know, see how long the track itself is, and then count the total number of nibbles and make sure that, you know, that it works. Anyway, so all of these were defeated. And we're talking like, you know, once this arms race started, we're talking a matter of months. You know, somebody comes up with a brilliant new scheme, and then Locksmith gets updated, or, you know, there's a parameter file that, you know, gets spread around on BBSs and so forth, and totally annihilates. Okay, so we get that for a while. Then we get, in 1983, we get Locksmith 5.0. And Locksmith 5.0 looked unprotected. You could copy it with copy A, or any other sector editor, but the copy wouldn't work. Excuse me? And, you know, you can copy a disk with copy A in like, what, 20, 30 seconds. Okay. And then you boot the copy, and it doesn't work. It knows. How does it know? And there were some runtime copy protection routines before this, but nothing this sophisticated. And they all relied on, you know, they were in parallel, they were in conjunction with the structural changes. They were limited to, you know, how you could do it, when you could check it, or they had already been defeated by all the nibble copiers, Locksmith pre-5.0 and its competitors. So Locksmith 5.0 comes out, and you can copy it in 30 seconds, and it doesn't work. Or you can spend 20 minutes on, you know, and turn on every single option, track length and sync, and you know, the whatever, and do all the things, and make a copy, and you boot it, and it doesn't work. How does it know? In 1984, by 1984, this protection had spread. So suddenly, instead of just one program in the world, there's dozens of new programs coming out that are completely uncopyable. And the beautiful thing about this E7, E7 protection that Locksmith pioneered was that you could use it in conjunction with structural changes if you wanted to. So they did some of that. So you had to nibble copy it, and also it didn't work. So just like, you know, layer on layer on layer, right? Because like security, this is defense in depth, right? So 1985 and even more gets into, you know, Scholastic does it with Microzine, and Mindscape says, oh, this is the greatest thing since sliced bread. We're going to use it on everything, which they did. You know, educational software is very, very poorly preserved even now because of stuff like this. Like, it was too complicated for whoever the wizard was at your high school to break it, and so it never circulated. Like, even if you have a copy of Copy 2+, like, it wouldn't help. Like, or, you know, nibbles away or back it up or super copy or whatever. Like, it didn't work. I just want to go back real quick. The Learning Company back here, down here, in 1984, they had released a number of titles. They're the one who did Rocky's Boots that came up in the Keynote. They did Robot Odyssey. They did What was the other famous one? Gertrude's Puzzles, yes. Anyway, so they had a whole series of, in the early 80s, okay. And in 1984, they re-released their entire software catalog with minor updates and new copy protection. And those stood for years. They're just like, that's it, we're done. We're just, So in 85, EDD4, which was another high-end bit copier, which was, actively developed. This is from the manual. We've noticed that the copy protection contained one of the other copy programs just is being sold to any software publisher that wants to buy it for their own programs. To us, it sounds like a conflict of interest. They weren't wrong. They had a lot of buyers. All these companies were releasing or re-releasing software with the same copy protection scheme. It was wildly popular. Yes, it did. Yes, it did. And later, Becky says it was easy for her to crack them all. Yes, and that eventually got out. There were Copy2 Plus tips and tricks and whatever these text files that Jason loves collecting so much. That would, say, oh yeah, you got to look for the E7, 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 and if you find, on that track, that's where the copy protection is, and then the nibbles after that, and you got to change it to this, and then you can manually fool this copy protection, but like it was a one-off, like you had to do it yourself. Although EDD4 was advanced enough, it came out in 85, was advanced enough that in some cases it could do it automatically. It could locate it and it would make the patches. But it was a special case. It couldn't do it generically. It couldn't defeat this copy protection generically. It had to special case it and look for this and say, oh yeah. And so if there was any variation at all, you were back to square one. 86, World Games. 87, Wings of Fury. These are not small titles. 88, Technocop. 89, Prince of Persia. Locksmith 5.0 came out in 83. By the end of 1989, Prince of Persia and others were still using it. That's 6 years. In an arms race where you measure success by a matter of months. So this is it. This is the bit stream. This is E7, 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 EE. This is actually the part after the initial E7. So you would have code, and I'll show you some slides of code taken from a real disk that used this. It would look for E7, 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 and then it would do the magic, and it would start looking for this bit stream. And this is what it looks like. Like if you use just a regular, those of you who have seen a little RWTS, to read a nibble, it's a tight little loop. You read the data latch, and then if the high bit isn't set yet, because the nibbles always have to have the high bit set. If the high bit isn't set, then you loop back with a BPL. Anyway, so this is what you would get if you read this bit stream, from the beginning. And that correlates to E7, 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 E7. So those zeros in the middle, here's 2 of them after this nibble. Here's 1 of them after this nibble, 2 of them after this nibble. None in between here, 1 in between here, none in between here. Those were called timing bits. And they were used legitimately by DOS 3.3, not this way, but they were just skipped because of the way that the DOS 3.3, RWTS would read individual nibbles. It would get to the end of this E7 and then say, all right, I'm ready to start over. And it would get, to this, and say, okay, high bit isn't set yet. Oh, there it is. Okay, we got an E7. What happened to that one? It just disappeared. It just vanished. And that's what happened when you tried to copy the nibbles, or if you just read this, looked at it in the nibble editor, you would just see E7s. You would just see a bunch of E7s. But the same stream, what if you miss the first 4 bits? 8 bits in a byte. What if you get out of phase by half a byte, okay? Then it looks totally different. You're going to end up, again, you're going to skip the first one, right? Because the high bit has to be 1, so it's going to get all the way to here. This will get thrown away, and you'll get, this nibble, there's a 0 in there that used to be data. Like that used to be part of a nibble, of an E7. It used to be in the middle, and now it's just ignored. And so you end up with this stream instead, EE, hence the title. E7, FC, EE, E7, FC, EE, EE, FC. Completely different. There they are. You can compare them at the same time. It's the same bit stream, but it all depends on where you start. You get a completely different. Now, on a copy, if you skip this bit and then start reading here, you're going to get a completely different, I don't have a slide for it, but you're going to get a completely different value. You're not going to get the magic EE, E7, FC because it relies on the fact that there's 2 bits right here. And if there's 1 bit, not 2 bits, but 1 bit right here, and there's 2 bits right here, and 1 right there. And if you don't get all those exactly right, which was essentially impossible in the general case, then the in-sync bit stream will look the same, but the out of phase, the out of sync bit stream will be completely different. So here's the code that does that. It's surprisingly small. Some standard stuff, turn on the drive motor, get ready. This sets up an address that we'll use later. This is a counter for, counting down to eventually it'll stop trying on a copy and just give you an answer that said, nope, illegal copy. This is some standard stuff. This calls into the DOS 3.3 WRTS to go look for the next available address field, the D5AA96 that I showed you earlier, and check and see the sector number. So it's looking for a particular place in the track, okay? Because that's the only place that this magic bit stream occurs on this disk. Okay, so that's just all set up. And then we look for D5, and then we look for E7, E7, E7. Okay, now we're set to look for the magic bit stream. This resets the data latch and does this, which does nothing. First time I saw this, I was like, why would you do that? That's wasting time. It's wasting 4 bits of time on purpose. And then we go look for EE. And then we go look for, in reverse order here, E7FC, EE, E7FC, EE, FC, which, by the way, is exactly what I just showed you in the magic bit stream. And then at the end, you get an answer. Yes, original. No, not original. Say again? Yeah, that's it. That's all you need. But you have to find this code on every single one of them. And that's not what nibble copiers wanted to do. They didn't want to change, they didn't want to auto crack it. They wanted to preserve the actual thing, right? But yes, that's one way to do this, is literally change the value, because this is just a subroutine, right? This isn't doing anything. It just returns 1 bit of information, literally 1 bit, the carry bit. 1 bit of information, original, not original. So then what do you do? Right, so if you change this to match that, then suddenly it always says, yes, original. Didn't work, yes, original. Thank you. So what do you do with that? Well, most people just rebooted. Not original, start over.
I wrote a reboot that caught that.
Excellent. Tell me about it afterwards. I want to hear that. Some of them scolded the user. That leave what? I don't know, but that's what it said. That's what it said.
Press return and run from the computer.
Yeah, apparently. Run from the computer. It is about to explode. Some of them, Epics loved to do this on, I forget, they're major arcade games. They love to do this. Here, instead of just reading and comparing, this is at the point where it's getting the desynchronized nibble stream. Okay, so it's getting that, whatever, the E7FC, EE, blah, blah. And then it stores that in 0-page, and then it immediately uses that as an 8-byte decryption key for the rest of the bootloader. Like, it doesn't stop if you don't have an original copy. It'll keep going, and it'll decrypt it with the wrong key and then run it. So the copy will work. I mean, it'll boot and then crash because the bootloader, you know, the stage 2 bootloader is encrypted with values that are only exist on an original disk. Or you could just do what Prince of Persia did. It's one bit of information. You can do whatever you want with it. You can call it more than once. Most disks called it on boot, but you can do it whenever. Prince of Persia had stuff after level 1. It had stuff after you turned the disk over. No, right before you turned the disk over, because all the copy protection was on side 1. But like it would just, so it knew, and it could, you know, we got it all, you know, run the game, get to level 7, nope. Get to level 2, nope, no. Get to level 4, oh, graphics getting corrupted, why is that? I don't know. Okay, we really got it this time. Get to level 7, crash. Nope, you missed one. It's all based on the same routine. So it could get that, it was so flexible. And you could do whatever you wanted. You could be, thank you, you could be, I'm done anyway. But it was just, you could do whatever you wanted. You could be as evil as you wanted. You could be as twisted as you wanted. You could just, you know, reboot and do nothing, or you could secretly set, you know, roll in 1 bit into a 0-page location and then 30 minutes later into the game, roll it back out and crash, and no one has any idea why. And it was all based on just killing the right amount of time at the right time and reading the same bit stream starting 4 bits too late. That's it. That's all I got.
Wow.
Do we have time for questions? Okay, questions. Quinn.
Different games do that differently to make that go harder time. Like, it doesn't matter what you do, right? It's only 5 cycles.
That's true. Actually, technically, it was, I think, it varied because it could be anywhere from 12 to 16 cycles, actually, just because there was an extra 0 in there that would get, if you only shifted it by 3 bits, that was enough, actually, to make it work. But you could also shift by 4 bits. Anyway, but this part is important because it resets the data latch so that you can go start reading from scratch once you're desynchronized. But then the other 2 instructions are, you know, they could be anything, as long as it doesn't interfere with, you know, I mean, you can't reset X because then you're going to use X unless you're not using X. You know, if you hard coded, you know, the boot slot X at this point is always the boot slot times hex 10, so like 60 if boot 6. If you're booting from slot 6. Anyway, so yes, I've seen minor variations. I haven't seen anything like really crazy, but I haven't looked at all that many. So there were probably variations, yeah. Steve?
People eventually were able to break this. You said all these years passed and nothing happened.
Well, as I said, EDD4 built in a special case for it. And I, but it was very brittle. Because it was exactly this, and if it didn't find it, or if it, you know, whatever, if it was slightly different, if the bit stream, if they used a variation on the bit stream and looked for different desynchronized nibbles, which is possible. This is not the only possible thing where in sync and out of sync will get you consistent results.
And was copy to plus any more successful, or was it less successful?
Copy to plus, I think it had a parameter for it, and you could set it. Their whole thing was around these individual parameters for individual games. And so yes, there was a parameter to turn on the E7 and then like tell it which track it was on. So like for this one track, you can say E7 detection or whatever. They called it generic bit slip detection. Anyway, so yeah, there were these tweaks, but it was just running up against the limitations of what you could do, while the disk was spinning, because there was only so much time before you would start missing legitimate bits. And then, you come around again and, suddenly it takes 8 hours to copy a disk because you got to go around, and around and around anyway, so they didn't go down that route. They had this special case and then they're like, we got other stuff to do. Yes.
You know who came up with the idea?
I do not.
They didn't sign their work?
They did not. There is speculation that it was Roland Gustafson himself. I don't think he's ever confirmed that, although he is on Twitter. We could ask him.
Did you do it?
I didn't do it. No, I was 11.
No, not you.
Oh, you mean to ask him? Oh yeah, I could do that. It could have been the author of Locksmith himself, who never unmasked himself publicly, but he was known to dabble in on both sides, playing both sides against the middle, and that would make sense because. From the EDD manual, someone is selling this copy protection, and they thought, anyway, that it was the guy who made Locksmith or the people who made Locksmith that were turning around and selling it as well. But I don't know. I don't know for certain. One more question? Dagen.
For the delay, would that be skewed and somehow break on an accelerated system?
No, because the question is, would this break if you had like a zip chip or a transwarp or anything? And the answer is no, because the timing was so sensitive on disk read stuff that as soon as the disk motor went on, all the accelerators would turn off their acceleration so that all of this code could work normally. Just all the normal code just could read any disk. So no, you had to provide exact timing. So they went back down to whatever the 1.024 megahertz unaccelerated speed whenever the disk motor was on.
Same configuration, 3.5 inches, 5.25.
It is not. I don't know a whole lot about the 3.5 inch discs, but it was all sort of abstracted. Like there was a hardware layer, and so it sort of limited the number of things that you could do. Like you could have a bad block and then whatever, or you could have like 0 bits that would return random values, which is what the guy who created Raskin did, which was on Open Apple podcast recently. But I don't think that you could do like the automatic desynchronization. But I'm not entirely sure. I'm not the right guy to ask. Okay, one more. I don't know. I haven't seen a write routine. Michael Mann says.
And that's actually easy because similarly, like still signal, just make the wait time is take a little longer than 32 seconds. If you get 34 seconds, you get another 0.
So you have a custom, instead of just having one loop that handles every single nibble, you have at some point a custom loop that has exact timing all the way through, so that after this bit, we're going to waste 4 CPU cycles and get an extra bit, and then after the second nibble, we're going to waste 8 CPU cycles and then go through. So you can apparently probably do it with just standard low-level RWTest stuff. Like you wouldn't need a special drive or a special mastering process. Just need a special program. That was also probably part of the appeal. There were other things that required like specially modified drives and that sort of thing, which is expensive. You know, this this was not only flexible, but it was combinable, and you could, you know, do it with standard floppy drives if you were small, and that was a big expense. I was 11 in 1983. I don't know a lot about like business from back then, but okay. Anyway,
I was 33.
do you know a lot about the business side of it?
Not really.
Okay.
I was doing the engineering program.
But okay, but I think Michael is right that it wasn't that difficult to produce this bit stream once you knew what you wanted.
Since it was this, because your code was triggering my amendment to reading.
I'm sorry.
I assumed it was a bit written in a half-track damaging something.
No, not at all.
And I went, well, I was using fourth dimension drives. And I could read the half-track, no problem, but I wasn't thinking, I just wanted to play the damn game. And it wasn't good.
Don't we all?
And I called their help number, and their response was, we don't support fourth dimension disk drives.
Nice.
Well, if you'd offered to.
So their copy protection was not supported by your floppy drive because your floppy drive probably could like read half tracks instead of having the bleed over. Nice. Nope, not related to this.
No, it was
This one.
That was the code.
Oh, was it really?
I just assumed it was a half track. I never tried to
Oh,
find it.
oh, interesting. Okay, I believe you.
But it was very consistent RTL.
Okay. All right. That's it. Thank you very much. I'll pose for pictures. No? Okay. Not doing that.
Okay, quick.
Oh, seriously? I'll pose for pictures. No. I'll pose later.
All right, we're going to segue into Charles, the last one before dinner.
Charles.
Charles.
Charlie, you up?
Yeah, this is Mark and Quinn and several of the presentations today have been all about the software side of things. And I'm going to talk, I talk kind of loud, so I'm just going to put this a little bit further down. Is that okay? Is that too loud if I talk? Okay. All right, thank you. I am not a software guy. All right. I am, on the other hand, I am instead a hardware kind of guy because there we go. Thank you. Whether it was made in the 80s or recently, you can still take it apart generally with the right set of screwdrivers. And even if you start putting things together with 3-lobe screwdrivers or 5-lobe screwdrivers or what have you, you can still take it apart. Because this, if you can put it together, I can take it apart. Let's see if I can go into my presentation. There we go. All right. So that's the title of the presentation. I've got some visual aids over here, and I'm wireless, so I can walk over here. Okay. So as I generally do before any time I do a presentation, is there grumbling? Okay. I'm going to challenge the audience. If I can hear your phone go bleep or bloop or then you're going to have to come up here after I'm done and do the unload button. So, and also that also counts if I hear you snoring. So somebody wake up Buggie and make sure that yeah.
Just tap him on the shoulder.
Yeah, I know it's what, day 3,
I'll watch out.
day 4 for some people, depending on how many hours of sleep you got. So, and it's just about dinner time. So I'm going to go pretty fast. And so the M0100, the Apple mouse that most of us in the Apple II world, the retro Apple world are familiar with, is this guy here, or you can see it up there. I do fancy stuff. So you're familiar with this, big blocky chamfered edges and big chunky button that makes a nice, good, solid click. I'm very familiar with this mouse. You might even call it an obsession. And you'll understand why when I get further down to it, why I have to have so many of these things, and why you may have lost out to me on some inexpensive auctions on eBay recently for any number of these. I usually once I had a good collection, I basically stopped bidding anything that was more than like $15 or $20 for shipping. So I got all the cheap ones. I got all the low-hanging fruit. So mouses, how do they work? There it is. False. So Quinn was explaining the software side of things with having to use interrupt to detect where the mouse was, whether it was moving in what direction. And this is the hardware side of it, and this is why. So inside of the mouse, you rotate the ball as you're dragging it across the surface. The ball rotates a little wheel that has perforations in it, and there's an infrared light on one side of it and a sensor on the other side. So as the wheel goes around, you're moving the mouse. It's producing a square wave of on, off, on, off, on, off, as it's detecting that light. Problem is, it's still 1, 0, 1, 0, 1, 0, regardless of which way you read it. So you could be moving left, moving right. The ones and zeros are still the same pattern. So you can tell that the mouse is moving in that axis, but not in what direction. So you add another beam slightly offset from the other. So you get, in combination, these two waves will give you 1, 1, 0, 1, 1, 0, 0, 0, and a pattern of 4 2-bit numbers. And you can see, so this one's on, and then it's off, and then this one comes off. So they're not exactly in sync. They're doing this. I like the hand puppets. Okay. So when you look at it up close, you get, as you're reading across, so the mouse is moving. It's giving you these signals on 2 pins of off on, off off, off on. No, I missed that one. But anyhow, so you get a different pattern if you're going backwards or you're going forwards. And I'm going to take just a second to set my display here so that I can see my notes, because there are some places where I have, yeah, there we go. Okay, so you get off on, off, off. Okay, so the mouse is moving in this direction, and you get, when this one is high, you read if this one's high. And you have an interrupt saying, this one just went high. What's this one doing? It's high. Okay. So that means I'm moving this direction. So next interrupt, this one just went high again, but this time I'm going this direction. So it went high. So what's the second line doing? It's low. So that means I'm going that direction. So with one interrupt and a listener, you can tell what direction it's moving, and then how often that happens, how fast it's moving. Does everybody kind of grok that? Okay, you guys part of the binary folks. So so this of course all has no bearing at all on the rest of my presentation, but I thought you all should know it, so now you know how mice work. But really, it does have some bearing, of course. So the M100, we all know and love, beige and brown, released in 1984, along with the first Macintosh, the 128K. So this is also the same mouse that you'll generally find if you are an Apple II collector or an Apple II user, because it's compatible with most of the Apple IIs. So that's the M100. So this is the inside of it, or this is the back of it. So based on what I could gather of the ones that I found and the ones that I saw, photos of online. So this is the where it was made, year it was made, week, and then model number, and then the serial number. So this was made in 22nd week of 1984. in wherever G was. Well, made in the USA, but which production line, whatever. So, but look closely. Mysteries upon mysteries. Is this a 0? No. So that says MO100. See the difference between the zeros and the O? And if you actually scan that barcode, it comes back MO1000, not M0. So it's not an M0100. It's an MO100. I don't know if it's any bearing at all on history, but that's what it says. So this is the inside of it. So here's the nice big chunky clicky button, strain relief coming out the front, and then the capture for the mouse ball. So it's got the little wheels here. That is sort of the guide that keeps the mouse ball pressed against those two wheels, and then you can see the encoder. Yeah, the encoder here is that perforated wheel, and then those are the two little infrared lights, and the receivers are on the other side. So as you rotate it, boom, 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 clickety click, and your mouse is doing its thing. So this is early or mid '84, and this is another one from a little later in '84, and you can see the design's already changed. It's still the same body style, strain relief, big clicky button up set on this this sort of pedestal here. But you can see the chip that's actually encoding that that bit stream, which is, I forgot to mention, it's called a quadrature encoding because it has 4 states, and so you're listening for one of the 4 states. So there's the chip that's actually taking this, reading the 1s and 0s and actually sending it out at TTL, I think, level stuff. And there's a couple of resistor packs because they needed resistors there. So this is still an M0100. The outward appearance is pretty much the same as the other one. The emitters are actually encased now, so I'm guessing they may have had some problems with light leakage, getting jitter or something if you're on a a surface where there's a lot of horizontal light coming in underneath. Dust. Or dust. That too. And you can see the chip is no longer underneath here, and then it's the resistor packs instead of just the discrete resistors. And then the connector was this beauty here, big, big blocky, and it's actually just about this. This is about life size for these that connector. Because these thumb screws, I mean, you can really get a good grip on the thumb screws. And it's got on such a small package, it's actually got 3 embossed Apple logos. They spent some engineering trying to figure out where can we squeeze an Apple logo on the end of thumb screws, and how big can we make them so that logo is still legible. So Steve Jobs had some input on every aspect of that design for the Mac. So later that year, with the Apple IIc, because you're not going to ship a Mac with a mouse, but not the IIc with a mouse, the mouse IIc came out in this kind of package, and thanks for the link down there if anybody wants to read more about it. So the package has changed, a little bit slimmer, strain relief there, all one color. The button isn't quite as chunky. The edges are smoother, and it's the same color. It's the matching fog color of the original Apple IIc. Sleeker design underneath as well. So they've taken the 2 screws here that were holding this together, and now it's 1 screw underneath. And it's a different model number, A2M4015. And of course it gets a new connector, because why not? Slightly smaller and not quite as blunt an instrument. So that's still 1984. The Apple IIc came out. So this is 1985. So this is early 85, the M100. And still has the 2 screws here. And it's, again, model M0100 with the older body style. And then after the IIc came out, I think they retooled. So some of the production lines are doing the newer style body with the 1 screw down here. Again, still M0100. And that kind of happened somewhere in the middle of 1985 for still production line G. So this is the inside before. So you can see the mouse button is up on this pedestal, and you got a 6-pin connector here. And then again, the resistor packs keep changing, so it's now resistors, but the chip and all that's kind of still where it was. And then here's after middle of 1985. So it's all one board. The mouse button is actually on the board. So this is a 7-pin connector now, and this will all be relevant in the payoff part of this presentation. So now there's the spring for the button is here, and the button is actually on the board instead of separated. So it's probably easier to manufacture all in one line instead of having to put the button on and connect the wires and everything. The guide wheel is plastic instead of metal, so they probably had some issues with either static or just the fact that the metal would collect dunk faster. And then we get into 86, and so this is a M0100, but it's got a totally different kind of serial number. So this would have been released as it has A2E in it, A//E in the serial number. So that's clearly a different model if you're looking at serial numbers, but model number M0100 still. But whoa, that doesn't look like an M0100, but it is. It's the same body style as the mouse 2C with the 4015 number. And it's the fog color again. It's not, they haven't gone to platinum yet. So this is basically the Apple IIc mouse rebranded, repackaged as an M0100, new serial number, and similar innards to the 2C again. So button on the board. They keep changing the arrangement of resistors down there and the 7-pin connector there. So it would have been sold like this as an Apple Mouse 2. And the picture on the box doesn't necessarily reflect the mouse that's in the box. It depends on what part of the year it was and which one they threw in. I've found several references to both styles, same serial numbers, et cetera, et cetera. Or it would have been this one, which is an A2M 2070. And so there's the top of the A2M 2070 packaged as Apple Mouse 2E. Can you go back to the serial number on that? This one, yeah. Yeah, it's a different serial number range. I imagine it would be A2M 2070 144. Yeah, because they took before it was the M0100 and then the string. Yeah, so if I haven't been able to decode that one as far as the data manufacturer unless the 6 is relevant, but I don't have enough of that as I don't have enough of this kind to look at the serial numbers and see what the code is.
There's 86 right there in the middle.
Yeah, but so it's back to the two-tone blocky design, but this time it's in platinum to match the new Platinum 2E and the Mac Plus, all new for 86. So, and then the insides again look like the one-tone 2C mouse. Oh, I'm going through by years. So 87, they moved the manufacturing to Japan. It was still an M0100, though this time it's actually M0100. If you look at the barcode, it's a 0 here, not an O. So 000. And the manufacturer is, the production line is M, signifying it's no longer in the G. It's in it's in the Japan plant. And again, it's the 2 screws at the top and the wider cable, and then the insides are changed a little bit. So the strain relief has changed. The cable is actually going around here instead of kind of going, and probably just for interference sake for when they're assembling it. The wheels are metal. The resistors have changed a little bit, and then there's capacitors here. It just, they keep making revisions, but there's no indication outside to say this is a revision 7 or a revision 6 or whatever, M0100 or M0100. The cable here is soldered on instead of a socket. You can't pull that off. Those are machine inserted, I think. And And then I think this is still 87. This is the oldest one I have. Is actually 89, made in Malaysia, still M0100. And then the innards are pretty much very similar to the Japanese one from 2 years earlier. Again, the machine inserted, so it's not a, you can't desocket that, and the strainer leaf is all the same. So I'm not going to really talk much about the whole mystery of is it MO100, M0100. The naming scheme is when the Macintosh came out, it was M0001. The keyboard was M0010, and then the mouse was M0100. Except if you actually look at the barcode, it's MO101. So all of that condenses into a chart. I'm going to post all this later, so if you want to high res and print it out for reference, whatever. But why?
Why?
Why this obsession with this mouse? Well, you may know me as the retro connector guy.
Oh, that's you?
That's me. So part of what I did originally was get a couple of these in different different iterations with the smooth design and the chunky design, so that I could model it in 3D. Because I'm also the guy that does the 3D models of the little tiny computers. So that I could have a quarter scale mouse to go along with my quarter scale 2D. And that's all well and good. I mean, the thing's tiny. You lose it when you sneeze. So I went in and modeled the whole thing. And it has this really fun locking mechanism on the bottom to keep the ball in place. So that's kind of cool. But it also means that if you have a mouse that has a missing ball or locking thing, you have this gaping hole in the bottom of it. And so that got me thinking, what if I put something in there? And you've probably seen instructables online or things online where people took an old mouse, ripped the guts out, and put the guts of a new optical mouse in it. And so you've got a retro-looking optical mouse. And I've even done a couple of those conversions myself. It's, it's ridiculously easy. So I'm going to drop out of Keynote here for a second and show you a very quick demo in 123D Design. How am I for time, by the way? I know I've been rushing through. Just killed the 80s, so I'm good. So dinner at Rocker's in 24 minutes, according to my calendar. Anyhow, so if I go and open up my 0100 model, you'll see that I've got the hole here kind of plugged up with this blue thing. So this is a blue piece that's, oh, why are you not seeing my screen? Oh, screen mirror off. Never mind. It would have been terrible. It would just blow your mind. Anyhow, okay. So here's the inside of a very roughly sketched out inside of the M0100 mouse. And so this blue piece here is plugging up that hole in the bottom. And it's got this strange indent in it for, let me see where my tools have hidden themselves. This is the lens for an optical mouse sensor. There's the sensor itself, and there's a PCB. And because this is all taking up a whole lot less space than the guts of an original, I have to put this big, again, this blue part here, this big shim here to hold up the hinge. So that takes place of, this big chunky black plastic part. And the circuit board, it didn't have to be round, but I could, so I did. And so the result is a little board like that, wafer thin. And the reason it works is because of a little chip like that that is an optical mouse sensor with USB interface built onto the chip. It's 8 pins and it's tiny, and it goes in those little novelty mice that come on keychains or that have the little retracting zippy USB cables that, you know, if you've ever gone to a convention, you've probably gotten 3 or 4 of them with different people's logos on them. So end result, I've got a little circuit board, sensor, cable from the original mouse, LED, et cetera, et cetera. And so here it is, living, breathing, little, you see the little LED blinking on there? And yes, it works.
I know, thanks.
Yeah. The other side of the equation, let's say you have a dead mouse. This board is broken. You're missing the little locking thing in the ball, and all you've got is the plastic shell. This will work great. So you've got the shim that goes in there, USB interface board, and it comes out to, well, it would have come out to something like that, ideally. So then you have to adapt 4 of those pins to the USB. So you get a little dongle like that. So your 9-pin connector goes in here, becomes a USB connector, a little dongle, and you've got your mouse ready to go. Or like this one, somebody, when they sold it, before they put it on eBay, it had lost its cable. It had been cut off. And so it was tailless. Somebody cut the tail off the mouse. So I put a USB cable on there. So if you have one that's missing a cable, missing guts, or just generally broken, it can be, we have the technology, we can make it better, stronger, faster. Or if you have a working mouse, if you've got one that you're perfectly happy with, and you want to keep it intact, but you still want to use it on a modern system, here is a dongle to USB, and yes, it works. Using the original ball and rolling mechanism, et cetera, et cetera. One button, so you're going to have to hold down control to get right click. All of this and more available at your local Retro Connector store. And I thank you for no phones going off and no snoring. So nobody has to do the chicken dance, or I'm a little teapot. Any questions? And I'm sure you're hungry and or tired.
Does it fit every MO100? In other words, is that the point? Is that regardless of the 17 models you showed, it'll just work?
That is, that's why, yeah, I threw them on the floor probably. The bits and pieces inside will actually fit the first models that have the button on the pedestal. And then there's another piece that goes in place where it's sort of a little piggyback for this board that will hold the button in place where it would normally be in the later model where the button is on the board. So why do I have to have so many? So I could get the spacing. Why did they change the design so many times? All I wanted to do is put a thing in there and say, if it's an M100 or M0100, you buy this thing, put it in, and it becomes a USB mouse. But I opened a second one up and, oh, it's in a different place. And then I opened up a third one and, again, a slightly different design in the spring. And so I've got all the parts and pieces to accommodate multiple different variations of the M and 100.
As you order, we tell you the model serial, you compute, and out comes the right.
The model that I foresee is, you send me a mouse, I will send it back to you either with the guts, removed, intact, whatever your order is, and then you get a working USB mouse, or You can just order the dongle if you have a working one. So if you have a broken one, you can send me the broken one. I'll get, replace the guts with, you'll have your bionic mouse. Sorry, there, other questions up here?
What about going the other way, from USB to the D9 or the USB ADB?
Yeah, no, not ADB. It's the quadrature or whatever. I'm working on that. I didn't have it done in time for KFest. I thought maybe that I'd be able to work on it here, but I've had so many other things to work on. So yes, it's in the works, and it'll be a dongle about like that. It'll have a little microcontroller in it to take that quadrature, or take the USB signal, and if it's moving, do the quadrature encoding, send it out to the pin the Apple's expecting. Send it out to the D9 for the Apple II. Which one?
Is
This one with the optical guts.
Yeah.
Mhm.
Is it lame to want a cable in the same color as the original?
It is not lame to want a cable in the same color as the original.
Is it possible?
It's probably possible because you can get USB accessories in a wide array of colors. This one just happened to be like 14 cents for a pile of them at mono price. So this cable, sacrificed its life, and it just happens to be the cheapest one that I could find in bulk and purchase. But yeah, if you really want to, I will go and find some.
Even go further.
Yeah, I could find some beige cables and call it the premium edition.
Oh, thank God.
For those of us on the end of a long shipping hill, can we just order these specific parts for the several mouses that we have?
Absolutely.
Okay.
Yeah, if you want to, if you are going to just buy the kit and assemble it yourself, then yeah, I'll sell you the board, whether it's populated or not. I mean, I haven't got it set up yet. I haven't actually started selling them on the website yet. But the idea is you can either get the kit, or you can get a fully assembled unit from my collection, or you can send me your broken one and I'll send it back to you with replaced guts. Yeah, and that'll probably be a lot cheaper to ship too than a 4-pound mouse. Yeah. I haven't decided on pricing yet. It's probably. The dongle to take a working mouse and make it a USB mouse is probably going to be, I think it ends up being about $25. That's the bulk of that price, to be honest, is the teensy microcontroller that's inside it, and the little enclosure is a couple bucks, and then the D9 is a couple bucks. So it ends up being, if you wanted to build it yourself, it'd be about $22. So I have to cover my expenses. So about 25 bucks for that. For this, it's probably going to be less because the 3D printed parts are small. I get these boards. They're if I get them from OSH Park, they're like $3 or $4 a piece. And then the chips and the lens are a couple dollars a piece. So I haven't actually done all the math yet because there's 2 or 3 printed parts and there's 2 or 3 different variations. So I'll have to do the math. If you order 100, I will have to get 100 made. So no. Yeah, you'll get the day after that. How's that? Yeah, you'll get it the day after I get them.
100?
Oh yeah, he was asking if he ordered 100, he'd get next day shipping.
In your research, it's really pretty impressive about all the mice. Do they all work with any Apple II, or do some not work with some Apple IIs? Yeah.
So the chart back here, for those who are interested, the original 84 Mac mouse. Okay, take your pictures. There you go. It'll be a PDF in about 5 minutes. The original 84 mice for the Mac works on the Mac. The 2C hadn't come out yet, so the Mac mouse doesn't necessarily work with the 2C. The 2C has a sense on one of the pins to see if there's a resistor there or not. And if there's a resistor there, it's a joystick. If it's not a resistor there, then it's a mouse. So they hadn't figured that part out yet for the original Mac mouse. So if you find one that's an early 84 M0100, it may or may not work with your Apple IIc. The 2C mouse will work with the 2C. It's probably also going to work with the Mac because that pin is just grounded or not grounded. It's not a signal. The A2M 2050 mouse 2 for the Apple IIe works with the Mac and the 2e, but doesn't necessarily work with the 2C because it doesn't necessarily have that sense pin. Because they were selling the 2C mouse separately because it had the separate design, smoother design for the 2C. Later on, when they combined all of these and fixed the the blunt instrument issue and refined the body style from the 2 screws to the 1 screw, it'll work with Mac 2e and 2C, from what I've found online. And we know how reliable Wikipedia is. I assembled all of this from Wikipedia, from Shrine of Apple, from A2 Central, from all the places that have Apple II history, and most of them agree on most of the points. But the compatibility with the 2C is, well, maybe. And I think the definitive answer will be if you plug it in and it doesn't blow up. No, if you actually test the signal on, test the continuity on pin 1, if it is shorted to ground or continuous with pin 3, because they're both ground, with no resistance, then it will work with the 2C.
Do you know, or do you know if anyone knows why the original Mac one wouldn't also work on a 2E?
I'm sure it was because, well, I'm sure it was because the Mac team was sequestered over here, and the guys designing the Mac mouse had a deadline to meet, and they didn't necessarily talk to the 2C guys that were coming out and to be honest, the 2C guys probably had the mouse forced on them and said, well, how are we we can't add another port for the mouse. We're going to have to combine it with the joystick. So,
well, I meant the 2E, but the point still holds.
Well, the Mac mouse may be compatible with the 2E with a mouse card. Yeah, because when I say 2E, it's the mouse card. But the 2E, the mouse card came out late enough that it probably is compatible with anything that's compatible with the 2C or the Mac. Sorry, I thought you were talking about this. The 2E mouse card doesn't have any. I don't think it has any issue with whether it's. Yeah, it doesn't. It's expecting a mouse, not a joystick. But I don't know that for certain because all the compatibility stuff was talking about the 2C.
So if I read the chart right, anything made after 1985 is compatible around all of them.
Should be, yes. Asterisk. Wikipedia gets stuff wrong. Because internet. Yes. Anything else before I get swept off?
Thank you.
Thank you.
Oh, the ADB mouse? If you can see my to-do list, it's on my to-do list. ADB is on my to-do list. Luckily, ADB, I don't have to worry too much about the innards of that mouse so much as the innards of the serial mouse. So thank you, and I will see you at dinner.
Before everybody gets up, we have something special to share with you. So I'm going to turn it over to Steve.
All right. Could we have Rebecca come up, please? Rebecca, keynote speaker. So we intended to do this when you had your speech, but forgot to have it available. Each year when we have our keynote speaker here for the last few years, we've been wanting to recognize them with an award that we call the Apple II Forever Award, in recognition of all of your contributions to the community and the Apple II in history. So this is for you.
Thank you.
You deserve it. Thank you for cracking all that software for us.
That's
And also that stuff will rub.
That too. Thank you. Thank you.
Thank you.
I don't know what to say other than thanks.
Speech.
Sorry it's not an Atari 800. I just never thought I'd get anything like this, to be quite frank. So, thank you.
All right, dinner.
Oh, if anybody is intending to or able to loan me machines for the demo for Friday afternoon, I need. I'm looking for 8 machines, preferably something like a 2C with a built-in serial card or a 2E with a super serial card. And if you have a serial cable that works with ADP Pro, that would be great too. I'm hoping to have 8 machines going all at once. You'll see on Friday. And some of you have already said that you would, so thanks. Just find me probably Friday at lunch, and I'll be collecting them and testing and make sure that everything has worked. So thank you for volunteering, and thank you for anybody who has yet to volunteer in advance.
I don't know what's wrong with me, but I really enjoy seeing all the information about the different models and what something you said. Yeah, that's it.